Chapter 19. Theories of volcanic and earthquake action. Though the first formation of a volcano, Italian, volcano, from Vulcan, the Roman god of fire, has seldom been witnessed, it would seem that it is marked by earthquake movements followed by the opening of a rent or fissure. But with no such tilting up of the rocks as was once supposed to take place. From this fissure large volumes of steam issue, accompanied by hydrogen, nitrogen, carbon dioxide, hydrochloric acid, and sulfur dioxide. The hydrogen, apparently derived from the dissociation of water at a high temperature, flashes explosively into union with atmospheric oxygen, and, having exerted its explosive force, the steam condenses into cloud, heavy masses of which overhang the volcano, pouring down copious rains. This naturally disturbs the electrical condition of the atmosphere, so that thunder and lightning are frequent accompaniments of an eruption. The hydrochloric acid probably points to the agency of seawater. Besides the gases just mentioned, sulfur and hydrogen, ammonia and common salt occur. But mainly as secondary products, formed by the union of the vapors issuing from the volcano, and commonly found also in the vapors rising from cooling lava streams or dormant volcanic districts. It is important to notice that the vapors issue from the volcano spasmodically, explosions succeeding each other with great rapidity and noise. All substances thrown out by the volcano, whether gaseous, liquid or solid, are conveniently united under the term ejectamenta, Latin, things thrown out, and all of them are in an intensely heated, if not an incandescent state. Most of the gases are incombustible, but the hydrogen and those containing sulfur burn with a true flame, perhaps rendered more visible by the presence of solid particles. Much of the so-called flame, however, in popular descriptions of eruptions is an error of observation due to the red-hot solid particles and the reflection of the glowing orifice on the overhanging clouds. Enormous force displayed. Solid bodies are thrown into the air with enormous force and to proportionally great heights, those not projected vertically falling in consequence at considerable distances from the volcano. A block weighing 200 tons is said to have been thrown 9 miles by Cotopaxi. Masses of rock weighing as much as 20 tons to have been ejected by Mount Ararat in 1840, and stones to have been hurled to a distance of 36 miles in other cases. The solid matter thrown out by volcanoes consists of lapilli, scoriae, dust, and bombs. Though on the first formation of the volcano, masses of non-volcanic rock may be torn from the chimney or pipe of the mountain, only slightly fused externally owing to the bad conducting power of most rocks, and hurled to a distance. And though at the beginning of a subsequent eruption the solid plug of rock which has cooled at the bottom of the crater, or, in fact, any part of the volcano, may be similarly blown up, the bulk of the solid particles of which the volcano itself is composed is derived from the lake of lava or molten rock which seethes at the orifice. Solid pieces rent from this fused mass and cast up by the explosive force of the steam with which the lava is saturated are known as lapilli. Cooling rapidly so as to be glassy in texture externally, these often have time to become perfectly crystalline within. Gases and steam escaping from other similar masses may leave them hollow, when they are termed bombs, or may pit their surfaces with irregular bubble cavities, when they are called scoriae or scoriaceous. Such masses whirling through the air in a plastic state often become more or less oblately spheroidal in form. But, as often, the explosive force of their contained vapors shatters them into fragments, producing quantities of the finest volcanic dust or sand. This fine dust darkens the clouds overhanging the mountain, mixes with the condensed steam to fall as a black mud rain, or lava di acqua, Italian, water lava, or is carried up to enormous heights, and then slowly diffused by upper currents of the atmosphere. In the eruption of Vesuvius of AD 79, the air was dark as midnight for 12 or 15 miles round. The city of Pompeii was buried beneath a deposit of dry scoriae, or ashes, and dust, and Herculaneum beneath a layer of the mud-like lava di acqua, which on drying sets into a compact rock. Rocks formed from these fragmentary volcanic materials are known as tuff. Volcanic cones have similar curvatures. It is entirely of these cindery fragments heaped up with marvelous rapidity round the orifice that the volcano itself is first formed. It may, as in the case of Jorullo in Mexico in 1759, form a cone several hundred feet high in less than a day. Such a cone may have a slope as steep as 30 or 40 degrees, its incline in all cases depending simply on the angle of repose of its materials, the inclination, that is, at which they stop rolling. The great volcanoes of the Andes, which are formed mainly of ash, are very steep. Owing to a general similarity in their materials, volcanic cones in all parts of the world have very similar curvatures. But older volcanic mountains, in which lava streams have broken through the cone, secondary cones have arisen, or portions have been blown up, are more irregular in outline and more gradual in inclination. In size, volcanoes vary from mere mounds a few yards in diameter, such as the Salzas or mud volcanoes near the Caspian, to Etna, 10,800 feet high, with a base 30 miles in diameter. Cotopaxi, in the Andes, 18,887 feet high, or Mauna Loa, in the Sandwich Isles, 13,700 feet high, with a base 70 miles in diameter, and 2 craters, one of which, Kilauea, the largest active crater on our Earth, is 7 miles in circuit. Larger extinct craters occur in Japan, but all our terrestrial volcanic mountains are dwarfed by those observed on the surface of the Moon, which, owing to its smaller size, has cooled more rapidly than our Earth. It is, of course, the explosive force from below which keeps the crater clear, as a cup-shaped hollow, truncating the cone, and all stones falling into it would be only thrown out again. It may at the close of an eruption cool down so completely that a lake can form within it, such as Lake Averno, near Naples. Or it may long remain a seething sea of lava, such as Kilauea. Or the lava may find one or more outlets from it, either by welling over its rim, which it will then generally break down, as in many of the small extinct volcanoes, Puys, of Auvergne, or more usually by bursting through the sides of the cone. Lava varies very much in liquidity. It is not generally until the volcano has exhausted its first explosive force that lava begins to issue. Several streams may issue in different directions. Their dimensions are sometimes enormous. Lava varies very much in liquidity and in the rate at which it flows. This much depends, however, upon the slope it has to traverse. A lava stream at Vesuvius ran 3 miles in 4 minutes, but took 3 hours to flow the next 3 miles, while a stream from Mauna Loa ran 18 miles in 2 hours. Glowing at first as a white-hot liquid, the lava soon cools at the surface to red and then to black. Cinder-like scoriaceous masses form on its surface and in front of the slowly advancing mass. Clouds of steam and other vapor rise from it, and little cones are thrown up from its surface, but many years may elapse before the mass is cooled through. Thus, while the surface is glassy, the interior becomes crystalline. As to what are the causes of the great convulsions of nature known as the volcano and the earthquake, we know very little. Various theories have been advanced, but nothing by any means sure has been discovered, and considerable difference of opinion exists. In truth, we know so little concerning the conditions existing in the Earth's interior that any views concerning the forces at work there must necessarily be largely conjectural. Sir Robert S. Ball says, in this connection, let us take, for instance, that primary question in terrestrial physics, as to whether the interior of the Earth is liquid or solid. If we were to judge merely from the temperatures reasonably believed to exist at a depth of some 20 miles, and if we might overlook the question of pressure, we should certainly say that the Earth's interior must be in a fluid state. It seems at least certain that the temperatures to be found at depths of 20 miles, and still more at greater depths, must be so high that the most refractory solids, whether metals or minerals, would at once yield if we could subject them to such temperatures in our laboratories. But none of our laboratory experiments can tell us whether, under the pressure of thousands of tons on the square inch, the application of any heat whatever would be adequate to transform solids into liquids. It may, indeed, be reasonably doubted whether the terms solid and liquid are applicable, in the sense in which we understand them, to the materials forming the interior of the Earth. A principle, already well known in the arts, is that many, if not all, solids may be made to flow like liquids if only adequate pressure be applied. The making of lead tubes is a well-known practical illustration of this principle, for these tubes are formed simply by forcing solid lead by the hydraulic press through a mold which imparts the desired shape. If then a solid can be made to behave like a liquid, even with such pressures as are within our control, how are we to suppose that the solids would behave with such pressures as those to which they are subjected in the interior of the earth? The fact is that the terms solid and liquid, at least as we understand them, appear to have no physical meaning with regard to bodies subjected to these stupendous pressures, and this must be carefully borne in mind when we are discussing the nature of the interior of the earth. The volcano is safety valve. Whatever be the state of affairs in the depths of the earth's crust, we may look upon the volcano as a sort of safety valve, opening a passage for the pent-up forces to the surface, and thus relieving the earth from the terrible effects of the earthquake, through which these imprisoned powers so often make themselves felt. Without the volcanic vent there might be no safety for man on the earth's unquiet face. Professor J.C. Russell, of Michigan University, presents the following views concerning the status and action of volcanoes. When reduced to its simplest terms, a volcano may be defined as a tube, or conduit, in the Earth's crust, through which the molten rock is forced to the surface. The conduit penetrates the cool and rigid rocks forming the superficial portion of the Earth, and reaches its highly heated interior. The length of volcanic conduits can only be conjectured, but, judging from the approximately known rate of increase of heat with depth, on an average 1 degree Fahrenheit for each 60 feet, and the temperature at which volcanic rocks melt, from 2,300 to 2,700 degrees Fahrenheit, when not under pressure, they must seemingly have a depth of at least 20 miles. There are other factors to be considered, but in general terms it is safe to assume that the conduits of volcanoes are irregular openings, many miles in depth, which furnish passageways for molten rock, lava, from the highly heated subcrust portion of the Earth to its surface. Eruptions of quiet type. During eruptions of the quiet type, the lava comes to the surface in a highly liquid condition, that is, it is thoroughly fused, and flows with almost the freedom of water. It spreads widely, even on a nearly level plain, and may form a comparatively thin sheet several hundred square miles in area, as has been observed in Iceland and Hawaii. On the Snake River Plains, in southern Idaho, there are sheets of once molten rock which were poured out in the manner just stated, some 400 square miles in area and not over 75 feet in average thickness. When an eruption of highly liquid lava occurs in a mountainous region, the molten rock may cascade down deep slopes and flow through narrow valleys for 50 miles or more before becoming chilled sufficiently to arrest its progress. Instances are abundant where quiet eruptions have occurred in the midst of a plain, and built up lava cones, or low mounds, with immensely expanded bases. Illustrations are furnished in southern Idaho, in which the cones formed are only 300 or 400 feet high, but have a breadth at the base of 8 or 10 miles. In the class of eruption illustrated by these examples, there is an absence of fragmental material, such as explosive volcanoes hurl into the air, and a person may stand within a few yards of a rushing stream of molten rock, or examine closely the opening from which it is being poured out, without danger or serious inconvenience. The quiet volcanic eruptions are attended by the escape of steam or gases from the molten rock, but the lava being in a highly liquid state, the steam and gases dissolved in it escape quietly and without explosions. If, however, the molten rock is less completely fluid, or in a viscous condition, the vapors and gases contained in it find difficulty in escaping, and may be retained until, becoming concentrated in large volume, they break their way to the surface, producing violent explosions. Volcanoes in which the lava extruded is viscous, and the escape of steam and gases is retarded until the pent-up energy bursts all bounds, are of the explosive type. One characteristic example is Vesuvius. When steam escapes from the summit of a volcanic conduit which, in plain terms, is a tall vessel filled with intensely hot and more or less viscous liquid, masses of the liquid rock are blown into the air, and on falling build up a rim or crater about the place of discharge. Commonly the lava in the summit portion of a conduit becomes chilled and perhaps hardened. And when a steam explosion occurs, this crust is shattered and the fragments hurled into the air and contributed to the building of the walls of the enclosing crater. The solid rock blown out by volcanoes consists usually of highly vesicular material which hardened on the surface of the column of lava within a conduit and was shattered by explosions beneath it. These fragments vary in size from dust particles up to masses several feet in diameter, and during violent eruptions are hurled miles high. The larger fragments commonly fall near their place of origin, and usually furnish the principal part of the material of which craters are built. But the gravel-like kernels, lapilli, may be carried laterally several miles if a wind is blowing, while the dust is frequently showered down on thousands of square miles of land and sea. The solid and usually angular fragments manufactured in this manner vary in temperature, and may still be red-hot on falling. Volcanoes of the explosive type not uncommonly discharge streams of lava, which may flow many miles. In certain instances, these outwellings of liquid rock occur after severe earthquakes and violent explosions, and may have all the characteristics of quiet eruptions. There is thus no fundamental difference between the two types into which it is convenient to divide volcanoes. Mountains blow their heads off. In extreme examples of explosive volcanoes, the summit portion of a crater, perhaps several miles in circumference and several thousand feet high, is blown away. Such an occurrence is recorded in the case of the volcano Cozgana, Nicaragua, in 1835. Or, an entire mountain may disappear, being reduced to lapilli and dust and blown into the air, as in the case of Krakatoa, in the Straits of Sunda, in 1883. The essential feature of a volcano, as stated above, is a tube or conduit, leading from the highly heated subcrust portion of the earth to the crater and through which molten rock is forced upward to the surface. The most marked variations in the process depend on the quantity of molten rock extruded, and on the freedom of escape of the steam and gases contained in the lava. The cause of the rise of the molten rock in a volcano is still a matter for discussion. Certain geologists contend that steam is the sole motive power, while others consider that the lava is forced to the surface owing to pressure on the reservoir from which it comes. The view perhaps most favorably entertained at present, in reference to the general nature of volcanic eruptions, is that the rigid outer portion of the earth becomes fractured, owing principally to movements resulting from the shrinking of the cooling inner mass, and that the intensely hot material reached by the fissures, previously solid owing to pressure, becomes liquid when pressure is relieved, and is forced to the surface. As the molten material rises, it invades the water-charged rocks near the surface and acquires steam, or the gases resulting from the decomposition of water, and a new force is added which produces the most conspicuous and at times the most terrible phenomena accompanying eruptions. The active agency of water is strongly maintained by many geologists, and certainly gains support from the vast clouds of steam given off by volcanoes in eruption and the steady and quiet emission of steam from many in a state of rest. The quantities of water in the liquid state, to which is due the frequent enormous outflows of mud, leads to the same conclusion. Many scientists, indeed, while admitting the agency of water, look upon this as the aqueous material originally pent up within the rocks. For instance, Professor Shaler, dean of the Lawrence Scientific School, says, "Volcanic outbreaks are merely the explosion of steam under high pressure. Steam which is bound in rocks buried underneath the surface of the earth and there subjected to such tremendous heat that when the conditions are right its pent-up energy breaks forth and it shatters its stone prison walls into dust. The process by which the water becomes buried in this manner is a long one. Some contend that it leaks down from the surface of the earth through fissures in the outer crust, but this theory is not generally accepted. The common belief is that water enters the rocks during the crystallization period, and that these rocks through the natural action of rivers and streams become deposited in the bottom of the ocean. Here they lie for many ages, becoming buried deeper and deeper under masses of like sediment, which are constantly being washed down upon them from above. This process is called the blanketing process. Each additional layer of sediment, while not raising the level of the sea bottom, buries the first layers just so much the deeper and adds to their temperature just as does the laying of extra blankets on a bed. When the first layer has reached a depth of a few thousand feet, the rocks which contain the water of crystallization are subjected to a terrific heat. This heat generates steam, which is held in a state of frightful tension in its rocky prison. Wrinklings in the outer crust of the Earth's surface occur, caused by the constant shrinking of the Earth itself and by the contraction of the outer surface as it settles on the plastic centers underneath. Fissures are caused by these foldings, and as these fissures reach down into the Earth, the pressure is removed from the rocks and the compressed steam in them, being released, explodes with tremendous force. This view is, very probably, applicable to many cases. And the exceedingly fine dust which so often rises from volcanoes has, doubtless, for one of its causes the sudden and explosive conversion of water into steam in the interior of ejected lava, thus rending it into innumerable fragments. But that this is the sole mode of action of water in volcanic eruptions is very questionable. It certainly does not agree with the immense volumes at times thrown out. While explosions of such extreme intensity as that of Krakatoa very strongly lead to the conclusion that a great mass of water has made its way through newly opened fissures to the level of molten rock, and exploded into steam with a suddenness which gave it the rending force of dynamite or the other powerful chemical explosives. As the earthquake is so intimately associated with the volcano, the causes of the latter are in great measure the causes of the former. And the forces at work frequently produce a more or less violent quaking of the Earth's surface before they succeed in opening a channel of escape through the mountain's heart. One agency of great potency, and one whose work never ceases, has doubtless much to do with earthquake action. In the description of this we cannot do better than to quote from The Earth's Beginning, of Sir Robert S. Ball. Cause of earthquakes. As to the immediate cause of earthquakes, there is no doubt considerable difference of opinion. But I think it will not be doubted that an earthquake is one of the consequences, though perhaps a remote one, of the gradual loss of internal heat from the Earth. As this terrestrial heat is gradually declining, it follows from the law that we have already so often had occasion to use that the bulk of the Earth must be shrinking. No doubt the diminution in the Earth's diameter due to the loss of heat must be exceedingly small, even in a long period of time. The cause, however, is continually in operation, and, accordingly, the crust of the Earth has from time to time to be accommodated to the fact that the whole globe is lessening. The circumference of our Earth at the equator must be gradually declining, a certain length in that circumference is lost each year. We may admit that loss to be a quantity far too small to be measured by any observations as yet obtainable, but, nevertheless, it is productive of phenomena so important that it cannot be overlooked. It follows from these considerations that the rocks which form the Earth's crust over the surface of the continents and the islands, or beneath the bed of the ocean, must have a lessening acreage year by year. These rocks must therefore submit to compression, either continuously or from time to time, and the necessary yielding of the rocks will in general take place in those regions where the materials of the Earth's crust happen to have comparatively small powers of resistance. The acts of compression will often, and perhaps generally, not proceed with uniformity, but rather with small successive shifts. And even though the displacements of the rocks in these shifts be actually very small, yet the pressures to which the rocks are subjected are so vast that a very small shift may correspond to a very great terrestrial disturbance. Suppose, for instance, that there is a slight shift in the rocks on each side of a crack, or fault, at a depth of 10 miles. It must be remembered that the pressure 10 miles down would be about 35 tons to the square inch. Even a slight displacement of one extensive surface over another, the sides being pressed together with a force of 35 tons on the square inch, would be an operation necessarily accompanied by violence greatly exceeding that which we might expect from so small a displacement if the forces concerned had been of more ordinary magnitude. On account of this great multiplication of the intensity of the phenomenon, merely a small rearrangement of the rocks in the crust of the Earth, in pursuance of the necessary work of accommodating its volume to the perpetual shrinkage, might produce an excessively violent shock, extending far and wide. The effect of such a shock would be propagated in the form of waves through the globe, just as a violent blow given at one end of a bar of iron by a hammer is propagated through the bar in the form of waves. When the effect of this internal adjustment reaches the Earth's surface, it will sometimes be great enough to be perceptible in the shaking it gives that surface. The shaking may be so violent that buildings may not be able to withstand it. Such is the phenomenon of an earthquake. When the Earth is shaken by one of those occasional adjustments of the crust which I have described, the wave that spreads like a pulsation from the center of agitation extends all over our globe and is transmitted right through it. At the surface lying immediately over the center of disturbance there will be a violent shock. In the surrounding country, and often over great distances, the earthquake may also be powerful enough to produce destructive effects. The convulsion may also be manifested over a far larger area of country in a way which makes the shock to be felt, though the damage wrought may not be appreciable. But beyond a limited distance from the center of the agitation, the earthquake will produce no destructive effects upon buildings, and will not even cause vibrations that would be appreciable to ordinary observation. The radius of disturbance. In each locality in which earthquakes are chronic, it would seem as if there must be a particularly weak spot in the Earth some miles below the surface. A shrinkage of the Earth, in the course of the incessant adjustment between the interior and the exterior, will take place by occasional little jumps at this particular center. The fact that there is this weak spot at which small adjustments are possible may provide, as it were, a safety valve for other places in the same part of the world. Instead of a general shrinking, the materials would be sufficiently elastic and flexible to allow the shrinking for a very large area to be done at this particular locality. In this way we may explain the fact that immense tracts on the Earth are practically free from earthquakes of a serious character, while in the less fortunate regions the earthquakes are more or less perennial. Now, suppose an earthquake takes place in Japan. It originates a series of vibrations through our globe. We must here distinguish between the rocks, I might almost say the comparatively pliant rocks which form the Earth's crust, and those which form the intensely rigid core of the interior of our globe. The vibrations which carry the tidings of the earthquake spread through the rocks on the surface, from the center of the disturbance, in gradually enlarging circles. We may liken the spread of these vibrations to the ripples in a pool of water which diverge from the spot where a raindrop has fallen. The vibrations transmitted by the rocks on the surface, or on the floor of the ocean, will carry the message all over the Earth. As these rocks are flexible, at all events by comparison with the Earth's interior, the vibrations will be correspondingly large, and will travel with vigor over land and undersea. In due time they reach, say, the Isle of Wight, where they set the pencil of the seismometer at work. But there are different ways round the Earth from Japan to the Isle of Wight, the most direct route being across Asia and Europe, the other route across the Pacific, America, and the Atlantic. The vibrations will travel by both routes, and the former is the shorter of the two. Transmissions of vibrations. Some brief repetition may not here be amiss as to the products of volcanic action, of which so much has been said in the preceding pages, especially as many of the terms are to some extent technical in character. The most abundant of these substances is steam or water gas, which, as we have seen, issues in prodigious quantities during every eruption. But with the steam a great number of other volatile materials frequently make their appearance. Though we have named a number of these at the beginning of this chapter, it will not be out of order to repeat them here. The chief among these are the acid gases known as hydrochloric acid, sulfurous acid, sulfur at hydrogen, carbonic acid, and boracic acid, and with these acid gases there issue hydrogen, nitrogen, ammonia, the volatile metals arsenic, antimony, and mercury, and some other substances. These volatile substances react upon one another, and many new compounds are thus formed. By the action of sulfurous acid and sulfur at hydrogen on each other, the sulfur so common in volcanic districts is separated and deposited. The hydrochloric acid acts very energetically on the rocks around the vents, uniting with the iron in them to form the yellow ferric chloride, which often coats the rocks round the vent and is usually mistaken by casual observers for sulfur. Some of the substances emitted by volcanic vents, such as hydrogen and sulfur at hydrogen, are inflammable, and when they issue at a high temperature these gases burst into flame the moment that they come into contact with the air. Hence, when volcanic fissures are watched at night, faint lambent flames are frequently seen playing over them, and sometimes these flames are brilliantly colored, through the presence of small quantities of certain metallic oxides. Such volcanic flames, however, are scarcely ever strongly luminous, and the red, glowing light which is observed over volcanic mountains in eruption is due to quite another cause. What is usually taken for flame during a volcanic eruption is simply, as we have before stated, the glowing light of the surface of a mass of red-hot lava reflected from the cloud of vapor and dust in the air, much as the lights of a city are reflected from the water vapor of the atmosphere during a night of fog. Besides the volatile substances which issue from volcanic vents, mingling with the atmosphere or condensing upon their sides, there are many solid materials ejected, and these may accumulate around the orifice till they build up mountains of vast dimensions, like Etna, Tenerife, and Chimborazo. Some of these solid materials are evidently fragments of the rock masses, through which the volcanic fissure has been rent. These fragments have been carried upwards by the force of the steam blast and scattered over the sides of the volcano. But the principal portion of the solid materials ejected from volcanic orifices consists of matter which has been extruded from sources far beneath the surface, in highly heated and fluid or semi-fluid condition. It is to these materials that the name of lavas is properly applied. Lavas present a general resemblance to the slags and clinkers which are formed in our furnaces and brick kilns, and consist, like them, of various stony substances which have been more or less perfectly fused. When we come to study the chemical composition and the microscopical structure of lavas, however, we shall find that there are many respects in which they differ entirely from these artificial products, they consisting chiefly of felspar, or of this substance in association with augite or hornblende. In texture they may be stony, glassy, resin-like, vesicular, or cellular and light in weight, as in the case of pumice or scoria. Floating pumice. The steam and other gases rising through liquid lava are apt to produce bubbles, yielding a surface froth or foam. This froth varies greatly in character according to the nature of the material from which it is formed. In the majority of cases the lavas consist of a mass of crystals floating in a liquid magma, and the distension of such a mass by the escape of steam from its midst gives rise to the formation of the rough cindery-looking material to which the name of scoria is applied. But when the lava contains no ready-formed crystals, but consists entirely of a glassy substance in a more or less perfect state of fusion, the liberation of steam gives rise to the formation of the beautiful material known as pumice. Pumice consists of a mass of minute glass bubbles. These bubbles do not usually, however, retain their globular form, but are elongated in one direction through the movement of the mass while it is still in a plastic state. The quantity of this substance ejected is often enormous. We have seen to what a vast extent it was thrown out from the crater of Krakatoa. During the year 1878, masses of floating pumice were reported as existing in the vicinity of the Solomon Isles, and covering the surface of the sea to such extent that it took ships 3 days to force their way through them. Sometimes this substance accumulates in such quantities along coasts that it is difficult to determine the position of the shore within a mile or two, as we may land and walk about on the great floating raft of pumice. Recent deep-sea soundings, carried on in the Challenger and other vessels, have shown that the bottom of the deepest portion of the ocean, far away from the land, is covered with volcanic materials which have been carried through the air or have floated on the surface of the ocean. Fragments of scoria or pumice may be thrown hundreds or thousands of feet into the atmosphere, those that fall into the crater and are flung up again being gradually reduced in size by friction. Thus it is related by Mr. Paulette Scrope, who watched the Vesuvian eruption of 1822, which lasted for nearly a month, that during the earlier stages of the outburst fragments of enormous size were thrown out of the crater, but by constant rejection these were gradually reduced in size, till at last only the most impalpable dust issued from the vent. This dust filled the atmosphere, producing in the city of Naples a darkness that might be felt. So excessively finely divided was it, that it penetrated into all drawers, boxes, and the most closely fastened receptacles, filling them completely. The fragmentary materials ejected from volcanoes are often given the name of cinders or ashes. These, however, are terms of convenience only, and do not properly describe the volcanic material. Sometimes the passages of steam through a mass of molten glass produces large quantities of a material resembling spun glass. Small particles of this glass are carried into the air and leave behind them thin, glassy filaments like a tail. At the volcano of Kilauea in Hawaii, this substance, as previously stated, is abundantly produced, and is known as Pele's hair, Pele being the name of the goddess of the mountain. Birds' nests are sometimes found composed of this beautiful material. In recent years, an artificial substance similar to this Pele's hair has been extensively manufactured by passing jets of steam through the molten slag of iron furnaces. It resembles cotton wool, but is made up of fine threads of glass, and is employed for the packing of boilers and other purposes. The lava itself, as left in huge deposits upon the surface, assumes various forms, some crystalline, others glassy. The latter is usually found in the condition known as obsidian, ordinarily black in color, and containing few or no crystals. It is brittle, and splits into sharp-edged or pointed fragments, which were used by primitive peoples for arrowheads, knives and other cutting implements. The ancient Mexicans used bits of it for shaving purposes, it having an edge of razor-like sharpness. They also used it as the cutting part of their weapons of war. Chapter XX. The active volcanoes of the Earth. It is not by any means an easy task to frame an estimate of the number of volcanoes in the world. Volcanoes vary greatly in their dimensions, from vast mountain masses, rising to a height of nearly 25,000 feet above sea level, to mere molehills. They likewise exhibit every possible stage of development and decay. While some are in a state of chronic active eruption, others are reduced to the condition of solfataras, or vents emitting acid vapors, and others again have fallen into a more or less complete state of ruin through the action of denuding forces. Number of active volcanoes. Even if we confine our attention to the larger volcanoes, which merit the name of mountains, and such of these as we have reason to believe to be in a still active condition, our difficulties will be diminished, but not by any means removed. Volcanoes may sink into a dormant condition that at times endures for hundreds or even thousands of years, and then burst forth into a state of renewed activity. And it is quite impossible, in many cases, to distinguish between the conditions of dormancy and extinction. We shall, however, probably be within the limits of truth in stating that the number of great habitual volcanic vents upon the globe which we have reason to believe are still in active condition, is somewhere between 300 and 350. Most of these are marked by more or less considerable mountains, composed of the materials ejected from them. But if we include mountains which exhibit the external conical form, crater-like hollows, and other features of volcanoes, yet concerning the activity of which we have no record or tradition, the number will fall little, if anything, short of 1,000. The mountains composed of volcanic materials, but which have lost through denudation the external form of volcanoes, are still more numerous, and the smaller temporary openings which are usually subordinate to the habitual vents that have been active during the periods covered by history and tradition, must be numbered by thousands. There are still feebler manifestations of the volcanic forces such as steam jets, geysers, thermal and mineral waters, spouting saline and muddy springs, and mud volcanoes that may be reckoned by millions. It is not improbable that these less powerful manifestations of the volcanic forces to a great extent make up in number what they want in individual energy. And the relief which they afford to the imprisoned activities within the Earth's crust may be almost equal to that which results from the occasional outbursts at the great habitual volcanic vents. In taking a general survey of the volcanic phenomena of the globe, no facts come out more strikingly than that of the very unequal distribution, both of the great volcanoes, and of the minor exhibitions of subterranean energy. Thus, on the whole of the continent of Europe, there is but one habitual volcanic vent, that of Vesuvius, and this is situated upon the shores of the Mediterranean. In the islands of that sea, however, there are no less than 6 volcanoes, namely, Stromboli, and Vulcano, in the Lipari Islands, Etna, in Sicily, Graham's Isle, a submarine volcano, off the Sicilian coast, and Santorin and Nisyros, in the Aegean Sea. The African continent is at present known to contain about 10 active volcanoes, 4 on the west coast, and 6 on the east coast, while about 10 other active volcanoes occur on islands close to the African coasts. On the continent of Asia, more than 20 active volcanoes are known or believed to exist, but no less than 12 of these are situated in the peninsula of Kamchatka. No volcanoes are known to exist in the Australian continent. The American continent contains a greater number of volcanoes than the continents of the Old World. There are 20 in North America, 25 in Central America, and 37 in South America. Thus, taken altogether, there are about 117 volcanoes situated on the great continental lands of the globe, while nearly twice as many occur upon the islands scattered over the various oceans. Asiatic inland volcanoes. Upon examining further into the distribution of the continental volcanoes, another very interesting fact presents itself. The volcanoes are in almost every instance situated either close to the coasts of the continent, or at no great distance from them. There are, indeed, only 2 exceptions to this rule. In the great and almost wholly unexplored tableland lying between Siberia and Tibet 4 volcanoes are said to exist, and in the Chinese province of Manchuria several others. More reliable information is, however, needed concerning these volcanoes. It is a remarkable circumstance that all the oceanic islands which are not coral reefs are composed of volcanic rocks, and many of these oceanic islands, as well as others lying near the shores of the continents, contain active volcanoes. Through the midst of the Atlantic Ocean runs a ridge, which, by the soundings of the various exploring vessels sent out in recent years, has been shown to divide the ocean longitudinally into 2 basins. Upon this great ridge, and the spurs proceeding from it, rise numerous mountainous masses, which constitute the well-known Atlantic islands and groups of islands. All of these are of volcanic origin, and among them are numerous active volcanoes. The island of Jan Mayen contains an active volcano, and Iceland contains 13, and not improbably more. The Azores have 6 active volcanoes, the Canaries 3, while about 8 volcanoes lie off the west coast of Africa. In the West Indies there are 6 active volcanoes, and 3 submarine volcanoes have been recorded within the limits of the Atlantic Ocean. Altogether, no less than 40 active volcanoes are situated upon the great submarine ridges which traverse the Atlantic longitudinally. But along the same line the number of extinct volcanoes is far greater, and there are not wanting proofs that the volcanoes which are still active are approaching the condition of extinction. Volcanoes of the Pacific. If the great medial chain of the Atlantic presents us with an example of a chain of volcanic mountains verging on extinction, we have in the line of islands separating the Pacific and Indian Oceans an example of a similar range of volcanic vents which are in a condition of the greatest activity. In the peninsula of Kamchatka there are 12 active volcanoes, in the Aleutian Islands 31, and in the peninsula of Alaska 3. The chain of the Kuriles contains at least 10 active volcanoes, the Japanese islands and the islands to the south of Japan 25. The great group of islands lying to the southeast of the Asiatic continent is at the present time the grandest focus of volcanic activity upon the globe. No less than 50 active volcanoes occur here. Farther south, the same chain is probably continued by the 4 active volcanoes of New Guinea, 1 or more submarine volcanoes, and several vents in New Britain, the Solomon Isles, and the New Hebrides, the 3 active volcanoes of New Zealand, and possibly by Mount Erebus and Mount Terror in the Antarctic region. Altogether, no less than 150 active volcanoes exist in the chain of islands which stretch from Bering's Straits down to the Antarctic Circle. And if we include the volcanoes on Indian and Pacific islands which appear to be situated on lines branching from this particular band, we shall not be wrong in the assertion that this great system of volcanic mountains includes at least 1/2 of the habitually active vents of the globe. In addition to the active vents, there are here several hundred very perfect volcanic cones, many of which appear to have recently become extinct, though some of them may be merely dormant, biding their time. A third series of volcanoes starts from the neighborhood of Bering's Straits, and stretches along the whole western coast of the American continent. This is much less continuous, but nevertheless very important, and contains, with its branches, nearly 100 active volcanoes. On the north, this great band is almost united with the one we have already described by the chain of the Aleutian and Alaska volcanoes. In British Columbia, about the parallel of 60 degrees north, there exist a number of volcanic mountains, one of which, Mount St. Elias, is believed to be 18,000 feet in height. Farther south, in the territory of the United States, a number of grand volcanic mountains exist, some of which are probably still active, for geysers and other manifestations of volcanic activity abound. From the southern extremity of the peninsula of California, an almost continuous chain of volcanoes stretches through Mexico and Guatemala, and from this part of the volcanic band a branch is given off which passes through the West Indies, and contains the volcanoes which have so recently given evidence of their vital activity. In South America, the line is continued by the active volcanoes of Ecuador, Bolivia, and Chile, but at many intermediate points in the chain of the Andes extinct volcanoes occur, which to a great extent fill up the gaps in the series. A small offshoot to the westward passes through the Galapagos Islands. The great band of volcanoes which stretches through the American continent is second only in importance, and in the activity of its vents, to the band which divides the Pacific from the Indian Ocean. The third volcanic band of the globe is that, already spoken of, which traverses the Atlantic Ocean from north to south. This series of volcanic mountains is much more broken and interrupted than the other two, and a greater proportion of its vents are extinct. It attained its condition of maximum activity during the distant period of the Miocene, and now appears to be passing into a state of gradual extinction. Beginning in the north with the volcanic rocks of Greenland and Bear Island, we pass southwards, by way of Jan Mayen, Iceland, and the Faroe Islands, to the Hebrides and the north of Ireland. Thence, by way of the Azores, the Canaries, and the Cape de Verde Islands, with some active vents, we pass to the ruined volcanoes of St. Paul, Fernando de Noronha, Ascension, St. Helena, Trinidad, and Tristan da Cunha. From this great Atlantic band, two branches proceed to the eastward. One through Central Europe, where all the vents are now extinct, and the other through the Mediterranean to Asia Minor, the great majority of the volcanoes along the latter line being now extinct, though a few are still active. The volcanoes on the eastern coast of Africa may be regarded as situated on another branch from this Atlantic volcanic band. The number of active volcanoes on this Atlantic band and its branches, exclusive of those in the West Indies, does not exceed 50. Thianshan and Hawaiian volcanoes. From what has been said, it will be seen that the volcanoes of the globe not only usually assume a linear arrangement, but nearly the whole of them can be shown to be thrown up along three well-marked bands and the branches proceeding from them. The first and most important of these bands is nearly 10,000 miles in length, and with its branches contains more than 150 active volcanoes. The second is 8,000 miles in length, and includes about 100 active volcanoes. The third is much more broken and interrupted, extends to a length of nearly 1,000 miles, and contains about 50 active vents. The volcanoes of the eastern coast of Africa, with Mauritius, Bourbon, Rodriguez, and the vents along the line of the Red Sea, may be regarded as forming a fourth and subordinate band. Thus we see that the surface of the globe is covered by a network of volcanic bands, all of which traverse it in sinuous lines with a general north and south direction, giving off branches which often run for hundreds of miles, and sometimes appear to form a connection between the great bands. To this rule of the linear arrangement of the volcanic vents of the globe, and their accumulation along certain well-marked bands, there are two very striking exceptions, which we must now proceed to notice. In the very center of the continent formed by Europe and Asia, the largest unbroken landmass of the globe, there rises from the great central plateau the remarkable volcanoes of the Thianshan Range. The existence of these volcanoes, of which only obscure traditional accounts had reached Europe before the year 1858, appears to be completely established by the researches of recent Russian and Swedish travelers. 3 volcanic vents appear to exist in this region, and other volcanic phenomena have been stated to occur in the Great Plateau of Central Asia, but the existence of the latter appears to rest on very doubtful evidence. The only accounts which we have of the eruptions of these Thianshan volcanoes are contained in Chinese histories and treatises on geography. The second exceptionally situated volcanic group is that of the Hawaiian Islands. while the Tian Shan volcanoes rise in the center of the largest unbroken landmass and stand on the edge of the loftiest and greatest plateau in the world. The volcanoes of the Hawaiian Islands rise in the northern center of the largest ocean and from almost the greatest depths in that ocean. All round the Hawaiian Islands the sea has a depth of from 2,000 to 3,000 fathoms, and the island group culminates in several volcanic cones, which rise to the height of nearly 14,000 feet above the sea level. The volcanoes of the Hawaiian Islands are unsurpassed in height and bulk by those of any other part of the globe. With the exception of the two isolated groups of the Tian Shan and the Hawaiian Islands, nearly all the active volcanoes of the globe are situated near the limits which separate the great land and water masses of the globe, that is to say, they occur either on the parts of continents not far removed from their coastlines, or on islands in the ocean not very far distant from the shores. The fact of the general proximity of volcanoes to the sea is one which has frequently been pointed out by geographers, and may now be regarded as being thoroughly established. Volcanoes parallel to mountain chains. Many of the grandest mountain chains have bands of volcanoes lying parallel to them. This is strikingly exhibited by the great mountain masses which lie on the western side of the American continent. The Rocky Mountains and the Andes consist of folded and crumpled masses of altered strata which, by the action of denuding forces, have been carved into series of ridges and summits. At many points, however, along the sides of these great chains we find that fissures have been opened in lines of volcanoes formed, from which enormous quantities of lava have flowed and covered great tracts of country. This is especially marked in the Snake River Plain of Idaho, in the western United States. In this, and the adjoining regions of Oregon and Washington, an enormous tract of country has been overflowed by lava in a late geological period, the surface covered being estimated to have a larger area than France and Great Britain combined. The Snake River cuts through it in a series of picturesque gorges and rapids, enabling us to estimate its thickness, which is considered to average 4,000 feet. Looked at from any point on its surface, one of these lava plains appears as a vast level surface, like that of a lake bottom. This uniformity has been produced either by the lava rolling over a plain or lake bottom, or by the complete effacement of an original, undulating contour of the ground under hundreds or thousands of feet of lava in successive sheets. The lava, rolling up to the base of the mountains, has followed the sinuosities of their margin, as the waters of a lake follow its promontories and bays. Similar conditions exist along the Sierra Nevada range of California, and to some extent placer mining has gone on under immense beds of lava, by a process of tunneling beneath the volcanic rock. In some localities the volcanoes are of such height and dimensions as to overlook and dwarf the mountain ranges by the side of which they lie. Some of the volcanoes lying parallel to the Great American Axis appear to be quite extinct, while others are in full activity. In the eastern continent we find still more striking examples of parallelism between great mountain chains and the lands along which volcanic activity is exhibited. Volcanoes, active or extinct, following the line of the great east and west chains which extend through southern Europe and Asia. There are some other volcanic bands which exhibit a similar parallelism with mountain chains, but, on the other hand, there are volcanoes between which and the nearest mountain axis no such connection can be traced. Areas of upheaval and subsidence. There is one other fact concerning the mode of distribution of volcanoes upon the surface of the globe, to which we must allude. By a study of the evidences presented by coral reefs, raised beaches, submerged forests, and other phenomena of a similar kind, it can be shown that certain wide areas of the land and of the ocean floor are at the present time in a state of subsidence, while other equally large areas are being upheaved. And the observations of the geologist prove that similar upward and downward movements of portions of the Earth's crust have been going on through all geological times. Now, as Mr. Darwin has so well shown in his work on coral reefs, if we trace upon a map the areas of the Earth's surface which are undergoing upheaval and subsidence respectively, we shall find that nearly all the active volcanoes of the globe are situated upon rising areas and that volcanic phenomena are conspicuously absent from those parts of the Earth's crust which can be proved at the present day to be undergoing depression. The remarkable linear arrangement of volcanic vents has a significance that is well worthy of fuller consideration. There are facts known which point to the cause of this state of affairs. It is not uncommon for small cones of scoriae to be seen following lines on the flanks or at the base of a great volcanic mountain. These are undoubtedly lines of fissure, caused by the subterranean forces. In fact, such fissures have been seen opening on the sides of Mount Etna, in whose bottom could be seen the glowing lava. Along these fissures, in a few days, scoriae cones appeared, on one occasion no less than 36 in number. It is believed by geologists that the linear systems of volcanoes are ranged along similar lines of fissure in the Earth's crust, enormous breaks, extending for thousands of miles, and the result of internal energies acting through vast periods of time. Along these immense fissures in the Earth's rock crust there appear, in place of small scoriae cones, great volcanoes, built up through the ages by a series of powerful eruptions, and only ceasing to spout fire themselves when the portion of the great crack upon which they lie is closed. The greatest of these fissures is that along the vast sinuous band of volcanoes extending from near the Arctic Circle at Bering Straits to the Antarctic Circle at South Victoria Land, not far from half round the Earth. It doubtless marks the line of mighty forces which have been active for millions of years. Chapter XXI. The famous Vesuvius and the destruction of Pompeii. The famous volcano of southern Italy named Vesuvius, which is now so constantly in eruption, was described by the ancients as a cone-shaped mountain with a flat top, on which was a deep circular valley filled with vines and grass, and surrounded by high precipices. A large population lived on the sides of the mountain, which was covered with beautiful woods, and there were fine flourishing cities at its foot. So little was the terrible nature of the valley on the top understood, that in AD 72, Spartacus, a rebellious Roman gladiator, encamped there with some thousands of fighting men, and the Roman soldiers were let down the precipices in order to surprise and capture them. There had been earthquakes around the mountain, and one of the cities had been nearly destroyed, but no one was prepared for what occurred 7 years after the defeat of Spartacus. Suddenly, in the year 79 AD, a terrific rush of smoke, steam, and fire belched from the mountain's summit. One side of the valley in which Spartacus had encamped was blown off, and its rocks, with vast quantities of ashes, burning stones, and sand, were ejected far into the sky. They then spread out like a vast pall, and fell far and wide. For 8 days and nights this went on, and the enormous quantity of steam sent up, together with the deluge of rain that fell, produced torrents on the mountainside, which, carrying onward the fallen ashes, overwhelmed everything in their way. Sulfurous vapors filled the air and violent tremblings of the earth were constant. A city 6 miles off was speedily rendered uninhabitable, and was destroyed by the falling stones. But 2 others, Herculaneum and Pompeii, which already had suffered from the downpour of ashes, were gradually filled with a flood of water, sand, and ashes, which came down the side of the volcano, and covering them entirely. Buried cities excavated. The difference in ease of excavation is due to the following circumstance. Herculaneum, being several miles nearer the crater, was buried in a far more consistent substance, seemingly composed of volcanic ashes cemented by mud. Pompeii, on the contrary, was buried only in ashes and loose stones. The casts of statues found in Herculaneum show the plastic character of the material that fell there, which time has hardened to rock-like consistency. These statues represented Hercules and Cleopatra, and the theater proved to be that of the long-lost city of Herculaneum. The site of Pompeii was not discovered until 40 years afterward, but work there proved far easier than at Herculaneum, and more progress was made in bringing it back to the light of day. The less solid covering of Pompeii has greatly facilitated the work of excavation, and a great part of the city has been laid bare. Many of its public buildings and private residences are now visible, and some whole streets have been cleared, while a multitude of interesting relics have been found. Among those are casts of many of the inhabitants, obtained by pouring liquid plaster into the ash molds that remained of them. We see them today in the attitude and with the expression of agony and horror with which death met them more than 18 centuries ago. In succeeding eruptions much lava was poured out, and in AD 472, ashes were cast over a great part of Europe, so that much fear was caused at Constantinople. The buried cities were more and more covered up, and it was not until about AD 1700 that, as above stated, the city of Herculaneum was discovered, the peasants of the vicinity being in the habit of extracting marble from its ruins. They had also, in the course of years, found many statues. In consequence, an excavation was ordered by Charles III, the earliest result being the discovery of the theater, with the statues above named. The work of excavation, however, has not progressed far in this city, on account of its extreme difficulty, though various excellent specimens of artwork have been discovered, including the finest examples of mural painting extant from antiquity. The library was also discovered, 1,803 papyri being found. Though these had been charred to cinder, and were very difficult to unroll and decipher, over 300 of them have been read. Pliny's celebrated description. Pliny the Younger, to whom we are indebted for the only contemporary account of the great eruption under consideration, was at the time of its occurrence resident with his mother at Misenum, where the Roman fleet lay, under the command of his uncle, the great author of the Historia Naturalis. His account, contained in 2 letters to Tacitus, Lib 6:16-20, is not so much a narrative of the eruption, as a record of his uncle's singular death, yet it is of great interest as yielding the impressions of an observer. The translation which follows is adopted from the very free version of Melmoth, except in 1 or 2 places, where it differs much from the ordinary text. The letters are given entire, though some parts are rather specimens of style than good examples of description. Your request that I should send an account of my uncle's death, in order to transmit a more exact relation of it to posterity, deserves my acknowledgments. For if this accident shall be celebrated by your pen, the glory of it, I am assured, will be rendered forever illustrious. And, notwithstanding he perished by a misfortune which, as it involved at the same time a most beautiful country in ruins, and destroyed so many populous cities, seems to promise him an everlasting remembrance. Notwithstanding he has himself composed many and lasting works, yet I am persuaded the mention of him in your immortal works will greatly contribute to eternize his name. Happy I esteem those to be, whom Providence has distinguished with the abilities either of doing such actions as are worthy of being related, or of relating them in a manner worthy of being read, but doubly happy are they who are blessed with both these talents, in the number of which my uncle, as his own writings in your history will prove, may justly be ranked. It is with extreme willingness, therefore, that I execute your commands, and should, indeed, have claimed the task if you had not enjoined it. He was at that time with the fleet under his command at Misenum. On the 24th of August, about 1 in the afternoon, my mother desired him to observe a cloud which appeared of a very unusual size and shape. He had just returned from taking the benefit of the sun, and, after bathing himself in cold water, and taking a slight repast, had retired to his study. He immediately arose, and went out upon an eminence, from whence he might more distinctly view this very uncommon appearance. It was not at that distance discernible from what mountain the cloud issued, but it was found afterward to ascend from Mount Vesuvius. I cannot give a more exact description of its figure than by comparing it to that of a pine tree, for it shot up to a great height in the form of a trunk, which extended itself at the top into a sort of branches. Occasioned, I imagine, either by a sudden gust of air that impelled it, the force of which decreased as it advanced upwards, or the cloud itself being pressed back again by its own weight, and expanding in this manner. It appeared sometimes bright, and sometimes dark and spotted, as it was more or less impregnated with earth and cinders. This extraordinary phenomenon excited my uncle's philosophical curiosity to take a nearer view of it. He ordered a light vessel to be got ready, and gave me the liberty, if I thought proper, to attend him. I rather chose to continue my studies, for, as it happened, he had given me an employment of that kind. As he was passing out of the house he received dispatches. The marines at Retina, terrified at the imminent peril, for the place lay beneath the mountain, and there was no retreat but by ships, entreated his aid in this extremity. He accordingly changed his first design, and what he began with a philosophical he pursued with an heroical turn of mind. The voyage to Stabia. He ordered the galleys to put to sea, and went himself on board with an intention of assisting not only Retina but many other places, for the population is thick on that beautiful coast. When hastening to the place from whence others fled with the utmost terror, he steered a direct course to the point of danger, and with so much calmness and presence of mind, as to be able to make and dictate his observations upon the motion and figure of that dreadful scene. He was now so nigh the mountain that the cinders, which grew thicker and hotter the nearer he approached, fell into the ships, together with pumice stones, and black pieces of burning rock. They were in danger of not only being left aground by the sudden retreat of the sea, but also from the vast fragments which rolled down from the mountain, and obstructed all the shore. Here he stopped to consider whether he should return back again, to which the pilot advised him. "Fortune," said he, "favors the brave. Carry me to Pomponianus." Pomponianus was then at Stabia, separated by a gulf, which the sea, after several insensible windings, forms upon the shore. He, Pomponianus, had already sent his baggage on board. For though he was not at that time in actual danger, yet being within view of it, and indeed extremely near, if it should in the least increase, he was determined to put to sea as soon as the wind should change. It was favorable, however, for carrying my uncle to Pomponianus, whom he found in the greatest consternation. He embraced him with tenderness, encouraging and exhorting him to keep up his spirits. And the more to dissipate his fears, he ordered, with an air of unconcern, the baths to be got ready, when, after having bathed, he sat down to supper with great cheerfulness, or at least, what is equally heroic, with all the appearance of it. In the meantime, the eruption from Mount Vesuvius flamed out in several places with much violence, which the darkness of the night contributed to render still more visible and dreadful. But my uncle, in order to soothe the apprehensions of his friend, assured him it was only the burning of the villages, which the country people had abandoned to the flames. After this he retired to rest, and it was most certain he was so little discomposed as to fall into a deep sleep, for, being pretty fat, and breathing hard, those who attended without actually heard him snore. The court which led to his apartment being now almost filled with stones and ashes, if he had continued there any longer it would have been impossible for him to have made his way out. It was thought proper, therefore, to awaken him. He got up and went to Pomponianus and the rest of his company, who were not unconcerned enough to think of going to bed. They consulted together whether it would be most prudent to trust to the houses, which now shook from side to side with frequent and violent concussions, or to fly to the open fields, where the calcined stone and cinders, though light indeed, yet fell in large showers and threatened destruction. In this distress they resolved for the fields as the less dangerous situation of the two, a resolution which, while the rest of the company were hurried into it by their fears, my uncle embraced upon cool and deliberate consideration. Death of Pliny the Elder. They went out, then, having pillows tied upon their heads with napkins, and this was their whole defense against the storm of stones that fell around them. It was now day everywhere else, but there a deeper darkness prevailed than in the most obscure night, which, however, was in some degree dissipated by torches and other lights of various kinds. They thought proper to go down further upon the shore, to observe if they might safely put out to sea, but they found that the waves still ran extremely high and boisterous. There my uncle, having drunk a draught or two of cold water, threw himself down upon a cloth which was spread for him, when immediately the flames, and a strong smell of sulphur which was the forerunner of them, dispersed the rest of the company, and obliged him to rise. He raised himself up with the assistance of two of his servants, and instantly fell down dead, suffocated, as I conjecture, by some gross and noxious vapor, having always had weak lungs, and being frequently subject to a difficulty of breathing. As soon as it was light again, which was not till the third day after this melancholy accident, his body was found entire, and without any marks of violence upon it, exactly in the same posture as that in which he fell, and looking more like a man asleep than dead. During all this time my mother and I were at Misenum. But this has no connection with your history, as your inquiry went no farther than concerning my uncle's death, With that, therefore, I will put an end to my letter. Suffer me only to add, that I have faithfully related to you what I was either an eyewitness of myself, or received immediately after the accident happened, and before there was any time to vary the truth. You will choose out of this narrative such circumstances as shall be most suitable to your purpose, for there is a great difference between what is proper for a letter and a history, between writing to a friend and writing to the public. Farewell. In this account, which was drawn up some years after the event, from the recollections of a student 18 years old, we recognize the continual earthquakes. The agitated sea with its uplifted bed, the flames and vapors of an ordinary eruption, probably attended by lava as well as ashes. But it seems likely that the author's memory, or rather the information communicated to him regarding the closing scene of Pliny's life, was defective. Flames and sulfurous vapors could hardly be actually present at Stabia, 10 miles from the center of the eruption. That lava flowed at all from Vesuvius on this occasion has been usually denied, chiefly because at Pompeii and Herculaneum the causes of destruction were different. Ashes overwhelmed the former, mud concreted over the latter. We observe, indeed, phenomena on the shore near Torre del Greco which seem to require the belief that currents of lava had been solidified there at some period before the construction of certain walls and floors, and other works of Roman date. In the Oxford Museum, among the specimens of lava to which the dates are assigned, is one referred to AD 79, but there is no mode of proving it to have belonged to the eruption of that date. Pliny's second letter. A second letter from Pliny to Tacitus, Epist 20, was required to satisfy the curiosity of that historian, especially as regards the events which happened under the eyes of his friend. Here it is according to Melmoth. The letter which, in compliance with your request, I wrote to you concerning the death of my uncle, has raised, it seems, your curiosity to know what terrors and danger attended me while I continued at Misenum. Further, I think, the account in my former letter broke off. Though my shocked soul recoils, my tongue shall tell. My uncle having left us, I pursued the studies which prevented my going with him till it was time to bathe. After which I went to supper, and from thence to bed, where my sleep was greatly broken and disturbed. There had been, for many days before, some shocks of an earthquake, which the less surprised us as they are extremely frequent in Campania. But they were so particularly violent that night, that they not only shook everything about us, but seemed, indeed, to threaten total destruction. My mother flew to my chamber, where she found me rising in order to awaken her. We went out into a small court belonging to the house, which separated the sea from the buildings. As I was at that time but 18 years of age, I know not whether I should call my behavior, in this dangerous juncture, courage, or rashness. But I took up Livy, and amused myself with turning over that author, and even making extracts from him, as if all about me had been in full security. While we were in this posture, a friend of my uncle's, who was just come from Spain to pay him a visit, joined us. And observing me sitting with my mother with a book in my hand, greatly condemned her calmness at the same time that he reproved me for my careless security. Nevertheless, I still went on with my author. Though it was now morning, the light was exceedingly faint and languid. The buildings all around us tottered, and, though we stood upon open ground, yet as the place was narrow and confined, there was no remaining there without certain and great danger. We therefore resolved to quit the town. The people followed us in the utmost consternation, and, as to a mind distracted with terror every suggestion seems more prudent than its own, pressed in great crowds about us in our way out. Being got to a convenient distance from the houses, we stood still, in the midst of a most dangerous and dreadful scene. The chariots which we had ordered to be drawn out were so agitated backwards and forwards, though upon the most level ground, that we could not keep them steady, even by supporting them with large stones. The sea seemed to roll back upon itself, and to be driven from its banks by the convulsive motion of the earth. It is certain at least that the shore was considerably enlarged, and many sea animals were left upon it. On the other side a black and dreadful cloud, bursting with an igneous serpentine vapor, darted out a long train of fire, resembling flashes of lightning, but much larger. Fear versus composure. Upon this the Spanish friend whom I have mentioned, addressed himself to my mother and me with great warmth and earnestness. "If your brother and your uncle," said he, "is safe, he certainly wishes you to be so too, but if he has perished, it was his desire, no doubt, that you might both survive him, why therefore do you delay your escape a moment?" We could never think of our own safety, we said, while we were uncertain of his. Hereupon our friend left us, and withdrew with the utmost precipitation. Soon afterward, the cloud seemed to descend, and cover the whole ocean, as it certainly did the island of Capri, and the promontory of Misenum. My mother strongly conjured me to make my escape at any rate, which, as I was young, I might easily do. As for herself, she said, her age and corpulency rendered all attempts of that sort impossible. However, she would willingly meet death, if she could have the satisfaction of seeing that she was not the occasion of mine. But I absolutely refused to leave her, and taking her by the hand, I led her on. She complied with great reluctance, and not without many reproaches to herself for retarding my flight. The ashes now began to fall upon us, though in no great quantity. I turned my head and observed behind us a thick smoke, which came rolling after us like a torrent. I proposed, while we yet had any light, to turn out of the high road lest she should be pressed to death in the dark by the crowd that followed us. We had scarce stepped out of the path when darkness overspread us, not like that of a cloudy night, or when there is no moon, but of a room when it is all shut up and all the lights are extinct. Nothing then was to be heard but the shrieks of women, the screams of children and the cries of men. Some calling for their children, others for their parents, others for their husbands, and only distinguishing each other by their voices. One lamenting his own fate, another that of his family. Some wishing to die from the very fear of dying, some lifting their hands to the gods, but the greater part imagining that the last and eternal night was come, which was to destroy the gods and the world together. Among them were some who augmented the real terrors by imaginary ones, and made the frightened multitude believe that Misenum was actually in flames. At length a glimmering light appeared, which we imagined to be rather the forerunner of an approaching burst of flames, as in truth it was, than the return of day. However, the fire fell a distance from us. Then again we were immersed in thick darkness, and a heavy shower of ashes rained upon us, which we were obliged every now and then to shake off, otherwise we should have been crushed and buried in the heap. I might boast that, during all this scene of horror, not a sigh or expression of fear escaped me, had not my support been founded in that miserable, though strong, consolation that all mankind were involved in the same calamity, and that I imagined I was perishing with the world itself. At last this dreadful darkness was dissipated by degrees, like a cloud of smoke, the real day returned, and soon the sun appeared, though very faintly, and as when an eclipse is coming on. Every object that presented itself to our eyes, which were extremely weakened, seemed changed, being covered over with white ashes, as with a deep snow. We returned to Misenum, where we refreshed ourselves as well as we could, and passed an anxious night between hope and fear, for the earthquake still continued, while several greatly excited people ran up and down, heightening their own and their friends' calamities by terrible predictions. However, my mother and I, notwithstanding the danger we had passed and that which still threatened us, had no thoughts of leaving the place till we should receive some account from my uncle. And now you will read this narrative without any view of inserting it in your history, of which it is by no means worthy, and, indeed, you must impute it to your own request if it shall not even deserve the trouble of a letter. Farewell. Dion Cassius on the eruption. The story told by Pliny is the only one upon which we can rely. Dion Cassius, the historian, who wrote more than a century later, does not hesitate to use his imagination, telling us that Pompeii was buried under showers of ashes while all the people were sitting in the theater. This statement has been effectively made use of by Bulwer, in his Last Days of Pompeii. In this he pictures for us a gladiatorial combat in the arena, with thousands of deeply interested spectators occupying the surrounding seats. The novelist works his story up to a thrilling climax in which the volcano plays a leading part. This is all very well as a vivid piece of fiction, but it does not accord with fact, since Dion Cassius was undoubtedly incorrect in his statement. We now know from the evidence furnished by the excavations that none of the people were destroyed in the theaters, and, indeed, that there were very few who did not escape from both cities. It is very likely that many of them returned and dug down for the most valued treasures in their buried habitations. Dion Cassius may have obtained the material for his accounts from the traditions of the descendants of survivors, and if so, he shows how terrible must have been the impression made upon their minds. He assures us that during the eruption a multitude of men of superhuman nature appeared, sometimes on the mountain and sometimes in the environs, that stones and smoke were thrown out, the sun was hidden, and then the giants seemed to rise again, while the sounds of trumpets were heard. Lake of Irnus. Not far from Vesuvius lay the famous Lake of Irnus, whose name was long a popular synonym for the infernal regions. The lake is harmless today, but its reputation indicates that it was not always so. There is every reason to believe that it hides the outlet of an extinct volcano, and that long after the volcano ceased to be active it emitted gases as fatal to animal life as those suffocating vapors which annihilated all the cattle on the island of Lanzarote, in the Canaries, in the year 1730. Its name signifies birdless, indicating that its ascending vapors were fatal to all birds that attempted to fly above its surface. In the superstition of the Middle Ages, Vesuvius assumed the character which had before been given to Avernus, and was regarded as the mouth of hell. Cardinal Damiano, in a letter to Pope Nicholas II, written about the year 1060, tells the story of how a priest, who had left his mother ill at Beneventum, went on his homeward way to Naples past the crater of Vesuvius, and heard issuing therefrom the voice of his mother in great agony. He afterward found that her death coincided exactly with the time at which he had heard her voice. A trip to the summit of Vesuvius is one of the principal attractions for strangers who are visiting Naples. There is a fascination about that awful slayer of cities which few can resist, and no less attractive is the city of Pompeii, now largely laid bare after being buried for 18 centuries. We are indebted to Henry Haney for the following interesting description: once seen, it will never be forgotten. It is full of suggestions. It kindles emotions that are worth the kindling, and brings on dreams that are worth the dreaming. Of the three places overwhelmed, Herculaneum, Pompeii and Stabia, the last scarcely repays excavation in one sense, and the first in another, but to watch the diggers at Pompeii is fascinating, even when there is no reasonable expectation of a find. Herculaneum was buried with lava, or rather with tufa, and it is so very hard that the expense of uncovering of only a small part of that city has been very great. How Pompeii impresses its visitors. Pompeii was smothered in ashes, however, and most of it is uncovered now. But while there is much that is fascinating, and all of it is instructive, there is nothing grand or awe-inspiring in the ruins of Pompeii. No visitor stands breathless as in the Great Hall of Karnak or in the once dreadful Colosseum at Rome, or dreams with sensuous delight as before the Jasmine Court at Agra. The weirdness of the scene possesses us as a haunted chamber might. We have before us the narrow lanes, paved with tufa, in which Roman wagon wheels have worn deep ruts. We cross streets on stepping stones which sandaled feet ages ago polished. We see the wine shops with empty jars, counters stained with liquor, stone mills where the wheat was ground, and the very ovens in which bread was baked more than 18 centuries ago. Welcome is offered us at one silent, broken doorway, at another we are warned to beware of the dog. The painted figures. Some of them so artistic and rich in colors that pictures of them are disbelieved. The mosaic pavements, the empty fountains, the altars, and household gods, the marble pillars and the small gardens are there just as the owners left them. Some of the walls are scribbled over by the small boys of Pompeii in strange characters which mock modern erudition. In places we read the advertisements of gladiatorial shows, never to come off, the names of candidates for legislative office who were never to sit. There is nothing like this elsewhere. The value of Pompeii to those classic students who would understand, not the speech only, but the life and the everyday habits, of the ancient world, is too high for reckoning. Its inestimable evidence may be seen in the fact that any high school boy can draw the plan of a Roman house, while ripest scholars hesitate on the very threshold of a Greek dwelling. This is because no Hellenic Pompeii has yet been discovered, but thanks to the silent city close to the beautiful Bay of Naples, the Latin house is known from ostium to porticus, from the front door to the back garden wall. Streets and houses of Pompeii. The streets of Pompeii must have had a charm unapproached by those of any city now in existence. The stores, indeed, were wretched little dens. 2 or 3 of them commonly occupied the front of a house on either side of the entrance, the ostium, but when the door lay open, as was usually the case, a passerby could look into the atrium. Prettily decorated and hung with rich stuffs. The sunshine entered through an aperture in the roof, and shone on the waters of the impluvium, the mosaic floor, the altar of the household gods and the flowers around the fountain. As the life of the Pompeians was all outdoors, their pretty homes stood open always. There was indeed a curtain betwixt the atrium and the peristyle, but it was drawn only when the master gave a banquet. Thus a wayfarer in the street could see, beyond the hall described and its busy servants, the white columns of the peristyle, with creepers trained about them, flowers all around, and jets of water playing through pipes which are still in place. In many cases the garden itself could be observed between the pillars of the further gallery, and rich paintings on the wall beyond that. But how far removed those little palaces of Pompeii were from our notion of well-being is scarcely to be understood by one who has not seen them. It is a question strange in all points of view where the family slept in the houses, nearly all of which had no second story. In the most graceful villas the 3 to 5 sleeping chambers round the atrium and 4 round the peristyle were rather ornamental cupboards than aught else. One did not differ from another, and if these were devoted to the household the slaves, male and female, must have slept on the floor outside. The master, his family, and his guest used these small, dark rooms, which were apparently without such common luxuries as we expect in the humblest home. All their furniture could hardly have been more than a bed and a footstool, but it should be remembered that the public bath was a daily amusement. The kitchen of each villa certainly was not furnished with such ingenuity, expense, or thought as the stories of Roman gormandizing would have led us to expect. In the house of the aedile, so called from the fact that Pansamede is inscribed in red characters by the doorway, the cook seems to have been employed in frying eggs at the moment when increasing danger put him to flight. His range, 4 partitions of brick, was very small. A knife, a strainer, a pan lay by the fire just as they fell from the slave's hand. Value of the discovery of Pompeii. This description strongly presents to us the principal value of the discovery of Pompeii. Interesting as are the numerous works of art found in its habitations, and important as is their bearing upon some branches of the art of the ancient world. This cannot compare in interest with the flood of light which is here thrown on ancient life in all its details, enabling us to picture to ourselves the manners and habits of life of a cultivated and flourishing population at the beginning of the Christian era, to an extent which no amount of study of ancient history could yield. Looking upon the work of the volcano as essentially destructive, as we naturally do, we have here a valuable example of its power as a preservative agent. And it is certainly singular that it is to a volcano we owe much of what we know concerning the cities, dwellings, and domestic life of the people of the Roman Empire. It would be very fortunate for students of antiquity if similar disasters had happened to cities in other ancient civilized lands, however unfortunate it might have been to their inhabitants. But doubtless we are better off without knowledge gained from ruins thus produced. Chapter XXII. Eruptions of Vesuvius, Etna, and Stromboli. Mount Vesuvius is of especial interest as being the only active volcano on the continent of Europe, all others of that region being on the islands of the Mediterranean, and for the famous ancient eruption described in the last chapter. Before this it had borne the reputation of being extinct, but since then it has frequently shown that its fires have not burned out, and has on several occasions given a vigorous display of its powers. During the 1500 years succeeding the destructive event described, eruptions were of occasional occurrence, though of no great magnitude. But throughout the long intervals when Vesuvius was at rest, it was noted that Etna and Ischia were more or less disturbed. The birth of Monte Nuovo. In 1538 a startling evidence was given that there was no decline of energy in the volcanic system of southern Italy. This was the sudden birth of the mountain still known as Monte Nuovo, or New Mountain, which was thrown up in the Campania near Avernus, on the spot formerly occupied by the Lucaran Lake. For about 2 years prior to this event the district had been disturbed by earthquakes, which on September 27 and 28, 1538, became almost continuous. The low shore was slightly elevated, so that the sea retreated, leaving bare a strip about 200 feet in width. The surface cracked. Steam escaped, and at last, early on the morning of the 29th, a greater rent was made, from which were vomited furiously smoke, fire, stones, and mud composed of ashes, making at the time of its opening a noise like the loudest thunder. The ejected material in less than 12 hours built the hill which has lasted substantially in the same form to our day. It is a noteworthy fact that since the formation of Monte Nuovo there has been no volcanic disturbance in any part of the Neapolitan district except in Vesuvius, which for 5 centuries previous had remained largely at rest. Lava from Vesuvius. The first recognized appearance of lava in the eruptions of Vesuvius was in the violent eruption of 1036. This was succeeded at intervals by 5 other outbreaks, none of them of great energy. After 1500 the crater became completely quiet, the whole mountain in time being grown over with luxuriant vegetation, while by the next century, the interior of the crater became green with shrubbery, indicating that no injurious gases were escaping. This was sleep, not death. In 1631 the awakening came in an eruption of terrible violence. Almost in a moment the green mantle of woodland and shrubbery was torn away and death and destruction left where peace and safety had seemed assured. 7 streams of lava poured from the crater and swept rapidly down the mountainside, leaving ruin along their paths. Resina, Granazello, and Torre del Greco, 3 villages that had grown up during the period of quiescence, were more or less overwhelmed by the molten lava. Great torrents of hot water also poured out, adding to the work of desolation. It was estimated that 18,000 of the inhabitants were killed. What made the horror all the greater was a frightful error of judgment, similar to that of the governor of Martinique at Saint-Pierre. The governor of Torre del Greco had refused to be warned in time, and prevented the people from making their escape until it was too late. Not until the lava had actually reached the walls was the order for departure given. Before the order could be acted upon, the molten streams burst through the walls into the crowded streets, and overwhelmed the vast majority of the inhabitants. In this violent paroxysm the whole top of the mountain is said to have been swept away, the new crater which took the place of the old one being greatly lowered. From that date Vesuvius has never been at rest for any long interval, and eruptions of some degree of violence have been rarely more than a few years apart. Of its various later manifestations of energy we select for description that of 1767, of which an interesting account by a careful observer is extant. Great eruption of 1767. From the 10th of December, 1766, to March, 1767, Vesuvius was quiet, then it began to throw up stones from time to time. In April the throws were more frequent, and at night the red glare grew stronger on the cloudy columns which hung over the crater. These repeated throws of cinders, ashes, and pumice stones so much increased the small cone of eruption which had been left in the center of the flat crateral space that its top became visible at a distance. On the 7th of August there issued a small stream of lava from a breach in the side of a small cone. The lava gradually filled the space between the cone and the crateral edge. On the 12th of September it overflowed the crater, and ran down the mountain. Stones were ejected which took 10 seconds in their fall, from which it may be computed that the height which the stones reached was 1,600 feet. Padre Torre, a great observer of Vesuvius, says they went up above 1,000 feet. The lava ceased on the 18th of October, but at 8 a.m. on the 19th it rushed out at a different place, after volleys of stones had been thrown to an immense height, and the huge traditional pine tree of smoke reappeared. On this occasion that vast phantom extended its menacing shadow over Capri, at a distance of 28 miles from Vesuvius. The lava at first came out of a mouth about 100 yards below the crater, on the side toward Monte Sama. While occupied in viewing this current, the observer heard a violent noise within the mountain. Saw it split open at the distance of 1/4 of a mile, and saw from the new mouth a mountain of liquid fire shoot up many feet, and then, like a torrent, roll on toward him. The earth shook, stones fell thick around him, dense clouds of ashes darkened the air, loud thunders came from the mountain top, and he took to precipitate flight. The Padre's account is too lively and instructive for his own words to be omitted. Padre Tor's narrative. I was making my observations upon the lava, which had already, from the spot where it first broke out, reached the valley, when, on a sudden, about noon, I heard a violent noise within the mountain, and at a spot about 1/4 of a mile off the place where I stood the mountain split. And with much noise, from this new mouth, a fountain of liquid fire shot up many feet high, and then like a torrent rolled on directly towards us. The earth shook at the same time that a volley of stones fell thick upon us. In an instant clouds of black smoke and ashes caused almost a total darkness. The explosions from the top of the mountain were much louder than any thunder I ever heard, and the smell of the sulfur was very offensive. My guide, alarmed, took to his heels, and I must confess that I was not at my ease. I followed close, and we ran near 3 miles without stopping. As the earth continued to shake under our feet, I was apprehensive of the opening of a fresh mouth which might have cut off our retreat. I also feared that the violent explosions would detach some of the rocks off the mountain of Sama, under which we were obliged to pass. Besides, the pumice stones, falling upon us like hail, were of such a size as to cause a disagreeable sensation in the part upon which they fell. After having taken breath, as the earth trembled greatly, I thought it most prudent to leave the mountain and return to my villa, where I found my family in great alarm at the continual and violent explosions of the volcano, which shook our house to its very foundation, the doors and windows swinging upon their hinges. About 2 o'clock in the afternoon, 19th, another lava stream forced its way out of the same place from whence came the lava of last year, so that the conflagration was soon as great on this side of the mountain as on the other which I had just left. I observed on my way to Naples, which was in less than 2 hours after I had left the mountain, that the lava had actually covered 3 miles of the very road through which we had retreated. This river of lava in the Atrio del Cavallo was 60 or 70 feet deep, and in some places nearly 2 miles broad. Besides the explosions, which were frequent, there was a continued subterranean and violent rumbling noise, which lasted 5 hours in the night, supposed to arise from contact of the lava with rainwater, lodged in cavities within. The whole neighborhood was shaken violently. Portici and Naples were in the extremity of alarm. The churches were filled, the streets were thronged with processions of saints, and various ceremonies were performed to quell the fury of the mountain. In the night of the 20th, the occasion being critical, the prisoners in the public jail attempted to escape, and the mob set fire to the gates of the residence of the Cardinal Archbishop because he refused to bring out the relics of Saint Januarius. The 21st was a quieter day, but the whole violence of the eruption returned on the 22d, at 10 a.m., with the same thundering noise, but more violent and alarming. Ashes fell in abundance in the streets of Naples, covering the housetops and balconies an inch deep. Ships at sea, 20 leagues from Naples, were covered with them. In the midst of these horrors, the mob, growing tumultuous and impatient, obliged the cardinal to bring out the head of Saint Januarius, at the extremity of Naples, toward Vesuvius, and it is well attested here that the eruption ceased the moment the saint came in sight of the mountain. It is true the noise ceased about that time after having lasted 5 hours, as it had done the preceding days. On the 23d the lava still ran, but on the 24th it ceased, but smoke continued. On the 25th there rose a vast column of black smoke, giving out much forked lightning with thunder, in a sky quite clear except for the smoke of the volcano. On the 26th smoke continued, but on the 27th the eruption came to an end. This eruption was also described by Sir William Hamilton, who continued to keep a close watch on the movements of the volcano for many years. The next outbreak of especial violence took place in 1779, when what seemed to the eye a column of fire ascended 2 miles high, while cinder fragments fell far and wide, destroying the hopes of harvest throughout a wide district. They fell in abundance 30 miles distant, and the dust of the explosion was carried 100 miles away. In 1793 the crater became active again, and in 1794, after a period of short tranquility or comparative inaction, the mountain again became agitated, and one of the most formidable eruptions known in the history of Vesuvius began. It was in some respects unlike many others, being somewhat peculiar as to the place of its outburst, the temperature of the lava, and the course of the current. Brylock, an Italian geologist, observed the characteristic phenomena with the eye of science, and his account supplies many interesting facts. Brylock on the eruption of 1794. Brylock remarked certain changes in the character of the Earth's motions during this 6 hours eruption, which led him to some particular conjecture of the cause. At the beginning the trembling was continual, and accompanied by a hollow noise, similar to that occasioned by a river falling into a subterranean cavern. The lava, at the time of its being disgorged, from the impetuous and uninterrupted manner in which it was ejected, causing it to strike violently against the walls of the vent, occasioned a continual oscillation of the mountain. Toward the middle of the night this vibratory motion ceased, and was succeeded by distant shocks. The fluid mass, diminished in quantity, now pressed less violently against the walls of the aperture, and no longer issued in a continual and gushing stream, but only at intervals, when the interior fermentation elevated the boiling matter above the mouth. About 4 a.m. the shocks began to be less numerous, and the intervals between them rendered their force and duration more perceptible. During this tremendous eruption at the base of the Vesuvian cone, and the fearful earthquakes which accompanied it, the summit was tranquil. The sky was serene, the stars were brilliant, and only over Vesuvius hung a thick, dark smoke cloud, lighted up into an auroral arch by the glare of a stream of fire more than 2 miles long, and more than a quarter of a mile broad. The sea was calm, and reflected the red glare, while from the source of the lava came continual jets of uprushing incandescent stones. Nearer to view, Torre del Greco in flames, and clouds of black smoke, with falling houses, presented a dark and tragical foreground, heightened by the subterranean thunder of the mountain, and the groans and lamentations of 15,000 ruined men, women, and children. The heavy clouds of ashes which were thrown out on this occasion gathered in the early morning into a mighty shadow over Naples and the neighborhood, the sun rose pale and obscure, and a long, dim twilight reigned afterward. Such were the phenomena on the western side of Vesuvius. They were matched by others on the eastern aspect, not visible at Naples, except by reflection of their light in the atmosphere. The lava on this side flowed eastward, along a route often traversed by lava, by the broken crest of the Canalo and the valley of Sorrento. The extreme length to which this current reached was not less than an Italian mile. The cubic content was estimated to be half that already assigned to the western currents. Taken together they amounted to 20,744,445 cubic meters, or 2,804,440 cubic fathoms, the constitution of the lava being the same in each, both springing from one deep-seated reservoir of fluid rock. The eruption of lava ceased on the 16th, and then followed heavy discharges of ashes, violent shocks of earthquakes, thunder, and lightning in the columns of vapors and ashes, and finally heavy rains, lasting till the 3rd of July. The barometer during all the eruption was steady. Brylock made an approximate calculation of the quantity of ashes which fell on Vesuvius during this great eruption, and states the result as equal to what would cover a circular area 6 kilometers, about 3.5 English miles, in radius, and 39 centimeters, about 15 inches, in depth. Strange effects. Among the notable things which attended this eruption, it is recorded that in Torre del Greco metallic and other substances exposed to the current were variously affected. Silver was melted, glass became porcelain, iron swelled to 4 times its volume and lost its texture. Brass was decomposed, and its constituent copper crystallized in cubic and octahedral forms aggregated in beautiful branches. Zinc was sometimes turned to blende. During the eruption, the lip of the crater toward Bosco Tracase on the southeast, fell in, or was thrown off, and the height of that part was reduced 426 feet. On the 17th, the sea was found in a boiling state 100 yards off the new promontory made by the lava of Torre del Greco, and no boat could remain near it on account of the melting of the pitch in her bottom. For nearly a month after the eruption, vast quantities of fine white ashes, mixed with volumes of steam, were thrown out from the crater. The clouds thus generated were condensed into heavy rain, and large tracts of the Vesuvian slopes were deluged with volcanic mud. It filled ravines, such as Fosso Grande, and concreted and hardened there into pumiceous tufa, a very instructive phenomenon. Immense injury was done to the rich territory of Sama, Ottageno, and Bosco by heavy rains, which swept along cinders, broke up the road and bridges, and overturned trees and houses for the space of 15 days. There were few years during the 19th century in which Vesuvius did not show symptoms of its internal fires, and at intervals it manifested much activity, though not equaling the terrible eruptions of its past history. The severest eruptions in that century were those of 1871 and 1876. In the first, a sudden emission of lava killed 20 spectators at the mouth of the crater, and only spent its fury after San Sebastian and Massa had been well nigh annihilated. Fragments of rock were thrown up to the height of 4,000 feet, and the explosions were so violent that the whole countryside fled panic-stricken to Naples. The activity of the volcano, accompanied by distinct shocks of earthquake, lasted for a week. In 1876, for 3 weeks together, lava streamed down the side of Vesuvius, sweeping away the village of Circolo and running nearly to the sea at Ponte Madleni. There were then formed 10 small craters within the greater one. But these were united by a later eruption in 1888, and pressure from beneath formed a vast cone where they had been. Hardihood of the people. It may seem strange that so dangerous a neighborhood should be inhabited. But so it is. Though Pompeii, Herculaneum and Stabia lie buried beneath the mud and ashes belched out of the mouth of Vesuvius. The villages of Portisai and Ravenna, Torre del Greco and Torre dell'Annunziata have taken their place, and a large population, cheerful and prosperous, flourishes around the disturbed mountain and over the district of which it is the somewhat untrustworthy safety valve. It is thus that man, in his eagerness to cultivate all available parts of the earth, dares the most frightful perils and ventures into the most threatening situations, seeking to snatch the means of life from the very jaws of death. The danger is soon forgotten, the need of cultivation of the ground is ever pressing, and no threats of peril seem capable of restraining the activity of man for many years. Though the proposition of abandoning the island of Martinique has been seriously considered, the chances are that, before many years have passed, a cheerful and busy population will be at work again on the flanks of Mont Pili. Mount Etna. On the eastern coast of the island of Sicily, and not far from the sea, rises in solitary grandeur Mount Etna, the largest and highest of European volcanoes. Its height above the level of the sea is a little over 10,870 feet, considerably above the limit of perpetual snow. It accordingly presents the striking phenomenon of volcanic vapors ascending from a snow-clad summit. The base of the mountain is 87 miles in circumference, and nearly circular, but there is a wide additional extent all around overspread by its lava. The lower portions of the mountain are exceedingly fertile, and richly adorned with cornfields, vineyards, olive groves and orchards. Above this region are extensive forests, chiefly of oak, chestnut, and pine, with here and there clumps of cork trees and beech. In this forest region are grassy glades, which afford rich pasture to numerous flocks. Above the forest lies a volcanic desert, covered with black lava and slag. Out of this region, which is comparatively flat, rises the principal cone, about 1,100 feet in height, having on its summit the crater, whence sulfurous vapors are continually evolved. The great height of Etna has exerted a remarkable influence on its general conformation, for the volcanic forces have rarely been of sufficient energy to throw the lava quite up to the crater at the summit. The consequence has been that numerous subsidiary craters and cones have been formed all around the flanks of the mountain, so that it has become rather a cluster of volcanoes than a single volcanic cone. The eruptions of this mountain have been numerous, records of them extending back to several centuries before the Christian era, while unrecorded ones doubtless took place much further back. After the beginning of the Christian era, and more especially after the breaking forth of Vesuvius in 79 AD, Etna enjoyed longer intervals of repose. Its eruptions since that time have nevertheless been numerous, more especially during the intervals when Vesuvius was inactive, there being a sort of alternation between the periods of great activity of the two mountains. Although there are not a few instances of their having been both in action at the same time. Similarity in Etna's eruptions. There is a great similarity in the character of the eruptions of Etna. Earthquakes presage the outburst, loud explosions follow, rifts and Bac del Fuoco open in the sides of the mountain. Smoke, sand, ashes, and scoriae are discharged. The action localizes itself in one or more craters, cinders are thrown up and accumulate around the crater and cone, ultimately lava rises and frequently breaks down one side of the cone where the resistance is least, then the eruption is at an end. Smith says, the symptoms which precede an eruption are generally irregular clouds of smoke, feruli, or volcanic lightnings, hollow intonations and local earthquakes that often alarm the surrounding country as far as Messina, and have given the whole province the name of Valdemini, as being the abode of infernal spirits. These agitations increase until the vast cauldron becomes surcharged with the fused minerals. When, if the convulsion is not sufficiently powerful to force them from the great crater, which, from its great altitude and the weight of the candent matter, requires an uncommon effort, they explode through that part of the side which offers the least resistance with a grand and terrific effect, throwing red-hot stones and flakes of fire to an incredible height, and spreading ignited cinders and ashes in every direction. After the eruption of ashes, lava frequently follows, sometimes rising to the top of the cone of cinders, at others disrupting it on the least resisting side. When the lava has reached the base of the cone, it begins to flow down the mountain, and, being then in a very fluid state, it moves with great velocity. As it cools, the sides and surface begin to harden, its velocity decreases, and after several days it moves only a few yards an hour. The internal portions, however, part slowly with their heat, and months after the eruption clouds of steam arise from the black and externally cold lava beds after rain, which, having penetrated through the cracks, has found its way to the heated mass within. The eruption of 1669. The most memorable of the eruptions of Etna was that which elevated the double cone of Monte Rossi and destroyed a large part of the city of Catania. It happened in the year 1669, and was preceded by an earthquake, which overthrew the town of Nicolosi, situated 10 miles inland from Catania, and about 20 miles from the top of Etna. The eruption began with the sudden opening of an enormous fissure, extending from a little way above Nicolosi to within about a mile of the top of the principal cone, its length being 12 miles, its average breadth 6 feet, its depth unknown. We have a more detailed account of this eruption than of any preceding one, as it was observed by men of science from various countries. The account from which we select is that of Alfonso Borelli, professor of mathematics in Catania. From the fissure above mentioned, he says, there came a bright light. 6 mouths opened in a line with it and emitted vast columns of smoke, accompanied by loud bellowings which could be heard 40 miles off. Towards the close of the day a crater opened about a mile below the others, which ejected red-hot stones to a considerable distance, and afterward sand and ashes which covered the country for a distance of 6 miles. The new crater soon vomited forth a torrent of lava which presented a front of 2 miles, it encircled Montpellier, and afterward flowed towards Belpetto, a town of 8,000 inhabitants, which was speedily destroyed. 7 mouths of fire opened around the new crater, and in 3 days united with it, forming one large crater 800 feet in diameter. All this time the torrent of lava continued to descend, it destroying the town of Mascalucia on the 23rd of March. On the same day the crater cast up great quantities of sand, ashes, and scoriae, and formed above itself the great double-coned hill now called Monte Rossi, from the red color of the ashes of which it is mainly composed. Villages and cities buried. On the 25th very violent earthquakes occurred. and the cone above the great central crater was shaken down into the crater for the 5th time since the 1st century AD. The original current of lava divided into 3 streams, one of which destroyed San Pietro, the second Campo Rotondo, and the third the lands about Mascalucia and afterward the village of Mr. Bianco. 14 villages were altogether destroyed, and the lava flowed toward Catania. At Albanelli, 2 miles from the city, it undermined a hill covered with cornfields and carried it forward a considerable distance. A vineyard was also seen to be floating on its fiery surface. When the lava reached the walls of Catania, it accumulated without progression until it rose to the top of the wall, 60 feet in height, and it then fell over in a fiery cascade and overwhelmed a part of the city. Another portion of the same stream threw down 120 feet of the wall and flowed into the city. On the 23rd of April the lava reached the sea, which it entered as a stream 600 yards broad and 40 feet deep. The stream had moved at the rate of 13 miles in 20 days, but as it cooled it moved less quickly, and during the last 23 days of its course, it advanced only 2 miles. On reaching the sea the water, of course, began to boil violently, and clouds of steam arose, carrying with them particles of scoriae. Towards the end of April the stream on the west side of Catania, which had appeared to be consolidated, again burst forth, and flowed into the garden of the Benedictine monastery of San Nicola, and then branched off into the city. Attempts were made to build walls to arrest its progress. An attempt of another kind was made by a gentleman of Catania, named Pappalardo, who took 50 men with him, having previously provided them with skins for protection from the intense heat and with crowbars to effect an opening in the lava. They pierced the solid outer crust of solidified lava, and a rivulet of the molten interior immediately gushed out and flowed in the direction of Paterno, whereupon 500 men of that town, alarmed for its safety, took up arms and caused Pappalardo and his men to desist. The lava did not altogether stop for 4 months, and 2 years after it had ceased to flow it was found to be red-hot beneath the surface. Even 8 years after the eruption quantities of steam escaped from the lava after a shower of rain. The stones ejected. The stones which were ejected from the crater during this eruption were often of considerable magnitude, and Borelli calculated that the diameter of one which he saw was 50 feet. It was thrown to a distance of a mile, and as it fell it penetrated the earth to a depth of 23 feet. The volume of lava emitted during the eruption amounted to many millions of cubic feet. Ferreira considers that the length of the stream was at least 15 miles, while its average width was between 2 and 3 miles, so that it covered at least 40 square miles of surface. Among the towns overflowed by this great eruption was Montpellier. 35 years afterward, in 1704, an excavation was made on the site of the principal church of this place, and at the depth of 35 feet the workmen came upon the gate, which was adorned with 3 statues. From under an arch which had been formed by the lava, one of these statues, with a bell and some coins, were extracted in good preservation. This fact is remarkable, for in a subsequent eruption, which happened in 1766, a hill about 50 feet in height, being surrounded on either side by 2 streams of lava, was in a quarter of an hour swept along by the current. The latter event may be explained by supposing that the hill in question was cavernous in its structure, and that the lava, penetrating into the cavities, forced asunder their walls, and so detached the superincumbent mess from its supports. It is not by its streams of fire alone that Etna ravages the valleys and plains at its base. It sometimes also deluges them with great floods of water. On the 2nd of March, 1755, 2 streams of lava, issuing from the highest crater, were at once precipitated on an enormous mass of very deep snow, which then clothed the summit. These fiery currents ran through the snow to a distance of 3 miles, melting it as they flowed. The consequence was that a tremendous torrent of water rushed down the sides of the mountain, carrying with it vast quantities of sand, volcanic cinders, and blocks of lava, with which it overspread the flanks of the mountain and the plains beneath, which it devastated in its course. The volume of water was estimated at 16 million cubic feet, it forming a channel 2 miles broad and in some places 34 feet deep, and flowing at the rate of 2 yards of a mile in a minute. All the winter's snow on the mountain could not have yielded such a flood, and Lyell considered that it melted older layers of ice which had been preserved under a covering of volcanic dust. Etna in 1819. Another great eruption took place in 1819, which presented some peculiarities. Near the point whence the highest stream of lava issued in 1811, there were opened 3 large mouths, which, with loud explosions, threw up hot cinders and sand, illuminated by a strong glare from beneath. Shortly afterwards there was opened, a little lower down, another mouth, from which a similar eruption took place. And still farther down there soon appeared a 5th, whence there flowed a torrent of lava which rapidly spread itself over the Val d'Elbove. During the first 48 hours it flowed nearly 4 miles, when it received a great accession. The 3 original mouths became united into one large crater, from which, as well as from the other 2 mouths below, there poured forth a vastly augmented torrent of lava, which rushed with great impetuosity down the same valley. During its progress over this gentle slope, it acquired the usual crust of hardened slag. It directed its course towards that point at which Val d'Elbove opens into the narrow ravine beneath it, there being between the 2 a deep and almost perpendicular precipice. Arrived at this point, the lava torrent leaped over the precipice in a vast cascade, and with a thundering noise, arising chiefly from the crashing and breaking up of the solid crust, which was in a great measure pounded to atoms by the fall. It throwing up such vast clouds of dust as to awaken an alarm that a fresh eruption had begun at this place, which is within the wooded region. A very violent eruption, which lasted more than 9 months, commenced on the 21st of August, 1852. It was first witnessed by a party of English tourists, who were ascending the mountain from Nicolosi in order to see the sunrise from the summit. As they approached the Casa Inglesi, the crater commenced to give forth ashes and flames of fire. In a narrow defile they were met by a violent hurricane, which overthrew both the mules and their riders, and urged them toward the precipices of the Val d'Elbove. They sheltered themselves beneath some masses of lava, when suddenly an earthquake shook the mountain, and their mules in terror fled away. As day approached they returned on foot to Nicolosi, fortunately without having sustained injury. In the course of the night many Bac del Fuoco, small lava vents, opened in that part of the Val d'Elbove called the Bazzo di Trifoglietto. A great fissure opened at the base of the Gian Nicola Grande, and a crater was thrown up from which for 17 days showers of sand and scoriae were ejected. Effect of the eruption. During the next day a quantity of lava flowed down the Val d'Elbove, branching off so that one stream advanced to the foot of Monte Finocchio, and the other to Monte Calina. Afterwards it flowed towards Zaffarana, and devastated a large tract of wooded region. 4 days later a second crater was formed near the first, from which lava was emitted, together with sand and scoriae, which caused cones to arise around the craters. The lava moved but slowly, and towards the end of August it came to a stand, only a quarter of a mile from Zaffarana. On the 2nd of September, Gemellero ascended Monte Finocchio in the Val d'Elbove in order to witness the outburst. He states that the hill was violently agitated, like a ship at sea. The surface of the Val d'Elbove appeared like a molten lake, scoriae were thrown up from the craters to a great height, and loud explosions were heard at frequent intervals. The eruption continued to increase in violence. On October 6 2 new mouths opened in the Val d'Elbove, emitting lava which flowed towards the valley of Calina, and fell over the Salto della Giamenta, a precipice nearly 200 feet deep. The noise which it produced was like that of a clash of metallic masses. The eruption continued with abated violence during the early months of 1853, and it did not finally cease till May 27. The entire mass of lava ejected is estimated to have been equal to an area 6 miles long by 2 miles broad, with an average depth of about 12 feet. This eruption was one of the grandest of all the known eruptions of Etna. During its outflow more than 2 billion cubic feet of molten lava was spread out over a space of 3 square miles. There have been several eruptions since its date, but none of marked prominence, though the mountain is rarely quiescent for any lengthened period. The Lipari volcanoes. Southeastward of Ischia, between Calabria and Sicily, the Lipari Islands arrest attention for the volcanic phenomena they present. On one of these is Mount Volcano, or Volcano, from which all this class of mountains is named. At present the best known of the Lipari volcanoes is Stromboli, which consists of a single mountain, having a very obtuse conical form. It has on one side of it several small craters, of which only one is at present in a state of activity. The total height of the mountain is about 2,000 feet, and the principal crater is situated at about 2/3 of the height. Stromboli is one of the most active volcanoes in the world. It is mentioned as being in a state of activity by several writers before the Christian era, and the commencement of its operations extends into the past beyond the limits of tradition. Since history began, its action has never wholly ceased, although it may have varied in intensity from time to time. It has been observed that the violence of its eruptive force has a certain dependence on the weather being always most intense when the barometer is lowest. From the position of the crater, it is possible to ascend the mountain and look down upon it from above. Even when viewed in this manner, it presents a very striking appearance. While there is an uninterrupted continuance of small explosions, there is a frequent succession of more violent eruptions, at intervals varying in length from 7 to 15 minutes. Hoffman at Stromboli. Several eminent observers have approached quite close to the crater, and examined it narrowly. One of these was M. Hoffman, who visited it in 1828. This eminent geologist, while having his legs held by his companions, stretched his head over the precipice, and, looking right down into the mouth of one of the vents of the crater immediately under him, watched the play of liquid lava within it. Its surface resembled molten silver, and was constantly rising and falling at regular intervals. A bubble of white vapor rose and escaped, with a decrepitating noise, at each ascent of the lava, tossing up red-hot fragments of scoria, which continued dancing up and down with a sort of rhythmic play upon the surface. At intervals of 15 minutes or so, there was a pause in these movements. Then followed a loud report, while the ground trembled, and there rose to the surface of the lava an immense bubble of vapor. This, bursting with a crackling noise, threw out to the height of about 1,200 feet large quantities of red-hot stones and scoriae, which, describing parabolic curves, fell in a fiery shower all around. After another brief repose, the more moderate action was resumed as before. Lipari, a neighboring volcano, was formerly more active than Stromboli, though for centuries past it has been in a state of complete quiescence. The island of Volcano lies south of Lipari. Its crater was active before the Christian era, and still emits sulfurous and other vapors. At present its main office is to serve as a sulfur mine. Thus the peak which gives title to all fire-breathing mountains has become a servant to man. So are the mighty fallen. Chapter XXIII. Skaptur Jökull and Hekla, the great Icelandic volcanoes. The far northern island of Iceland, on the verge of the frozen Arctic realm, is one of the most volcanic countries in the world, whether we regard the number of volcanoes concentrated in so small a space, or the extraordinary violence of their eruptions. Of volcanic mountains there are no less than 20 which have been active during historical times. Skaptur in the north, and Hekla in the south, being much the best known. In all, 23 eruptions are on record. Iceland's volcanoes rival Mount Etna in height and magnitude. Their action has been more continuous and intense, and the range of volcanic products is far greater than in Sicily. The latter island, indeed, is not 1/10 of volcanic origin, while the whole of Iceland is due to the work of subterranean forces. It is entirely made up of volcanic rocks, and has seemingly been built up during the ages from the depths of the seas. It is reported, indeed, that a new island, the work of volcanic forces, appeared opposite Mount Hekla in 1563, but this statement is open to doubt. Volcanoes in Iceland. The eruptions of the volcanoes in Iceland have been amongst the most terrible of those carefully recorded. The cold climate of the island and the height of the mountains produce vast quantities of snow and ice, which cover the volcanoes and fill up the cracks and valleys in their sides. When, therefore, an eruption commences, the intense heat of the boiling lava, and of the steam which rushes forth from the crater, makes the whole mountain hot, and vast masses of ice, great fields of snow, and deluges of water roll down the hillsides into the plains. The lava pours from the top and from cracks in the side of the mountain, or is ejected hundreds of feet, to fall amongst the ice and snow. And the great masses of red-hot stone cast forth, accompanied by cinders and fine ashes, splash into the roaring torrent, which tears up rocks in its course and devastates the surrounding country for miles. Dreadful floods. An eruption of Kot Lugja, in 1860, was accompanied by dreadful floods. It began with a number of earthquakes, which shook the surrounding country. Then a dark columnar cloud of vapor was seen to rise by day from the mountain, and by night balls of fire, volcanic bombs, and red-hot cinders to the height of 24,000 feet, nearly 5 miles, which were seen at a distance of 180 miles. Deluges of water rushed from the heights, bearing along whole fields of ice and rocky fragments of every size, some vomited from the volcano, but in great part torn from the flanks of the mountain itself and carried to the sea, there to add considerably to the coastline after devastating the intervening country. The fountain of volcanic bombs consisted of masses of lava, containing gases which exploded and produced a loud sound, which was said to have been heard at a distance of 100 miles. The size of the bombs, and the height to which they must have reached, were very great. But the most remarkable of the historical eruptions in Iceland were those of Skaptur Jökull in 1783, and of Hekla in 1845. Of these an extended description is worthy of being given. Of these two memorable eruptions, that of Skaptur Jökull began on the 11th of June, 1783. It was preceded by a long series of earthquakes, which had become exceedingly violent immediately before the eruption. On the 8th, volcanic vapors were emitted from the summit of the mountain, and on the 11th immense torrents of lava began to be poured forth from numerous mouths. These torrents united to form a large stream, which, flowing down into the river Skapta, not only dried it up, but completely filled the vast gorge through which the river had held its course. This gorge, 200 feet in breadth, and from 400 to 600 feet in depth, the lava filled so entirely as to overflow to a considerable extent the fields on either side. On issuing from this ravine, the lava flowed into a deep lake which lay in the course of the river. Here it was arrested for a while, but it ultimately filled the bed of the lake altogether, either drying up its waters, or chasing them before it into the lower part of the river's course. Still forced onward by the accumulation of molten lava from behind, the stream resumed its advance, till it reached some ancient volcanic rocks which were full of caverns. Into these it entered, and where it could not eat its way by melting the old rock, it forced a passage by shivering the solid mass and throwing its broken fragments into the air to a height of 150 feet. A torrent of lava. On the 18th of June there opened above the first mouth a second of large dimensions, whence poured another immense torrent of lava, which flowed with great rapidity over the solidified surface of the first stream, and ultimately combined with it to form a more formidable main current. When this fresh stream reached the fiery lake, which had filled the lower portion of the valley of the Skapta, a portion of it was forced up the channel of that river towards the foot of the hill whence it takes its rise. After pursuing its course for several days, the main body of this stream reached the edge of a great waterfall called Stapa, which plunged into a deep abyss. Displacing the water, the lava here leaped over the precipice, and formed a great cataract of fire. After this, it filled the channel of the river, though extending itself in breadth far beyond it, and followed it until it reached the sea. Enormous quantity of lava. The 3rd of August brought fresh accessions to the flood of lava still pouring from the mountain. There being no room in the channel, now filled by the former lurid stream, which had pursued a northwesterly course, the fresh lava was forced to take a new direction towards the southeast, where it entered the bed of another river with a barbaric name. Here it pursued a course similar to that which flowed through the channel of the Skapta, filling up the deep gorges, and then spreading itself out into great fiery lakes over the plains. The eruptions of lava from the mountain continued, with some short intervals, for 2 years, and so enormous was the quantity poured forth during this period that, according to a careful estimate which has been made, the whole together would form a mass equal to that of Mont Blanc. Of the two streams, the greater was 50, the less 40, miles in length. The Skapta branch attained on the plains a breadth varying from 12 to 15 miles, that of the other was only about half as much. Each of the currents had an average depth of 100 feet, but in the deep gorges it was no less than 600 feet. Even as late as 1794 vapors continued to rise from these great streams, and the water contained in the numerous fissures formed in their crust was hot. The devastation directly wrought by the lava currents themselves was not the whole of the evils they brought upon unfortunate Iceland and its inhabitants. Partly owing to the sudden melting of the snows and glaciers of the mountain, partly owing to the stoppage of the river courses, immense floods of water deluged the country in the neighborhood, destroying many villages and a large amount of agricultural and other property. 20 villages were overwhelmed by the lava currents, while the ashes thrown out during the eruption covered the whole island and the surface of the sea for miles around its shores. On several occasions the ashes were drifted by the winds over considerable parts of the European continent, obscuring the sun and giving the sky a gray and gloomy aspect. In certain respects they reproduced the phenomena of the explosion of Mount Krakatoa, which, singularly, occurred just a century later, in 1883. The strange red sunset phenomena of the latter were reproduced by this Icelandic event of the 18th century. Out of the 50,000 persons who then inhabited Iceland, 9,336 perished, together with 11,460 head of cattle, 190,480 sheep, and 28,000 horses. This dreadful destruction of life was caused partly by the direct action of the lava currents, partly by the noxious vapors they emitted, partly by the floods of water, partly by the destruction of the herbage by the falling ashes, and lastly in consequence of the desertion of the coasts by the fish, which formed a large portion of the food of the people. Eruption of Mount Hekla. After this frightful eruption, no serious volcanic disturbance took place in Iceland until 1845, when Mount Hekla again became disastrously active. Mount Hekla has been the most frequent in its eruptions of any of the Icelandic volcanoes. Previous to 1845 there had been 22 recorded eruptions of this mountain, since the discovery of Iceland in the 9th century, while from all the other volcanoes in the island there had been only 20 during the same period. Hekla has more than once remained in activity for 6 years at a time, a circumstance that has rendered it the best known of the volcanoes of this region. Later outbreaks. After enjoying a long rest of 79 years, this volcano burst again into violent activity in the beginning of September, 1845. The first inkling of this eruption was conveyed to the British Islands by a fall of volcanic ashes in the Orkneys, which occurred on the night of September 2 during a violent storm. This palpable hint was soon confirmed by direct intelligence from Copenhagen. On the 1st of September a severe earthquake, followed the same night by fearful subterranean noises, alarmed the inhabitants and gave warning of what was to come. About noon the next day, with a dreadful crash, there opened in the sides of the volcano 2 new mouths, whence 2 great streams of glowing lava poured forth. They fortunately flowed down the northern and northwestern sides of the mountain, where the low grounds are mere barren heaths, affording a scanty pasture for a few sheep. These were driven before the fiery stream, but several of them were burnt before they could escape. The whole mountain was enveloped in clouds of volcanic ashes and vapors. The rivers near the lava currents became so hot as to kill the fish, and to be impassable even on horseback. About a fortnight later there was a fresh eruption, of greater violence, which lasted 22 hours, and was accompanied by detonations so loud as to be heard over the whole island. 2 new craters were formed, one on the southern, the other on the eastern slope of the cone. The lava issuing from these craters flowed to a distance of more than 22 miles. At about 2 miles from its source the fiery stream was a mile wide, and from 40 to 50 feet deep. It destroyed a large extent of fine pasture and many cattle. Nearly a month later, on the 15th of October, a fresh flood of lava burst from the southern crater, and soon heaped up a mass at the foot of the mountain from 40 to 60 feet in height, 3 great columns of vapor, dust, and ashes rising at the same time from the 3 new craters of the volcano. The mountain continued in a state of greater or less activity during most of the next year, and even as late as the month of October, 1846, after a brief pause, it began again with renewed vehemence. The volumes of dust, ashes, and vapor, thrown up from the craters, and brightly illuminated by the glowing lava beneath, assumed the appearance of flames, and ascended to an immense height. Electric phenomena. Among the stones tossed out of the craters was one large mass of pumice weighing nearly half a ton, which was carried to a distance of between 4 and 5 miles. The rivers were flooded by the melting of ice and snow which had accumulated on the mountain. The greatest mischief wrought by these successive eruptions was the destruction of the pasturages, which were for the most part covered with volcanic ashes. Even where left exposed, the herbage acquired a poisonous taint which proved fatal to the cattle, inducing among them a peculiar murrain. Fortunately, owing to the nature of the district through which the lava passed, there was on this occasion no loss of human life. The Icelandic volcanoes are remarkable for the electric phenomena which they produce in the atmosphere. Violent thunderstorms, with showers of rain and hail, are frequent accompaniments of volcanic eruptions everywhere. But owing to the coldness and dryness of the air into which the vapors from the Icelandic volcanoes ascend, their condensation is so sudden and violent that great quantities of electricity are developed. Thunderstorms accompanied by the most vivid lightnings are the result. Humboldt mentions in his Cosmos that, during an eruption of Kotlugja, one of the southern Icelandic volcanoes, the lightning from the cloud of volcanic vapor killed 11 horses and 2 men, Cosmos I 223. Great displays of the aurora borealis usually accompany the volcanic eruptions of this island, doubtless resulting from the quantity of electricity imparted to the higher atmosphere by the condensation of the ascending vapors. On the 18th of August, 1783, while the great eruption of Skaptur Jökull was in progress, an immense fireball passed over England and the European continent as far as Rome. This ball, which was estimated to have had a diameter exceeding half a mile, is supposed to have been of electrical origin, and due to the high state of electric tension in the atmosphere over Iceland at that time. Chapter XXIV. Volcanoes of the Philippines and other Pacific Islands. We cannot do better than open this chapter with an account of the work of volcanoes in the mountain-girdled East Indian island of Java. This large and fertile tropical island has a large native population, and many European settlers are employed in cultivating spices, coffee, and woods. The island is rather more than 600 miles long, and it is not 150 miles broad in any part, and this narrow shape is produced by a chain of volcanoes which runs along it. There is scarcely any other region in the world where volcanoes are so numerous, even in the East, where the volcano is a very common product of nature. Some of the volcanoes of Java are constantly in eruption, while others are inactive. One of their number, Galunggung, was previous to 1822 covered from top to bottom with a dense forest. Around it were populous villages. The mountain was high. There was a slight hollow on its top, a basin-like valley, carpeted with the softest sward. Brooks rippled down the hillside through the forests, and, joining their silvery streams, flowed on through beautiful valleys into the distant sea. In the month of July, 1822, there were signs of an approaching disturbance. This tranquil peacefulness was at an end. One of the rivers became muddy, and its waters grew hot. In October, without any warning, a most terrific eruption occurred. A loud explosion was heard. The earth shook, and immense columns of hot water, boiling mud mixed with burning brimstone, ashes, and stones, were hurled upwards from the mountain top like a waterspout, and with such wonderful force that large quantities fell at a distance of 40 miles. Every valley near the mountain became filled with burning torrents. The rivers, swollen with hot water and mud, overflowed their banks, and swept away the escaping villagers, and the bodies of cattle, wild beasts, and birds were carried down the flooded stream. Eruption of Galunggung. A space of 24 miles between the mountain and a river 40 miles distant was covered to such a depth with blue mud, that people were buried in their houses, and not a trace of the numerous villages and plantations was visible. The boiling mud and cinders were cast forth with such violence from the crater, that while many distant villages were utterly destroyed and buried, others much nearer the volcano were scarcely injured, and all this was done in 5 short hours. 4 days afterwards a second eruption occurred more violent than the first, and hot water and mud were cast forth with masses of slag like the rock called basalt, some of which fell 7 miles off. A violent earthquake shook the whole district, and the top of the mountain fell in, and so did one of its sides, leaving a gaping chasm. Hills appeared where there had been level land before, and the rivers changed their courses, drowning in one night 2,000 people. At some distance from the mountain a river runs through a large town. And the first intimation the inhabitants had of all this horrible destruction was the news that the bodies of men and the carcasses of stags, rhinoceroses, tigers, and other animals were rushing along to the sea. No less than 114 villages were destroyed, and above 4,000 persons were killed by this terrible catastrophe. 50 years before this eruption, Mount Papandayang, one of the highest burning mountains of Java, was constantly throwing out steam and smoke, but as no harm was done, the natives continued to live on its sides. Suddenly this enormous mountain fell in, and left a gap 15 miles long and 6 broad. 40 villages were destroyed, some being carried down and others overwhelmed by mud and burning lava. No less than 2,957 people perished, with vast numbers of cattle. Moreover, most of the coffee plantations in the neighboring districts were destroyed. Even more terrible was the eruption of Mount Salak, another of the volcanoes of Java. The burning of the mountain was seen 100 miles away, while the thunders of its convulsions and the tremblings of the earth reached the same distance. 7 hills, at whose base ran a river crowded with dead buffaloes, deer, apes, tigers, and crocodiles slipped down and became a level plain. River courses were changed, forests were burnt up, and the whole face of the country was completely altered. Later volcanic eruptions in Java include that of 1843. When Mount Guntur flung out sand and ashes estimated at the vast total of 30 million tons. And those of 1849 and 1872, when Mount Merapi, a very active volcano, covered a great extent of country with stones and ashes, and ruined the coffee plantations of the neighboring districts. We have said nothing concerning the most terrible explosion of all, that of the volcanic island of Krakatoa, off the Javan coast. This event was so phenomenal as to deserve a chapter of its own, for which we reserve it. The United States, as one result of its recent acquisition of island dominions, has added largely to its wealth in volcanic mountains. The famous Hawaiian craters, far the greatest in the world, now belong to our national estate, and the Philippine Islands contain various others, of less importance, yet some of which have proved very destructive. A description of those of the island of Luzon, which are the most active in the archipelago, is here subjoined. The Luzon volcanoes. Volcanoes have played an important part in the formation of the Philippine Islands and have left traces of their former activity in all directions. Most of them, however, have long been dead and silent, only a few of the once numerous group being now active. Of these there are 3 of importance in the southern region of Luzon: Tal, Biolusan, and Mayon or Albay. The last named of these is the largest and most active of the existing volcanoes. In form it is of marvelous grace and beauty, forming a perfect cone, about 50 miles in circuit at base and rising to a height of 8,900 feet. It is one of the most prominent landmarks to navigators in the island. From its crater streams upward a constant smoke, accompanied at times by flame, while from its depths issue subterranean sounds, often heard at a distance of many leagues. The whole surrounding country is marked by evidences of old eruptions. This mountain, in 1767, sent up a cone of flame of 40 feet in diameter at base, for 10 days, and for 2 months a wide stream of lava poured from its crater. A month later there gushed forth great floods of water, which filled the rivers to overflow, doing widespread damage to the neighboring plantations. But its greatest and most destructive eruption took place in 1812, the year of the great eruption of the St. Vincent volcano. On this fatal occasion, several towns were destroyed and no less than 12,000 people lost their lives. The debris flung forth from the crater were so abundant that deposits deep enough to bury the tallest trees were formed near the mountain. In 1867 another disastrous explosion took place, and still another in 1888. A disaster different in kind and cause occurred in 1876, when a terrible tropical storm burst upon the mountain. The floods of rain swept from its sides the loose volcanic material, and brought destruction to the neighboring country, more than 6,000 houses being ruined by the rushing flood. Biolusin and Tal. Biolusin, a volcano on the southern extremity of the island, resembles Vesuvius in shape. For many years it remained dormant, but in 1852 smoke began to issue from its crater. In some respects the most interesting of these three volcanoes is that of Tal, which lies almost due south of Manila and about 45 miles distant, on a small island in the middle of a large lake, known as Bombom or Bongbong. A remarkable feature of this volcanic mountain is that it is probably the lowest in the world, its height being only 850 feet above sea level. There are doubtful traditions that Lake Bombom, 100 square miles in extent, was formed by a terrible eruption in 1700, by which a lofty mountain 8,000 or 9,000 feet high, was destroyed. The vast deposits of porous tufa in the surrounding country are certainly evidences of former great eruptions from Mount Tal. The crater of this volcano is an immense, cup-shaped depression, a mile or more in diameter and about 800 feet deep. When recently visited by Professor Worcester, during his travels in these islands, he found it to contain 3 boiling lakelets of strangely colored water, one being of a dirty brown hue, a second intensely yellow in tint, and the third of a brilliant emerald green. The mountain still steams and fumes, as if too actively at work below to be at rest above. In past times it has shown the forces at play in its depths by breaking at times into frightful activity. Of the various explosions on record, the 3 most violent were those of 1716, 1749, and 1754. In the last named year the earth for miles round quaked with the convulsive throes of the deeply disturbed mountain, and vast quantities of volcanic dust were hurled high into the air, sufficient to make it dark at midday for many leagues around. The roofs of distant Manila were covered with volcanic dust and ashes. Molten lava also poured from the crater and flowed into the lake, which boiled with the intense heat, while great showers of stones and ashes fell into its waters. Volcanoes in the southern islands. Extinct volcanoes are numerous in Luzon, and there are smoking cones in the north, and also in the Babuyan's Islands still farther north. Volcanoes also exist in several of the other islands. On Negros is the active peak of Malaspina, and on Camigan, an island about 90 miles to the southeast, a new volcano broke out in 1876. The large island of Mindanao has 3 volcanoes, of which Cotabato was in eruption in 1856 and is still active at intervals. Apo, the largest of the 3, estimated to be 10,312 feet high, has 3 summits, within which lies the great crater, now extinct and filled with water. In evidence of former volcanic activity are the abundant deposits of sulfur on the island of Leyte, the hot springs in various localities, and the earthquakes which occasionally bring death and destruction. Of the many of these on record, the most destructive was in 1863, when 400 people were killed and 2,000 injured, while many buildings were wrecked. Another in 1880 wrought great destruction in Manila and elsewhere, though without loss of life. An earthquake in Mindanao in 1675 opened a passage to the sea, and a vast plain emerged. These convulsions of the earth affect the form and elevation of buildings, which are rarely more than 2 stories high and lightly built, while translucent seashells replace glass in their windows. While Java is the most prolific in volcanoes of the islands of the Malayan archipelago, other islands of the group possess active cones, including Sumatra, Bali, Amboyna, Bunda, and others. In Sanguir, an island north of Celebes, is a volcanic mountain from which there was a destructive eruption in 1856. The country was devastated with lava, stones, and volcanic ashes, ruining a wide district and killing nearly 3,000 of the inhabitants. Mount Madrian in one of the Spice Islands was rent in twain by a fierce eruption in 1646, and since then has remained two distinct mountains. It became active again in 1862, after 2 centuries of repose, and caused great loss of life and property. Saria, a small island of the same group, forming but a single volcanic mountain, had an eruption in 1693, the cone crumbling gradually till a vast crater was formed, filled with liquid lava and occupying nearly half the island. This lake of fire increased in size by the same process till in the end it took possession of the island and forced all the inhabitants to flee to more hospitable shores. The Great Eruption of Tambora. But of the East Indian islands, Sumbawa, lying east of Java, contains the most formidable volcano, one indeed scarcely without a rival in the world. This is named Tambora. Of its various eruptions, the most furious on record was that of 1815. This, as we are told by Sir Stamford Raffles, far exceeded in force and duration any of the known outbreaks of Etna or Vesuvius. The ground trembled and the echoes of its roar were heard through an area of 1,000 miles around the volcano, and to a distance of 300 miles its effects were astounding. In Java, 300 miles away, ashes filled the air so thickly that the solar rays could not penetrate them, and fell to the depth of several inches. The detonations were so similar to the reports of artillery as to be mistaken for them. The Raja of Sangayar, who was an eyewitness of the eruption, thus described it to Sir Stamford. About 7 p.m. on the 10th of April, 3 distinct columns of flame burst forth near the top of the Tambora mountain, all of them apparently within the verge of the crater. And, after ascending separately to a very great height, their tops united in the air in a troubled, confused manner. In short time the whole mountain next Sangayar appeared like a body of liquid fire, extending itself in every direction. The fire and columns of flame continued to rage with unabated fury, until the darkness caused by the quantity of falling matter obscured them. At about 8 p.m. stones at this time fell very thick at Sangayar, some of them as large as 2 fists, but generally not larger than walnuts. Between 9 and 10 p.m. ashes began to fall, and soon after a violent whirlwind ensued, which blew down nearly every house in the village of Sangayar, carrying the roofs and light parts away with it. In the port of Sangayar, adjoining Tambora, its effects were much more violent, tearing up by the roots the largest trees, and carrying them into the air, together with men, horses, cattle, and whatever else came within its influence. This will account for the immense number of floating trees seen at sea. The sea rose nearly 12 feet higher than it had ever been known to do before, and completely spoiled the only spots of rice land in Sangayar, sweeping away houses and everything within its reach. The whirlwind lasted about an hour. No explosions were heard till the whirlwind had ceased, at about 11 p.m. From midnight till the evening of the 11th, they continued without intermission. After that time their violence moderated, and they were heard only at intervals, but the explosions did not cease entirely until the 15th of July. Of all the villages of Tambora, Tempo, containing about 40 inhabitants, is the only one remaining. In Pekate no vestige of a house is left. 26 of the people, who were at Sumbawa at the time, are the whole of the population who have escaped. From the most particular inquiries I have been able to make, there were certainly no fewer than 12,000 individuals in Tambora and Pekate at the time of the eruption, of whom only 5 or 6 survive. The trees and herbage of every description, along the whole of the north and west sides of the peninsula, have been completely destroyed, with the exception of those on a high point of land, near the spot where the village of Tambora stood. Tambora village was not only invaded by the sea on this occasion, but its site permanently subsided, so that there is now 18 feet of water where there was formerly dry land. The volcanoes of Japan. The Japanese archipelago, as stated in an earlier chapter, is abundantly supplied with volcanoes, a number of them being active. Of these the best known to travelers is Asamayama, a mountain 8,500 feet high, of which there are several recorded eruptions. The first of these was in 1650, after which the volcano remained feebly active till 1783, when it broke out in a very severe eruption. In 1870 there was another of some severity, accompanied by violent shocks of earthquake felt at Yokohama. The crater is very deep, with irregular rocky walls of a sulfurous character. Far the most famous of all the Japanese mountains, however, is that named Fuji-san, but commonly termed in English Fujiyama or Fusiyama. It is in the vicinity of the capital, and is the most prominent object in the landscape for many miles around. The apex is shaped somewhat like an 8-petaled lotus flower, and offers to view from different directions from 3 to 5 peaks. Though now apparently extinct, it was formerly an active volcano, and is credited in history with several very disastrous eruptions. The last of these was in 1707, at which time the whole summit burst into flames. Rocks were split and shattered by the heat, and stones fell to the depth of several inches in Yedo, now Tokyo, 60 miles away. At present there are in its crater, which has a depth of 700 or 800 feet, neither sulfurous exhalations nor steam. According to Japanese tradition, this great peak was upheaved in a single night from the bottom of the sea, more than 2100 years ago. Nothing can be more majestic than this volcano, extinct though it be, rising in an immense cone from the plain to the height of over 12,000 feet, truncated at the top, and with its peak almost always snow-covered. Its ascent is not difficult to an expert climber, and has frequently been made. From its summit is unfolded a panorama beyond the power of words to describe, and probably the most remarkable on the globe. Mountains, valleys, lakes, forests, and the villages of 13 counties may be seen, as we gaze upon its beautifully shaped and lofty mass. Visible even from Yokohama and 100 miles at sea, one does not wonder that it should be regarded as a holy mountain, and that it should form a conspicuous object in every Japanese work of art. It is to the natives of Japan as Mont Blanc is to Europeans, the monarch of mountains. In summer pilgrimages are made around the base of the summit elevation, and there are on the upward path a number of Buddhist temples and shrines, made of blocks of stone, for devotion, shelter, and the storage of food for pilgrims. Hakone Lake is 3,000 feet above the sea, and probably lies in the crater of an extinct volcano. Its waters are very deep, it is several miles long and wide, and is surrounded by high hills which abound in fine scenery, solfataras, and mineral springs. Hot springs near Hakone Lake. At this place the mountain seems to be smoldering, as sulfur fumes and steam issue at many points, and the ground is covered with a friable white alkaline substance. In many a hollow the water bubbles with clouds of vapor and sulfur and hydrogen. Here the soil is hot and evidently underlaid by active fires. It is not safe to go very near, as the crust is thin and crumbling. The water running down the hills has a refreshing sound and a tempting clearness, but the thirsty tongue at once detects it to be a very strong solution of alum. The whole aspect of the place is infernal, and naturally suggests the name given its principal geyser, Ojigako, Big Hell. Fujiyama is almost a perfect cone, with, as above said, a truncated top, in which is the crater. It is, however, less steep than Mayon. Its upper part is comparatively steep, even to 35 degrees, but below this portion the inclination gradually lessens, till its elegant outlines are lost in the plain from which it rises. The curves of the sides depend partly on the nature, size and shape of the ejected material. The fine uniform pieces remaining on comparatively steep slopes, while the larger and rounder ones roll farther down, resting on the inclination that afterward becomes curved from the subsidence of the central mass. The most recent and one of the most destructive of volcanic eruptions recorded in Japan was that of Bandazan or Baldazan. For ages this mountain had been peaceful, and there was scarcely an indication of its volcanic character or of the terrific forces which lay dormant deep within its heart. On its flanks lay some small deposits of scoriae, indications of far past eruptions, and there were some hot springs at its base, while steam arose from a fissure. Yet there was nothing to warn the people of the vicinity that deadly peril lay under their feet. Bandazan's work of terror. This sense of security was fatally dissipated on a day in July 1888, when the mountain suddenly broke into eruption and flung 1,600 million cubic yards of its summit material so high into the air that many of the falling fragments, in their fall, struck the ground with such velocity as to be buried far out of sight. The steam and dust were driven to a height of 13,000 feet, where they spread into a canopy of much greater elevation, causing pitchy darkness beneath. There were from 15 to 20 violent explosions, and a great landslide devastated about 30 square miles and buried many villages in the Nagas Valley. Mr. Norman, a traveler who visited the spot shortly afterward, thus describes the scene of ruin. After a journey through the forests which clothed the slopes of the volcanic mountain and prevented any distant view, the travelers at last found themselves standing upon the ragged edge of what was left of the mountain of Bandazan, after 2/3 of it, including, of course, the summit, had been literally blown away and spread over the face of the country. The original cone of the mountain, he continues, had been truncated at an acute angle to its axis. From our very feet a precipitous mud slope falls away for half a mile or more till it reaches the level. At our right, still below us, rises a mud wall a mile long, also sloping down to the level, and behind it is evidently the crater. But before us, for 5 miles in a straight line, and on each side nearly as far, is a sea of congealed mud, broken up into ripples and waves and great billows, and bearing upon its bosom 1,000 huge boulders, weighing hundreds of tons apiece. On reaching the crater he found it to resemble a gigantic cauldron, fully a mile in width, and enclosed with precipitous walls of indurated mud. From several orifices volumes of steam rose into the air, and when the vapor cleared away for a moment glimpses of a mass of boiling mud were obtained. Before the eruption the mountain top had terminated in 3 peaks. Of these the highest had an elevation of about 5,800 feet. The peak destroyed was the middle one, which was rather smaller than the other 2. The explosion was caused by steam, there was neither fire nor lava of any kind. It was, in fact, nothing more nor less than a gigantic boiler explosion. The whole top and one side of Bandazan had been blown into the air in a lateral direction, and the earth of the mountain was converted by the escaping steam, at the moment of the explosion, into boiling mud, part of which was projected into the air to fall at a long distance, and then take the form of an overflowing river, which rushed with vast rapidity and covered the country to a depth of from 20 to 150 feet. 30 square miles of country were thus devastated. In the devastated lowlands and buried villages below and on the slopes of the mountain many lives were lost. From the survivors Mr. Norman gathered some information, enabling him to describe the main features of the catastrophe. We append a brief outline of his narrative. Mr. Norman's narrative. At a few minutes past 8 o'clock in the morning a frightful noise was heard by the inhabitants of a village 10 miles distant from the crater. Some of them instinctively took to flight, but before they could run much more than 100 yards the light of day was suddenly changed into a darkness more intense than that of midnight. A shower of blinding hot ashes and sand poured down upon them, the ground was shaken with earthquakes, and explosion followed explosion, the last being the most violent of all. Many fugitives, as well as people in the houses, were overwhelmed by the deluge of mud, none of the fugitives, when overtaken by death, being more than 200 yards from the village. From the statements made by those fortunate enough to escape with their lives, and from a personal examination of the ground, Mr. Norman inferred that the mud must have been flung fully 6 miles through the air and then have poured in a torrent along the ground for 4 miles further. All this was done in less than 5 minutes, so that millions of tons of boiling mud were hurled over the country at the rate of 2 miles a minute. The velocity of the mud torrent may perhaps be overestimated, but in its awful suddenness this catastrophe was evidently one with few equals. The cone destroyed may have been largely composed of rather fine ashes and scoriae, which was almost instantaneously converted into mud by the condensing steam and the boiling water ejected. The quantity of water thus discharged must have been enormous. Of the remaining volcanic regions of the Pacific, the New Zealand islands present some of the most striking examples of activity. All the central parts, indeed, of the northern island of the group are of a highly volcanic character. There is here a mountain named Tongariro. on whose snow-clad summit is a deep crater, from which volcanic vapors are seen to issue, and which exhibits other indications of having been in a state of greater activity at a not very remote period of time. There is also, at no great distance from this mountain, a region containing numerous funnel-shaped chasms, emitting hot water, or steam, or sulfurous vapors, or boiling mud. The earthquakes in New Zealand had probably their origin in this volcanic focus. The New Zealand volcanoes. Tongariro has a height of about 6,500 feet, while Egmont, 8,270 feet in height, is a perfect cone with a perpetual cap of snow. There are many other volcanic mountains, and also great numbers of mud volcanoes, hot springs, and geysers. It is for the latter that the island is best known to geologists. Their waters are at or near the boiling point and contain silica in abundance. At a place called Rotomehana, in the vicinity of Mount Tararua, there was formerly a lake of about 120 acres in area, which was in its way one of the most remarkable bodies of water upon the earth. Formerly, we say, for this lake no longer exists, it having been destroyed by the very forces to which it owed its fame. Its waters were maintained nearly at the boiling point by the continual accession of boiling water from numerous springs. The most abundant of those sources was situated at the height of about 100 feet above the level of the lake. It kept continually filled an oval basin about 250 feet in circumference, the margins of which were fringed all round with beautiful pure white stalactites, formed by deposits of silica, with which the hot water was strongly impregnated. At various stages below the principal spring were several others, that contributed to feed the lake at the bottom, in the center of which was a small island. Minute bubbles continually escaped from the surface of the water with a hissing sound, and the sand all round the lake was at a high temperature. If a stick was thrust into it, very hot vapors would ascend from the hole. Not far from this lake were several small basins filled with tepid water, which was very clear, and of a blue color. The conditions here were of a kind with those to which are due the great geysers of Iceland and the Yellowstone Park, but different in the fact that instead of being intermittent and throwing up jets at intervals, the springs allowed the water to flow from them in a continuous stream. The pink and white terraces. The siliceous incrustations left by the overflow from the large pool had made a series of terraces, 2 to 6 feet high, with the appearance of being hewn from white or pink marble, each of the basins containing a similar azure water. These terraces covered an area of about 3 acres, and looked like a series of cataracts changed into stone, each edge being fringed with a festoon of delicate stalactites. The water contained about 85% of silica, with 1 or 2% of iron alumina, and a little alkali. There were no more beautiful products of nature upon the earth than those, pink and white terraces, as they were called. The hot springs of the Yellowstone have produced formations resembling them, but not their equal in fairy-like charm. One series of these terraced pools and cascades was of the purest white tint. The other of the most delicate pink, the waters topping over the edge of each pool and falling in a miniature cascade to the one next below, thus keeping the edges built up by a continual renewal of the siliceous incrustation. But all their beauty could not save them from utter and irremediable destruction by the forces below the Earth's surface. On June 9, 1886, a great volcanic disturbance began in the Auckland Lake region with a tremendous earthquake, followed during the night by many others. At 7 the next morning a lead-covered cloud of pumice sand, advancing from the south, burst, and discharged showers of fine dust. The range of Mount Tararua seemed to be in full volcanic activity, including some craters supposed to be extinct, and embracing an area of 120 miles by 20. The showers of dust were so thick as to turn day into night for nearly 2 days. Some lives were lost, and several villages were destroyed, these being covered 10 feet deep with ashes, dust, and clayey mud. The volcanic phenomena were of the most violent character, and the whole island appears to have been more or less convulsed. Mount Tararua is said to be 500 feet higher than before the eruption. Glowing masses were thrown up into the air, and tongues of fiery hue, gases, or illuminated vapors, 500 feet wide, towered up 1,000 feet high. The mountain was 2,700 feet in height. Tararua in eruption. This eruption presented a spectacle of rarely equaled grandeur. To travelers and strangers, the greatest resultant loss will be the destruction of those world-famous curiosities, the white and pink terraces, in the vicinity of Lake Rotomehana and the region of the famous geysers. The natives have a superstition that the eruption of the extinct Tararua was caused by the profanation of foreign footsteps. It was to them a sacred place, and its crater a repository for their dead. The first earthquake occurred in this region. One side of the mountain fell in, and then the eruption began. The basin of the lake was broken up and disappeared, but again reappeared as a boiling mud cauldron. Craters burst out in various places, and the beautiful terraces were no more. After the first day the violence gradually diminished, and in a week had ceased. Very possibly another lake will be formed, and in time other terraces, but it is hardly within the range of probability that the beauty of the lost terraces will ever be paralleled. In this eruption, as usual, we find the earthquake preceding the volcanic outburst. New Zealand, like the Philippines, Java, and the Japanese islands, is situated over a great earth fissure or line of weakness. Subsidence or dislocation from tensile strain of the crust took place, and the influx of water to new regions of heated strata may have developed the explosive force. The earthquake and the volcano worked together here, as they frequently do, unfortunately in this case destroying one of the most beautiful scenes on the surface of the globe. The Antarctic volcanoes. Much further south, on the frozen shore of Victoria Land in the Antarctic regions, Sir James Ross, in 1841, sailing in his discovery ships the Erebus and Terror, discovered two great volcanic mountains, which he named after those two vessels. Mount Erebus is continually covered, from top to bottom, with snow and glaciers. The mountain is about 12,000 feet high, and although the snow reaches to the very edge of the crater, there rise continually from the summit immense volumes of volcanic fumes, illuminated by the glare of glowing lava beneath them. The vapors ascend to an estimated height of 2,200 feet above the top of the mountain. Chapter XXV. The wonderful Hawaiian craters in Kilauea's Lake of Fire. In the central region of the North Pacific Ocean lies the archipelago formerly known as the Sandwich Islands, now collectively designated as Hawaii. The people of the United States should be specially interested in this island group, for it has become one of our possessions, an outlying territory of our growing republic. And in making it part of our national domain we have not alone extended our dominion far over the seas, but have added to the many marvels of nature within our land one of the chief wonders of the world, the stupendous Hawaiian volcanoes, before whose grandeur many of more ancient fame sink into insignificance. The island of Hawaii. The island of Hawaii, the principal island of the group, we may safely say contains the most enormous volcano of the earth. Indeed, the whole island, which is 4,000 square miles in extent, may be regarded as of volcanic origin. It contains four volcanic mountains: Kohala, Hualalai, Mauna Kea, and Mauna Loa. The two last named are the chief, the former being 13,800 feet, the latter 13,600 feet, above the sea level. Although their height is so vast, the ascent to their summits is so gradual that their circumference at the base is enormous. The bulk of each of them is reckoned to be equal to 2.5 times that of Etna. Some of the streams of lava which have emanated from them are 26 miles in length by 2 miles in breadth. On the adjoining island of Maui is a still larger volcano, the mighty Haleakala, long since extinct, but memorable as possessing the most stupendous crater on the face of the earth. The mountain itself is over 10,000 feet high, and forms a great dome-like mass of 90 miles circumference at base. The crater on its summit has a length of 7.5 and a width of 2 1/4 miles, with a total area of about 16 square miles. The only approach in dimensions to this enormous opening exists in the still living crater of Kilauea, on the flank of Mauna Loa, a volcanic island group. The peaks named are the most apparent remnants of a world-rending volcanic activity in the remote past, by whose force this whole Hawaiian island group was lifted up from the depths of the ocean, here descending some 3.5 miles below the surface level. The coral reefs which abound around the islands are of comparatively recent formation, and rest upon a substratum of lava probably ages older, which forms the base of the archipelago. The islands are volcanic peaks and ridges that have been pushed up above the surrounding seas by the profound action of the interior forces of the Earth. It must not be supposed that this action was a violent perpendicular thrust upward over a very limited locality. For the mountains continue to slope at about the same angle under the sea and for great distances on every side. So that the islands are really the crests of an extensive elevation, estimated to cover an area of about 2,000 miles in one direction by 150 or 200 miles in the other. The process was probably a gradual one of upbuilding, by means of which the sea receded as the land steadily rose. Some idea of the mighty forces that have been at work beneath the sea and above it can be gained by considering the enormous mass of material now above the sea level. Thus, the bulk of the island of Hawaii, the largest of the group, has been estimated by the Hawaiian Surveyor General as containing 3,600 cubic miles of lava rock above sea level. Taking the area of England at 50,000 square miles, this mass of volcanic matter would cover that entire country to a depth of 274 feet. We must remember, however, that what is above sea level is only a small fraction of the total amount, since it sweeps down below the waves hundreds of miles on every side. Crater of Haleakala. Of the lava openings on these islands, the extinct one of Haleakala, as stated, with its 27 miles circumference, is far the most stupendous. It is easy of access, the mountainsides leading to it presenting a gentle slope, while the walls of the crater, in places perpendicular, in others are so sloping that man and horse can descend them. The pit varies from 1,500 to 2,000 feet in depth, its bottom being very irregular from the old lava flows and the many cinder cones, these still looking as fresh as though their fires had just gone out. Some of these cones are over 500 feet high. There is a tradition among the natives that the vast lava streams which in the past flowed from the crater to the sea continued to do so in the period of their remote ancestors. They still, indeed, appear as if recent, though there are today no signs of volcanic activity anywhere on this island. In fact, the only volcano now active in the Hawaiian Islands is Mauna Loa, in the southern section of the island of Hawaii. A striking feature of this is that it has two distinct and widely disconnected craters, one on its summit, the other on its flank, at a much lower level. The latter is the vast crater of Kilauea, the largest active crater known on the face of the globe. Miss Bird in the crater of Kilauea. We cannot offer a better description of the aspect of this lava abyss than to give Miss Bird's eloquent description of her adventurous descent into it. The abyss, which really is at a height of 4,000 feet on the flank of Mauna Loa, has the appearance of a pit on a rolling plain. But such a pit. It is quite 9 miles in circumference, and at its lowest area, which not long ago fell about 300 feet, just as the ice on a pond falls when the water below is withdrawn, covers 6 square miles. The depth of the crater varies from 800 to 1,000 feet. According as the molten sea below is at flood or ebb. Signs of volcanic activity are present more or less throughout its whole depth and for some distance along its margin, in the form of steam cracks, jets of sulfurous vapor, blowing cones, accumulating deposits of acicular crystals of sulfur, etc. And the pit itself is constantly rent and shaken by earthquakes. Great eruptions occur with circumstances of indescribable terror and dignity. But Kilauea does not limit its activity to these outbursts, but has exhibited its marvelous phenomena through all known time in a lake or lakes on the southern part of the crater 3 miles from this side. This lake, the Hail Mau Mau, or House of Everlasting Fire, of the Hawaiian mythology, the abode of the dreaded goddess Pele, is approachable with safety, except during an eruption. The spectacle, however, varies almost daily, and at times the level of the lava in the pit within a pit is so low, and the suffocating gases are evolved in such enormous quantities, that travelers are unable to see anything. At the time of our visit there had been no news from it for a week, and as nothing was to be seen but a very faint bluish vapor hanging round its margin, the prospect was not encouraging. After more than an hour of very difficult climbing, we reached the lowest level of the crater, pretty nearly a mile across, presenting from above the appearance of a sea at rest. But on crossing it, We found it to be an expanse of waves and convolutions of ashy-colored lava, with huge cracks filled up with black iridescent rolls of lava only a few weeks old. Parts of it are very rough and ridgy, jammed together like field ice, or compacted by rolls of lava, which may have swelled up from beneath. But the largest part of the area presents the appearance of huge coiled hawsers, the ropey formation of the lava rendering the illusion almost perfect. These are riven by deep cracks, which emit hot sulfurous vapors. As we ascended, the flow became hotter under our feet, as well as more porous and glistening. It was so hot that a shower of rain hissed as it fell upon it. The crust became increasingly insecure, and necessitated our walking in single file with the guide in front, to test the security of the footing. I fell through several times, and always into holes full of sulfurous steam so malignantly acid that my strong dogskin gloves were burned through as I raised myself on my hands. We had followed the lava flow for 30 miles up to the crater's brink, and now we had toiled over recent lava for 3 hours, and, by all calculations, were close to the pit. Yet there was no smoke or sign of fire, and I felt sure that the volcano had died out for once for my special disappointment. Suddenly, just above and in front of us, gory drops were tossed in the air, and springing forwards, we stood on the brink of Hail Mau Mau, which was about 35 feet below us. I think we all screamed. I know we all wept, but we were speechless, for a new glory and terror had been added to the earth. It is the most unutterable of wonderful things. The words of common speech are quite useless. It is unimaginable, indescribable, a sight to remember forever, a sight which at once took possession of every faculty of sense and soul, removing one altogether out of the range of ordinary life. Here was the real, bottomless pit, the fire which is not quenched, the place of hell, the lake which burneth with fire and brimstone, the everlasting burnings, the fiery sea whose waves are never weary. Perhaps those scripture phrases were suggested by the sight of some volcano in eruption. There were groanings, rumblings, and detonations, rushings, hissings, splashings, and the crashing sound of breakers on the coast, but it was the surging of fiery waves upon a fiery shore. But what can I write? Such words as jets, fountains, waves, spray, convey some idea of order and regularity, but here there are none. The inner lake, while we stood there, formed a sort of crater within itself. The whole lava sea rose about 3 feet, a blowing cone about 8 feet high was formed. It was never the same 2 minutes together. And what we saw had no existence a month before, and probably will be changed in every essential feature a month from hence. The prominent object was fire in motion, but the surface of the double lake was continually skimming over for a second or two with a cool crust of lustrous gray-white, like frost silver, broken by jagged cracks of a bright rose color. The movement was nearly always from the sides to the center, but the movement of the center itself appeared independent, and always took a southerly direction. Before each outburst of agitation there was much hissing and throbbing, with internal roaring as of imprisoned gases. Now it seemed furious, demoniacal, as if no power on earth could bind it, then playful and sportive, then for a second languid, but only because it was accumulating fresh force. Sometimes the whole lake took the form of mighty waves, and, surging heavily against the partial barrier with a sound like the Pacific surf, lashed, tore, covered it, and threw itself over it in clots of living fire. It was all confusion, commotion, forces, terror, glory, majesty, mystery, and even beauty. And the color, eye hath not seen it. Molten metal hath not that crimson gleam, nor blood that living light. To this description we may add that of Mr. Ellis, a former missionary to these islands, and one of the number who have descended to the shores of Kilauea's abyss of fire. He says, after describing his difficult descent and progress over the lava-strewn pit, Mr. Ellis visits the lake of lava. Immediately before us yawned an immense gulf, in the form of a crescent, about 2 miles in length, from northeast to southwest, nearly a mile in width, and apparently 800 feet deep. The bottom was covered with lava, and the southwestern and northern parts of it were one vast flood of burning matter in a state of terrific ebullition, rolling to and fro its fiery surges and flaming billows. 51 conical islands, of varied form and size, containing as many craters, rose either round the edge or from the surface of the burning lake. 22 constantly emitted columns of gray smoke or pyramids of brilliant flame, and several of these at the same time vomited from their ignited mouths. Streams of lava, which rolled in blazing torrents down their black indented sides into the boiling mass below. The existence of these conical craters led us to conclude that the boiling cauldron of lava before us did not form the focus of the volcano. That this mass of melted lava was comparatively shallow. And that the basin in which it was contained was separated by a stratum of solid matter from the great volcanic abyss, which constantly poured out its melted contents through these numerous craters into this upper reservoir. The sides of the gulf before us, although composed of different strata of ancient lava, were perpendicular for about 400 feet, and rose from a wide horizontal ledge of solid black lava of irregular breadth, but extending completely round. Beneath this ledge the sides sloped gradually towards the burning lake, which was, as nearly as we could judge, 300 or 400 feet lower. It was evident that the large crater had been recently filled with liquid lava up to this black ledge, and had, by some subterraneous canal, emptied itself into the sea or spread under the lowland on the shore. The gray and in some places apparently calcined sides of the great crater before us. The fissures which intersected the surface of the plain on which we were standing. The long banks of sulfur on the opposite side of the abyss. The vigorous action of the numerous small craters on its borders. The dense columns of vapor and smoke that rose at the north and west end of the plain, together with the ridge of steep rocks by which it was surrounded, rising probably in some places 300 or 400 feet in perpendicular height, presented an immense volcanic panorama, the effect of which was greatly augmented by the constant roaring of the vast furnaces below. Mauna Loa in eruption. Of the two great craters of Mauna Loa, the summit one has frequently in modern times overflowed its crest and poured its molten streams in glowing rivers over the land. This has rarely been the case with the lower and incessantly active crater of Kilauea, whose lava, when in excess, appears to escape by subterranean channels to the sea. We append descriptions of some of the more recent examples of Mauna Loa's eruptive energy. The lava from this crater does not alone flow over the crater's lip, but at times makes its way through fissures far below, the immense pressure causing it to spout in great flashing fountains high into the air. In 1852 the fiery fountains reached a height of 500 feet. In some later eruptions they have leaped 1,000 feet high. The lava is white-hot as it ascends, but it assumes a blood-red tint in its fall, and strikes the ground with a frightful noise. The quantities of lava ejected in some of the recent eruptions have been enormous. The river-like flow of 1,855 was remarkable for its extent, being from 2 to 8 miles wide, with a depth of from 3 to 300 feet, and extending in a winding course for a distance of 60 miles. The apostle of Hawaiian volcanoes, the Rev. Titus Cohen, who ventured to the source of this flow while it was in supreme action, thus describes it: "We ascended our rugged pathway amidst steam and smoke and heat which almost blinded and scathed us. We came to open orifices down which we looked into the fiery river which rushed madly under our feet. These fiery vents were frequent, some of them measuring 10, 20, 50, or 100 feet in diameter. In one place we saw the river of lava uncovered for 30 rods and rushing down a declivity of from 10 to 25 degrees. The scene was awful, the momentum incredible, the fusion perfect, white heat, and the velocity 40 miles an hour. The banks on each side of the stream were red-hot, jagged, and overhanging. As we viewed it rushing out from under its ebon counterpane, and in the twinkling of an eye diving again into its fiery den, it seemed to say, 'Stand off. Scan me not. I am God's messenger. A work to do. Away.' Later he wrote again, "The great summit fountain is still playing with fearful energy, and the devouring stream rushes madly down toward us. It is now about 10 miles distant, and heading directly for our bay. In a few days we may be called to announce the painful fact that our beauteous Hilo is no more, that our lovely, our inimitable landscape, our emerald bowers, our crescent strand and our silver bay are blotted out. A fiery sword hangs over us. A flood of burning ruin approaches us. Devouring fires are near us. With sure and solemn progress, the glowing fusion advances through the dark forest and the dense jungle in our rear, cutting down ancient trees of enormous growth and sweeping away all vegetable life. For months the great summit furnace on Mauna Loa has been in awful blast. Floods of burning destruction have swept wildly and widely over the top and down the sides of the mountain. The wrathful stream has overcome every obstacle, winding its fiery way from its high source to the bases of the everlasting hills, spreading in a molten sea over the plains, penetrating the ancient forests, driving the bellowing herds, the wild goats and the affrighted birds before its lurid glare, leaving nothing but ebon blackness and smoldering ruin in its track. His anticipation of the burial of Hilo under the mighty flow was happily not realized. It came to an abrupt halt while 7 miles distant, the checked stream standing in a threatening and rugged ridge, with rigid, beetling front. The eruptions of 1859 and 1865. In January 1859, Mauna Loa was again at its fire play, throwing up lava fountains from 800 to 1,000 feet in height. From this great fiery fountain the lava flowed down in numerous streams, spreading over a width of 5 or 6 miles. One stream, probably formed by the junction of several smaller, attained a height of from 20 to 25 feet, and a breadth of about 1/8 of a mile. Great stones were thrown up along with the jet of lava, and the volume of seeming smoke, composed probably of fine volcanic dust, is said to have risen to the height of 10,000 feet. An eruption of still greater violence took place in 1865, characterized by similar phenomena, particularly the throwing up of jets of lava. This fiery fountain continued to play without intermission for 20 days and nights, varying only as respects the height to which the jet arose, which is said to have ranged between 100 and 1,000 feet, the mean diameter of the jet being about 100 feet. This eruption was accompanied by explosions so loud as to have been heard at a distance of 40 miles. A cone of about 300 feet in height, and about a mile in circumference, was accumulated round the orifice whence the jet ascended. It was composed of solid matters ejected with the lava, and it continued to glow like a furnace, notwithstanding its exposure to the air. The current of lava on this occasion flowed to a distance of 35 miles, burning its way through the forests, and filling the air with smoke and flames from the ignited timber. The glare from the glowing lava and the burning trees together was discernible by night at a distance of 200 miles from the island. The lava flow of 1880. A succeeding great lava flow was that which began on November 6, 1880. Mr. David Hitchcock, who was camping on Mauna Kea at the time of this outbreak, saw a spectacle that few human eyes have ever beheld. "We stood," writes he, "on the very edge of that flowing river of rock. Oh, what a sight it was! Not 20 feet from us was this immense bed of rock slowly moving forward with irresistible force, bearing on its surface huge rocks and immense boulders of tons weight as water would carry a toy boat. The whole front edge was one bright red mass of solid rock incessantly breaking off from the towering mass and rolling down to the foot of it, to be again covered by another avalanche of white-hot rocks and sand. The whole mass at its front edge was from 12 to 30 feet in height. Along the entire line of its advance it was one crash of rolling, sliding, tumbling red-hot rock. We could hear no explosions while we were near the flow, only a tremendous roaring like 10,000 blast furnaces all at work at once. This was the most extensive flow of recent years, and its progress from the interior plain through the dense forests above Hilo and out onto the open levels close to the town was startling and menacing enough. Through the woods especially it was a turbulent, seething mass that hurled down mammoth trees, and licked up streams of water, and day and night kept up an unintermitting cannonade of explosions. The steam and imprisoned gases would burst the congealing surface with loud detonations that could be heard for many miles. It was not an infrequent thing for parties to camp out close to the flow overnight. Ordinarily a lava flow moves sluggishly and congeals rapidly, so that what seems like hardihood in the narrating is in reality calm judgment. For it is perfectly safe to be in the close vicinity of a lava stream, and even to walk on its surface as soon as one would be inclined to walk on cooling iron in a foundry. This notable flow finally ceased within half a mile of Hilo, where its black form is a perpetual reminder of a marvelous deliverance from destruction. Kilauea in 1840. Kilauea seems never, in historic times, to have filled and overflowed its vast crater. To do so would need an almost inconceivable volume of liquid rock material. But it approached this culmination in 1840, when it became, through its whole extent, a raging sea of fire. The boiling lava rose in the mighty mountain cup to a height of from 500 to 600 feet. Then it forced a passage through a subterranean cavity 27 miles long, and reached the sea 40 miles distant, in 2 days. The stream where it fell into the sea was half a mile wide, and the flow kept up for 3 weeks, heating the ocean 20 miles from land. An eyewitness of this extraordinary flow thus describes it. When the torrent of fire precipitated itself into the ocean, the scene assumed a character of terrific and indescribable grandeur. The magnificence of destruction was never more perceptibly displayed than when these antagonistic elements met in deadly strife. The mightiest of Earth's magazines of fire poured forth its burning billows to meet the mightiest of oceans. For 20 miles it came rolling, tumbling, swelling forward, an awful agent of death. Rocks melted like wax in its path, forests crackled and blazed before its fervent heat, the works of man were to it but as a scroll in the flames. Imagine Niagara's stream, above the brink of the falls, with its dashing, whirling, madly raging waters hurrying on to their plunge, instantaneously converted into fire. A gory-hued river of fused minerals. Volumes of hissing steam arising. Some curling upward from 10,000 vents, which give utterance to as many deep-toned mutterings, and sullen, confined clamorings. Gases detonating and shrieking as they burst from their hot prison house, the heavens lurid with flame, the atmosphere dark and oppressive, the horizon murky with vapors and gleaming with the reflected contest. Such was the scene as the fiery cataract, leaping a precipice of 50 feet, poured its flood upon the ocean. The old line of coast, a mass of compact, indurated lava, whitened, cracked and fell. The waters recoiled, and sent forth a tempest of spray, they foamed and dashed around and over the melted rock, they boiled with the heat, and the roar of the conflicting agencies grew fiercer and louder. The reports of the exploding gases were distinctly heard 25 miles distant, and were likened to a whole broadside of heavy artillery. Streaks of the intensest light glanced like lightning in all directions. The outskirts of the burning lava as it fell, cooled by the shock, were shivered into millions of fragments, and scattered by the strong wind in sparkling showers far into the country. For 3 successive weeks the volcano disgorged an uninterrupted burning tide, with scarcely any diminution, into the ocean. On either side, for 20 miles, the sea became heated, with such rapidity that, on the second day of the junction of the lava with the ocean, fishes came ashore dead in great numbers, at a point 15 miles distant. 6 weeks later, at the base of the hills, the water continued scalding hot, and sent forth steam at every wash of the waves. The sinking of Kilauea's Fire Lake. In 1866 the great crater of Kilauea presented a new and unlooked-for spectacle in the sinking and vanishing of its great lava lake. In March of that year the fires in the ancient cauldron totally disappeared, and the surrounding lava rock sank to a depth of nearly 600 feet. Mr. Thrum, in a pamphlet on the suspended activity of Kilauea, says of it, "Distant rumbling noises were heard, accompanied by a series of earthquakes, 43 in number. With the fourth shock the brilliancy of New Lake disappeared, and towards 3 a.m. the fires in Hailmamau disappeared also, leaving the whole crater in darkness. With the dawn the shocks and noises ceased, and revealed the changes which Kilauea had undergone in the night. All the high cliffs surrounding Hailmamau and New Lake, which had become a prominent feature in the crater, had vanished entirely, and the molten lava of both lakes had disappeared by some subterranean passage from the bottom of Hailmamau. There was no material change in the sunken portion of the crater except a continual falling in of rocks and debris from its banks as the contraction from its former intense heat loosened their compactness and sent them hurling some 200 or 300 feet below, giving forth at times a boom as of distant thunder, followed by clouds of cinders and ashes shooting up into the air 100 to 300 feet, proportionate, doubtless, to the size of the newly fallen mass. This remarkable recession of the liquid lava in Hailmamau was probably due to the opening of some deep subterranean passage through which the lake of lava made its way unseen to the ocean's depths. The Rev. Mr. Baker, probably the most adventuresome explorer of Hawaiian volcanoes, actually descended into that crumbling pit to a point within what he judged to be 50 feet of the bottom. But Hailmamau had only taken an intermission, for in 2 short months signs of returning life became frequent and unmistakable, and, in June, culminated in the sudden outbreak of a lake that has since then steadily increased in activity. The goddess Pele. We cannot close this chapter without some reference to the goddess Pele, to whom the Hawaiians long imputed the wonder work of their volcanic mountains. When there is unusual commotion in Kilauea, myriads of thread-like filaments float in the air and fall upon the cliffs, making deposits much resembling matted hair. A single filament over 15 inches long was picked up on a helo veranda, having sailed in the air a distance of 50 miles. This is the famous Pele's hair, being the glass-like product of volcanic fires. It resembles Prince Rupert's drops, and the tradition is that whenever the volcano becomes active it is because Pele, the goddess of the crater, emerges from her fiery furnace and shakes her vitreous locks in anger. This fabled being, according to Emerson, in a paper on the lesser Hawaiian gods, could at times assume the appearance of a handsome young woman, as when Kamapa'ea, to his cost, was smitten with her charms when first he saw her with her sisters at Kilauea. Kamapa'ea was a gigantic hog, who could appear as a handsome young man, a hog, a fish, or a tree. At other times the innate character of the Fury showed itself, and Pele appeared in her usual form as an ugly and hateful old hag, with tattered and fire-burnt garments, scarcely concealing the filth and nakedness of her person. Her bloodshot eyes and fiendish countenance paralyzed the beholder, and her touch turned him to stone. She was a jealous and vindictive monster, delighting in cruelty, and at the slightest provocation overwhelming the unoffending victims of her rage in widespread ruin. The superstition regarding the goddess Pele was thought to have received a death blow in 1825. When Kapiolani, an Hawaiian princess and a Christian convert, ascended, with numerous attendants, to the crater of Kilauea, where she publicly defied the power and wrath of the goddess. No response came to her defiance, she descended in safety, and faith in Pele's power was widely shaken. Yet as late as 1887 the old superstition revived and claimed an exalted victim. For in that year the princess the youngest sister of the king, starved herself to death to appease the anger of the goddess Pele, supposed to be manifested in Mauna Loa's eruption of that year, and to be quieted only by the sacrifice of a victim of royal blood. Thus slowly do the old superstitions die away. Chapter XXVI. Popocatépetl and other volcanoes of Mexico and Central America. Mexico is very largely a vast tableland, rising through much of its extent to an elevation of from 7,000 to 8,000 feet above sea level, and bounded east and west by wide strips of torrid lowlands adjoining the oceans. It is crossed at about 19 degrees north latitude by a range of volcanic mountains, running in almost a straight line east and west, upon which are several extinct volcanic cones, and 5 active or quiescent volcanoes. The highest of these is Popocatépetl, south of the city of Mexico and nearly midway between the Atlantic and Pacific. East of this mountain lies Orizaba, little below it in height, and San Martin or Tuxtla, 9,700 feet high, on the coast south of Veracruz. West of it is Jorullo, 4,000 feet, and Colima, 12,800, near the Pacific coast. The volcanic energy continues southward toward the isthmus, but decreases north of this volcanic range. These mountains have shown little signs of activity in recent times. Popocatépetl emits smoke, but there is no record of an eruption since 1540. Orizaba has been quiet since 1566. Tuxtla had a violent eruption in 1793, but since then has remained quiescent. Colima is the only one now active. For 10 years past it has been emitting ashes and smoke. The most remarkable of these volcanoes is Jorullo, which closely resembled Monte Nuevo, described in Chapter 13. in its mode of origin. Popocatépetl, the hill that smokes. In the Mexican language, the huge mountain clothed in eternal snows, and regarded by the idolaters of old as a god, towers up nearly 18,000 feet above the level of the sea, and in the days of the conquest of Mexico was a volcano in a state of fierce activity. It was looked upon by the natives with a strange dread, and they told the white strangers with awe that no man could attempt to ascend its slopes and yet live. But, from a feeling of vanity, or the love of adventure, the Spaniards laughed at these fears, and accordingly a party of 10 of the followers of Cortés commenced the ascent, accompanied by a few Indians. But these latter, after ascending about 13,000 feet to where the last remains of stunted vegetation existed, became alarmed at the subterranean bellowings of the volcano, and returned, while the Spaniards still painfully toiled on through the rarefied atmosphere, their feet crushing over the scoriae and black-glazed volcanic sand, until they stood in the region of perpetual snow, amidst the glittering, treacherous glaciers and crevasses, with vast slippery-pathed precipices yawning round. Still they toiled on in this wild and wondrous region. A few hours before they were in a land of perpetual summer, here all was snow. They suffered the usual distress awarded to those who dare to ascend to these solitudes of nature, but it was not given to them to achieve the summit. For suddenly, at a higher elevation, after listening to various ominous threatenings from the interior of the volcano, they encountered so fierce a storm of smoke, cinders, and sparks, that they were driven back half suffocated to the lower portions of the mountain. Some time after another attempt was made, and upon this occasion with a definite object. The invaders had nearly exhausted their stock of gunpowder, and Cortés organized a party to ascend to the crater of the volcano, to seek and bring down sulfur for the manufacture of this necessary of warfare. This time the party numbered but 5, led by one Francisco Montano, and they experienced no very great difficulty in winning their way upwards. The region of verdure gave place to the wild, lava-strewn slope, which was succeeded in its turn by the treacherous glaciers. And at last the gallant little band stood at the very edge of the crater, a vast depression of over a league in circumference, and 1,000 feet in depth. Sulfur from the crater. Flame was issuing from the hideous abysses. And the stoutest man's heart must have quailed as he peered down into the dim, mysterious cavity to where the sloping sides were crusted with bright yellow sulfur, and listened to the mutterings which warned him of the pent-up wrath and power of the mighty volcano. They knew that at any moment flame and stifling sulphurous vapor might be belched forth, but now no cowardice was shown. They had come provided with ropes and baskets, and it only remained to see who should descend. Lots were therefore drawn, and it fell to Montano, who was accordingly lowered by his followers in a basket 400 feet into the treacherous region of eternal fires. The basket swayed and the rope quivered and vibrated, but the brave cavalier sturdily held to his task, disdaining to show fear before his humble companions. The lurid light from beneath flashed upon his tanned features, and a sulphurous steam rose slowly and condensed upon the sides. But, whatever were his thoughts, the Spaniard collected as much sulfur as he could take up with him, breaking off the bright incrustations, and even dallying with his task as if in contempt of the danger, till he had leisurely filed his basket, when the signal was given and he was drawn up. The basket was emptied, and then he once more descended into the lurid crater, collected another store and was again drawn up. But far from shrinking from his task, he descended again several times, till a sufficiency had been obtained, with which the party descended to the plain. The volcano Jorullo. No further back than the middle of the 18th century the site of Jorullo was a level plain, including several highly cultivated fields, which formed the farm of Don Pedro de Jorullo. The plain was watered by 2 small rivers, called Quidamba and San Pedro, and was bounded by mountains composed of basalt, the only indications of former volcanic action. These fields were well irrigated, and among the most fertile in the country, producing abundant crops of sugar cane and indigo. In the month of June, 1759, the cultivators of the farm began to be disturbed by strange subterranean noises of an alarming kind, accompanied by frequent shocks of earthquake, which continued for nearly a couple of months. But they afterward entirely ceased, so that the inhabitants of the place were lulled into security. On the night between the 28th and 29th of September, however, the subterranean noises were renewed with greater loudness than before, and the ground shook severely. The Indian servants living on the place started from their beds in terror, and fled to the neighboring mountains. Thence gazing upon their master's farm they beheld it, along with a tract of ground measuring between 3 and 4 square miles, in the midst of which it stood, rise up bodily, as if it had been inflated from beneath like a bladder. At the edges this tract was uplifted only about 39 feet above the original surface, but so great was its convexity that toward the middle it attained a height of no less than 524 feet. The Indians who beheld this strange phenomenon declared that they saw flames issuing from several parts of this elevated tract, that the entire surface became agitated like a stormy sea, that great clouds of ashes, illuminated by volcanic fires glowing beneath them, rose at several points, and that white-hot stones were thrown to an immense height. Vast chasms were at the same time opened in the ground, and into these the 2 small rivers above mentioned plunged. Their waters, instead of extinguishing the subterranean conflagration, seemed only to add to its intensity. Quantities of mud, enveloping balls of basalt, were then thrown up, and the surface of the elevated ground became studded with small cones, from which volumes of dense vapor, chiefly steam, were emitted, some of the jets rising from 20 to 30 feet in height. These cones the Indians called ovens, and in many of them was long heard a subterranean noise resembling that of water briskly boiling. Out of a great chasm in the midst of those ovens there were thrown up 6 larger elevations, the highest being 1,640 feet above the level of the plain, 4,315 above sea level, and now constituting the principal volcano of Jorullo. The smallest of the 6 was 300 feet in height, the others of intermediate elevation. The highest of these hills had on its summit a regular volcanic crater, whence there have been thrown up great quantities of dross and lava, containing fragments of older rocks. The ashes were transported to immense distances, some of them having fallen on the houses at Querétaro, more than 48 leagues from Jorullo. The volcano continued in this energetic state of activity for about 4 months. In the following years its eruptions became less frequent, but it still continues to emit volumes of vapor from the principal crater, as well as from many of the ovens in the upheaved ground. Effect on the rivers. The 2 rivers, which disappeared on the first night of this great eruption, now pursue an underground course for about 1.25 miles, and then reappear as hot springs, with a temperature of 126 degrees Fahrenheit. This wonderful volcanic upheaval is all the more remarkable, from the inland situation of the plain on which it occurred, it being no less than 120 miles distant from the nearest ocean, while there is no other volcano nearer to it than 80 miles. The activity of the ovens has now ceased, and portions of the upheaved plain on which they are situated have again been brought under cultivation, and the volcano is in a state of quiescence. The crater of Popocatépetl, which towers to a height of 17,000 feet, is a vast circular basin, whose nearly vertical walls are in some parts of a pale rose tint, in others quite black. The bottom contains several small fuming cones, whence arise vapors of changeable color, being successively red, yellow and white. All round them are large deposits of sulfur, which are worked for mercantile purposes. Orizaba has a little less lofty snow-clad peak. This mountain was in brisk volcanic activity from 1545 to 1560, but has since then relapsed into a prolonged repose. It was climbed, in 1856, by Baron Muller, to whose mind the crater appeared like the entrance to a lower world of horrible darkness. He was struck with astonishment on contemplating the tremendous forces required to elevate and rend such enormous masses to melt them, and then pile them up like towers, until by cooling they became consolidated into their present forms. The internal walls of the crater are in many places coated with sulfur, and at the bottom are several small volcanic craters. At the time of his visit the summit was wholly covered with snow, but the Indians affirmed that hot vapors occasionally ascend from fissures in the rocks. Since then others have reached its summit, among them Angelo Heilprin, the first to gaze into the crater of Mont Pelee after its eruption. Eruptions in Nicaragua. On the 14th of November, 1867, there commenced an eruption from a mountain about 8 leagues to the eastward of the city of Leon, in Nicaragua. This mountain does not appear to have been previously recognized as an active volcano, but it is situated in a very volcanic country. The outburst had probably some connection with the earthquake at St. Thomas, which took place on the 18th of November following. The mountain continued in a state of activity for about 16 days. There was thrown out an immense quantity of black sand, which was carried as far as to the coast of the Pacific, 50 miles distant. Glowing stones were projected from the crater to an estimated height of 3,000 feet. Central America is more prolific of volcanoes than Mexico, and the state of Guatemala in particular. One authority credits this state with 15 or 16 and another with more than 30 volcanic cones. Of these at least 5 are decidedly active. Tajamalco, which was in eruption at the time of the Great Earthquake of 1863, yields great quantities of sulfur, as also does Quetzaltenango. The most famous is the Volcán de Agua, water volcano, so called from its overwhelming the old city of Guatemala with a torrent of water in 1541. Nicaragua is also rich in volcanoes, being traversed its entire length by a remarkable chain of isolated volcanic cones, several of which are to some extent active. We have already told the story of the tremendous eruption of Cozgana in 1835, one of the most violent of modern times. The latest important eruption here was that of Ometepec, a volcanic mount on an island of the same name in Lake Nicaragua. This broke a long period of repose on June 19, 1883, with a severe eruption, in which the lava, pouring from a new crater, in 7 days overflowed the whole island and drove off its population. Incessant rumblings and earthquake shocks accompanied the eruption, and mud, ashes, stones, and lava covered the mountain slopes, which had been cultivated for many centuries. These were the most recent strong displays of volcanic energy in Central America, though former great outflows of lava are indicated by great fields of barren rock, which extend for miles. Chapter XXVII. The terrible eruption of Krakatoa. The most destructive volcanic explosion of recent times, one perhaps unequaled in violence in all times, was that of the small mountain island of Krakatoa, in the East Indian archipelago, in 1883. This made its effects felt round the entire globe, and excited such wide attention that we feel called upon to give it a chapter of its own. The island of Krakatoa lies in the Straits of Sunda, between Java and Sumatra. In size it is insignificant, and had been silent so long that its volcanic character was almost lost sight of. Of its early history we know nothing. At some remote time in the past it may have appeared as a large cone, of some 25 miles in circumference at base and not less than 10,000 feet high. Then, still in unknown times, its cone was blown away by internal forces, leaving only a shattered and irregular crater ring. This crater was 2 or 3 miles in diameter, while the highest part of its walls rose only a few hundred feet above the sea. Later volcanic work built up a number of small cones within the crater, and still later a new cone, called Rakata, rose on the edge of the old one to a height of 2,623 feet. The first known event in the history of the island volcano was an eruption in the year 1680. After that it lay in repose, forming a group of islands, one much larger than the others. Some of the smaller islands indicated the rim of the old crater, much of which was buried under the sea. Its state of quiescence continued for 2 centuries, a tropical vegetation richly mantled the island, and to all appearance it had sunk permanently to rest. Indications of a coming change appeared in 1880, in the form of earthquakes, which shook all the region around. These continued at intervals for more than 2 years. Then, on May 20, 1883, there were heard at Batavia, 100 miles away, booming sounds like the firing of artillery. Next day the captain of a vessel passing through the straits saw that Krakatoa was in eruption, sending up clouds of smoke and showers of dust and pumice. The smoke was estimated to reach a height of 7 miles, while the volcanic dust drifted to localities 300 miles away. Awful premonitions. The mountain continued to play for about 14 weeks with varying activity, several parties meanwhile visiting it and making observations. Such an eruption, in ordinary cases, would have ultimately died away, with no marked change other than perhaps the ejection of a stream of lava. But such was not now the case. The sequel was at once unexpected and terrible. As the island was uninhabited, no one actually saw what took place, those nearest to the scene of the eruption having enough to do to save their own lives, while the dense clouds of vapor and dust baffled observation. The phase of greatest violence set in on Sunday, August 26th. Soon after midday, sailors on passing ships saw that the island had vanished behind a dense cloud of black vapor, the height of which was estimated at not less than 17 miles. At intervals frightful detonations resounded, and after a time a rain of pumice began to fall at places 10 miles distant. For miles round fierce flashes of lightning rent the vapor, and at a distance of fully 40 miles ghostly corposants gleamed on the rigging of a vessel. These phenomena grew more and more alarming until August 27th, when 4 explosions of fearful intensity shook earth and sea and air, the third being far the most violent and productive of the most widespread results. It was, in fact, perhaps the most tremendous volcanic outburst, in its intensity, known in human history. It seemed to overcome the obstruction to the energy of the internal forces, for the eruption now declined, and in a day or two practically died away, though 1 or 2 comparatively insignificant outbursts took place later. Far-reaching destruction. The eruption spread ruin and death over many surrounding leagues. At Krakatoa itself, when men once more reached its shores, everything was found to be changed. About 2/3 of the main island were blown completely away. The marginal cone was cut nearly in half vertically, the new cliff falling precipitously toward the center of the crater. Where land had been before, now sea existed, in some places more than 100 feet deep. But the part of the island that remained had been somewhat increased in size by ejected materials. Of the other islands and islets, some had disappeared, some were partially destroyed, some were enlarged by fallen debris, while many changes had taken place in the depth of the neighboring seabed. 2 new islands, Steers and Kamire, were formed. The ejected pumice, so cavernous in structure as to float upon the water, at places formed great floating islands which covered the sea for miles, and sometimes rose from 4 to 7 feet above it, proving a serious obstacle to navigation. On vessels nearby, dust fell to the depth of 18 inches. The enormous clouds of volcanic dust which had been flung high into the air darkened the sky for a great area around. At Batavia, about 100 miles from the volcano, it produced an effect not unlike that of a London fog. This began about 7 in the morning of August 27th. Soon after 10 the light had become lurid and yellow, and lamps were required in the houses. Then came a downfall of rain, mingled with dust, and by about 11:30 the town was in complete darkness. It soon after began to lighten, and the rain to diminish, and about 3 o'clock it had ceased. At Betenzorg, 20 miles further away, the conditions were similar, but lasted for a shorter time. In places much farther away the upper sky presented a strangely murky aspect, and the sun assumed a green color. Phenomena of this kind were traced over a broad area of the globe, even as far as the Hawaiian Islands, while over a yet wider area the sky after sunset was lit up by afterglows of extraordinary beauty. The height to which the dust was projected has been calculated from various data, with the result that 121,500 feet, or nearly 25 miles, is thought to be a probable maximum estimate, though it may be that occasional fragments of larger size were shot up to a still greater height. A graphic description of the eruption. Another effect, of a distressing character, followed the eruption. A succession of enormous waves, emanating from Krakatoa, traversed the sea, and swept the coast bordering the Straits of Sunda with such force as to destroy many villages on the low-lying shores in Java, Sumatra, and other islands. Some buildings at a height of 50 feet above sea level were washed away, and in some places the water rose higher, in one place reaching the height of 115 feet. At Teluk Betong, in Sumatra, a ship was carried inland a distance of nearly 2 miles, and left stranded at a height of 30 feet above the sea. The eruption of Krakatoa seems to have been due to some deep-lying causes of extraordinary violence. This appearing not only in the terrible explosion which tore the island to fragments and sent its remnants as floating dust many miles high into the air, but also from an internal convulsion that affected many of the volcanoes of Java, which almost simultaneously broke into violent eruption. We extract from Dr. Robert Bonney's Our Earth and Its Story, a description of these closely related events. The disturbances originated on the island of Krakatoa, with eruptions of red-hot stones and ashes, and by noon next day Semeru, the largest of the Javanese volcanoes, was reported to be belching forth flames at an alarming rate. The eruption soon spread to Gunung Guntur and other mountains, until more than a third of the 45 craters of Java were either in activity or seriously threatening it. Just before dusk a great cloud hung over Gunung Guntur, and the crater of the volcano began to emit enormous streams of white sulfurous mud and lava, which were rapidly succeeded by explosions, followed by tremendous showers of cinders and enormous fragments of rock, which were hurled high into the air and scattered in all directions, carrying death and destruction with them. The overhanging clouds were, moreover, so charged with electricity that waterspouts added to the horror of the scene. The eruption continued all Saturday night, and next day a dense cloud, shot with lurid red, gathered over the Kidang range, intimating that an eruption had broken out there. This proved to be the case, for soon after streams of lava poured down the mountainsides into the valleys, sweeping everything before them. About 2 o'clock on Monday morning we are drawing on the account of an eyewitness. The great cloud suddenly broke into small sections and vanished. When light came it was seen that an enormous tract of land, extending from Point Capucin on the south, and Negiri Paso Arang on the north and west, to the lowest point, covering about 50 square miles, had been temporarily submerged by the tidal wave. Here were situated the villages of Negiri and Negiri Babawan. Few of the inhabitants of these places escaped death. This section of the island was less densely populated than the other portions, and the loss of life was comparatively small, although it must have aggregated several thousands. The waters of Welcome Bay in the Sunda Straits, Pepper Bay on the east, and the Indian Ocean on the south, had rushed in and formed a sea of turbulent waves. Detonations heard for many miles away. On Monday night the volcano of Papandayang was in an active state of paroxysmal eruption, accompanied by detonations which are said to have been heard for many miles away. In Sumatra 3 distinct columns of flame were seen to rise from a mountain to a vast height, and its whole surface was soon covered with fiery lava streams, which spread to great distances on all sides. Stones fell for miles around, and black fragmentary matter carried into the air caused total darkness. A whirlwind accompanied the eruption, by which house roofs, trees, men, and horses were swept into the air. The quantity of matter ejected was such as to cover the ground and the roofs of the houses at Dinamo to the depth of several inches. Suddenly the scene changed. At first it was reported that Papandayang had been split into 7 distinct peaks. This proved untrue, but in the open seams formed could be seen great balls of molten matter. From the fissures poured forth clouds of steam and black lava, which, flowing in steady streams, ran slowly down the mountain sides, forming beds 200 or 300 feet in extent. At the entrance to Batavia was a large group of houses extending along the shore, and occupied by Chinese men. This portion of the city was entirely destroyed, and not many of the Chinese who lived on the swampy plains managed to save their lives. They stuck to their homes till the waves came and washed them away, fearing torrents of flame and lava more than torrents of water. Of the 3,500 Europeans and Americans in Batavia, which for several hours was in darkness, owing to the fall of ashes, 800 perished at Anjer. The European and American quarter was first overwhelmed by rocks, mud and lava from the crater, and then the waters came up and swallowed the ruins, leaving nothing to mark the site, and causing the loss of about 200 lives of the inhabitants and those who sought refuge there. The loss of life above mentioned was but a small fraction of the total loss. All along the coasts of the adjoining large islands, towns and villages were swept away and their inhabitants drowned, till the total loss was, as nearly as could be estimated, 36,000 souls. Krakatoa thus surpassed Mont Pelee in its tale of destruction. These two, indeed, have been the most destructive to life of known volcanic explosions, since the volcano usually falls far short of the earthquake in its murderous results. The distant effects of this explosion were as remarkable as the near ones. The concussion of the air reached to an unprecedented distance and the clouds of floating dust encircled the earth, producing striking phenomena of which an account is given at the end of this chapter. The rapidity with which the effects of the Krakatoa eruption made themselves evident in all parts of the earth is perhaps the most remarkable outcome of this extraordinary event. The floating pumice reached the harbor of St. Paul on the 22nd of March, 1884, after having made a voyage of some 260 days at a rate of 0.6 of a mile an hour. Immense quantities of pumice of a similar description, and believed to have been derived from the same source, reached Tamatave in Madagascar 5 months later, and no doubt much of it long continued to float round the world. Series of atmospheric waves. Another result of the eruption was the series of atmospheric waves, caused by the disturbance in the atmosphere, which affected the barometer over the entire world. The velocity with which these waves traveled has been variously estimated at from 912.09 feet to 1066.29 feet per second. This speed is, of course, very much inferior to that at which sound travels through the air. Yet, in 3 distinct cases, the noise of the Krakatoa explosions was plainly heard at a distance of at least 2,200 miles, and in one instance that recorded from Rodriguez of nearly 3,000. The sound traveled to Ceylon, Burma, Manila, New Guinea, and Western Australia, places, however, within a radius of about 2,000 miles, out Diego Garcia lies outside that area, and Rodriguez 1,000 miles beyond it. 6 days subsequent to the explosion, after the atmospheric waves had traveled 4 times round the globe, the barometer was still affected by them. Another result, similar in kind, was the extraordinary dissemination of the great ocean wave, which in a like manner seems to have encircled the earth, since high waves, without evident cause, appeared not only in the Pacific, but at many places on the Atlantic coast within a few days after the event. They were observed alike in England and at New York. The writer happened to be at Atlantic City, on the New Jersey coast, at this time. It was a period of calm, the winds being at rest, but, unheralded, there came in an ocean wave of such height as to sweep away the oceanfront boardwalk and do much other damage. He ascribed this strange wave at the time to the Krakatoa explosion, and is of the same opinion still. In addition to the account given of this extraordinary volcanic event, it seems desirable to give Sir Robert S. Ball's description of it in his recent work, The Earth's Beginnings. While repeating to some extent what we have already said, it is worthy, from its freshness of description and general readability, of a place here. Sir Robert S. Ball's description. Until the year 1883 few had ever heard of Krakatoa. It was unknown to fame, as are hundreds of other gems of glorious vegetation set in tropical waters. It was not inhabited, but the natives from the surrounding shores of Sumatra and Java used occasionally to draw their canoes up on its beach, while they roamed through the jungle, in search of the wild fruits that there abounded. It was known to the mariner who navigated the Straits of Sunda, for it was marked on his charts as one of the perils of the intricate navigation in those waters. It was no doubt recorded that the locality had been once, or more than once, the seat of an active volcano. In fact, the island seemed to owe its existence to some frightful eruption of bygone days, but for a couple of centuries there had been no fresh outbreak. It almost seemed as if Krakatoa might be regarded as a volcano that had become extinct. In this respect it would only be like many other similar objects all over the globe, or like the countless extinct volcanoes all over the moon. As the summer of 1883 advanced, the vigor of Krakatoa, which had sprung into notoriety at the beginning of the year, steadily increased and the noises became more and more vehement. These were presently audible on shores 10 miles distant, and then 20 miles distant. And still those noises waxed louder and louder, until the great thunders of the volcano, now so rapidly developing, astonished the inhabitants that dwelt over an area at least as large as Great Britain. And there were other symptoms of the approaching catastrophe. With each successive convulsion a quantity of fine dust was projected aloft into the clouds. The wind could not carry this dust away as rapidly as it was hurled upward by Krakatoa, and accordingly the atmosphere became heavily charged with suspended particles. A pall of darkness thus hung over the adjoining seas and islands. Such was the thickness and density of these atmospheric volumes of Krakatoa dust that, for 100 miles around, the darkness of midnight prevailed at midday. Then the awful tragedy of Krakatoa took place. Many thousands of the unfortunate inhabitants of the adjacent shores of Sumatra and Java were destined never to behold the sun again. They were presently swept away to destruction in an invasion of the shore by the tremendous waves with which the seas surrounding Krakatoa were agitated. As the days of August passed by, the spasms of Krakatoa waxed more and more vehement. By the middle of that month the panic was widespread, for the supreme catastrophe was at hand. On the night of Sunday, August 26, 1883, the blackness of the dust clouds, now much thicker than ever in the straits of Sunda and adjacent parts of Sumatra and Java, was only occasionally illumined by lurid flashes from the volcano. At the town of Batavia, 100 miles distant, there was no quiet that night. The houses trembled with subterranean violence, and the windows rattled as if heavy artillery were being discharged in the streets. And still these efforts seemed to be only rehearsing for the supreme display. By 10 o'clock on the morning of Monday, August 27, 1883, the rehearsals were over, and the performance began. An overture, consisting of 2 or 3 introductory explosions, was succeeded by a frightful convulsion which tore away a large part of the island of Krakatoa and scattered it to the winds of heaven. In that final outburst all records of previous explosions on this earth were completely broken. An extraordinary noise. This supreme effort it was which produced the mightiest noise that, so far as we can ascertain, has ever been heard on this globe. It must have been indeed a loud noise which could travel from Krakatoa to Batavia and preserve its vehemence over so great a distance. But we should form a very inadequate conception of the energy of the eruption of Krakatoa if we thought that its sounds were heard by those merely 100 miles off. This would be little indeed compared with what is recorded on testimony which it is impossible to doubt. Westward from Krakatoa stretches the wide expanse of the Indian Ocean. On the opposite side from the Straits of Sunda lies the island of Rodriguez, the distance from Krakatoa being almost 3,000 miles. It has been proved by evidence which cannot be doubted that the thunders of the great volcano attracted the attention of an intelligent coast guard on Rodriguez, who carefully noted the character of the sounds and the time of their occurrence. He had heard them just 4 hours after the actual explosion, for this is the time the sound occupied on its journey. A constant wind. This mighty incident at Krakatoa has taught us other lessons on the constitution of our atmosphere. We previously knew little, or I might say almost nothing, as to the conditions prevailing above the height of 10 miles overhead. It was Krakatoa which first gave us a little information which was greatly wanted. How could we learn what winds were blowing at a height 4 times as great as the loftiest mountain on the earth, and twice as great as the loftiest altitude to which a balloon has ever soared? No doubt a straw will show which way the wind blows, but there are no straws up there. There was nothing to render the winds perceptible until Krakatoa came to our aid. Krakatoa drove into those winds prodigious quantities of dust. Hundreds of cubic miles of air were thus deprived of that invisibility which they had hitherto maintained. With eyes full of astonishment men watched those vast volumes of Krakatoa dust on a tremendous journey. Of course, everyone knows the so-called trade winds on our Earth's surface, which blow steadily in fixed directions, and which are of such service to the mariner. But there is yet another constant wind. It was first disclosed by Krakatoa. Before the occurrence of that eruption, no one had the slightest suspicion that far up aloft, 20 miles over our heads, A mighty tempest is incessantly hurrying, with a speed much greater than that of the awful hurricane which once laid so large a part of Calcutta on the ground and slew so many of its inhabitants. Fortunately for humanity, this new trade wind does not come within less than 20 miles of the Earth's surface. We are thus preserved from the fearful destruction that its unintermittent blasts would produce, blasts against which no tree could stand and which would, in 10 minutes, do as much damage to a city as would the most violent earthquake. When this great wind had become charged with the dust of Krakatoa, then, for the first, and, I may add, for the only time, it stood revealed to human vision. Then it was seen that this wind circled round the Earth in the vicinity of the equator, and completed its circuit in about 13 days. A vast cloud of dust. The dust manufactured by the supreme convulsion was whirled round the Earth in the mighty atmospheric current into which the volcano discharged it. As the dust cloud was swept along by this incomparable hurricane, it showed its presence in the most glorious manner by decking the sun and the moon in hues of unaccustomed splendor and beauty. The blue color in the sky under ordinary circumstances is due to particles in the air. And when the ordinary motes of the sunbeam were reinforced by the introduction of the myriads of motes produced by Krakatoa, even the sun itself sometimes showed a blue tint. Thus the progress of the great dust cloud was traced out by the extraordinary sky effects it produced, and from the progress of the dust cloud we inferred the movements of the invisible air current which carried it along. Nor need it be thought that the quantity of material projected from Krakatoa should have been inadequate to produce effects of this worldwide description. Imagine that the material which was blown to the winds of heaven by the supreme convulsion of Krakatoa could be all recovered and swept into one vast heap. Imagine that the heap were to have its bulk measured by a vessel consisting of a cube 1 mile long, 1 mile broad and 1 mile deep. It has been estimated that even this prodigious vessel would have to be filled to the brim at least 10 times before all the products of Krakatoa had been measured. It is not specially to the quantity of material ejected from Krakatoa that it owes its reputation. Great as it was, it has been much surpassed. Professor Judd says that the great eruptions of Papapendayang, in Java, in 1772, of Skaptur Jökull, in Iceland, in 1783, and of Tambora, in Sumbawa, in 1815, were marked by the extrusion of much larger quantities of material. The special feature of the Krakatoa eruption was its extreme violence, which flung volcanic dust to a height probably never before attained, and produced sea and air waves of an intensity unparalleled in the records of volcanic action. Judd thinks this was due to the situation of the crater, and the possible inflow through fissures of a great volume of seawater to the interior lava, the result being the sudden production of an enormous volume of steam. Extraordinary red sunsets. The red sunsets spoken of above were so extraordinary in character that a fuller description of them seems advisable. A remarkable fact concerning them is the great rapidity with which they were disseminated to distant regions of the Earth. They appeared around the entire equatorial zone in a few days after the eruption, this doubtless being due to the great rapidity with which the volcanic dust was carried by the upper air current. They were seen at Rodriguez, 3,000 miles away, on August 28th, and within a week in every part of the torrid zone. From this zone they spread north and south with less rapidity. Their first appearance in Australia was on September 15th, and at the Cape of Good Hope on the 20th. On the latter day they were observed in California and the southern United States. They were first seen in England on November 9th. Elsewhere in Europe and the United States they appeared from November 20th to 30th. The effect lasted in some instances as long as an hour and 3/4 after sunset. In India the sun and skies assumed a greenish hue, and there was much curiosity regarding the cause of the green Sunday. Another remarkable phenomenon of this period was the great prevalence of rain during the succeeding winter. This probably was due to the same cause, that is, to the fact of the air being so filled with dust, the prevailing theory in regard to rain being that the existence of dust in the air is necessary to its fall. The vapor of the air concentrates into drops around such minute particles, the result being that where dust is absent rain cannot fall. As regards the sunsets spoken of, there are 3 similar instances on record. The first of these was in the year 526, when a dry fog covered the Roman Empire with a red haze. Nothing further is known concerning it. The other instances were in the years 1783 and 1831. The former of these has been traced to the great eruption of Skaptur in that year. It lasted for several months as a pale blue haze, and occasioned so much obscurity that the sun was only visible when 12 degrees above the horizon, and then it had a blood-red appearance. Violent thunderstorms were associated with it, thus assimilating it with that of 1883. Alike in 1783 and 1831 there was a pearly, phosphorescent gleam in the atmosphere, by which small print could be read at midnight. We know nothing regarding the meteorological conditions of 1831. The red sunsets of 1883 were remarkable for their long persistence. They were observed in the autumn of 1884 with almost their original brilliancy, and they were still visible in 1885, being seen at intervals, as if the dust was then distributed in patches, and driven about by the winds. In fact, similar sunsets were occasionally visible for several years afterwards. These may well have been due to the same cause, when we consider with what extreme slowness very fine dust makes its way through the air, and how much it may be affected by the winds. The red sunsets described. One writer describes the appearance of these sunsets in the following terms: immediately after sunset a patch of white light appeared 10 or 15 degrees above the horizon, and shone for 10 minutes with a pearly luster. Beneath it a layer of bright red rested on the horizon, melting upward into orange, and this passed into yellow light, which spread around the lucid spot. Next the white light grew of a rosy tint, and soon became an intense rose hue. A vivid golden aureole yellow strip divided it from the red fringe below and the rose red above. This description, although exaggerated, represents the general conditions of the phenomenon. On October 20, 1884, the author observed the sunset effect as follows: immediately after the sun had set, a broad cone of silvery luster rested upon a horizon of smoky pink. After 15 minutes the white became rose color above and yellowish below, deepening to lemon color, and finally into reddish tint, while the rose faded out. The whole cone gradually sank and died away in the brownish-red flush on the horizon, more than an hour after sunset. The time of duration varied, since, on the succeeding evening, it lasted only a half hour. These sunset effects, if we can justly attribute them all to the Krakatoa eruption, were extraordinary not alone for their intensity and beauty but for their extended duration, the influence of this remarkable volcanic outbreak being visible for several years after the event. Though no doubt is entertained concerning the cause of the red sunset effects of 1783 and 1883, that of 1831 is not so readily explained, there having been no known volcanic explosion of great intensity in that year. But in view of the fact that volcanoes exist in unvisited parts of the earth, some of which may have been at work unknown to scientific man, this difficulty is not insuperable. Possibly Mounts Erebus or Terror, the burning mountains of the Antarctic zone, may, unseen by man, have prepared for civilized lands this grand spectacular effect of nature's doings. Chapter XXVIII. Mount Pelee and its harvest of death. Saint-Pierre, the principal city of the French island of Martinique, in the West Indies, lies for the length of about a mile along the island coast, with high cliffs hemming it in, its houses climbing the slope, tier upon tier. At one place where a river breaks through the cliffs, the city creeps further up towards the mountains. As seen from the bay, its appearance is picturesque and charming, with the soft tints of its tiles, the gray of its walls, the clumps of verdure in its midst, and the wall of green in the rear. Seen from its streets this beauty disappears, and the chief attraction of the town is gone. Back from the 3 miles of hills which sweep in an arc round the town, is the noble Montagne Pelee lying several miles to the north of the city. A mass of dark rock some 4,000 feet high, with jagged outline, and cleft with gorges and ravines, down which flow numerous streams, gushing from the crater lake of the great volcano. Though known to be a volcano, it was looked upon as practically extinct, though as late as August, 1856, it had been in eruption. No lava at that time came from its crater, but it hurled out great quantities of ashes and mud, with strong sulfurous odor. Then it went to rest again, and slept till 1902. The people had long ceased to fear it. No one expected that grand old Mount Pelee, the slumbering, so it was thought, tranquil old hill, would ever spurt forth fire and death. This was entirely unlooked for. Mont Pelee was regarded by the natives as a sort of protector. They had an almost superstitious affection for it. From the outskirts of the city it rose gradually, its sides grown thick with rich grass, and dotted here and there with spreading shrubbery and drooping trees. There was no pleasanter outing for an afternoon than a journey up the green, velvet-like sides of the towering mountain and a view of the quaint, picturesque city slumbering at its base. A peaceful scene. There were no rocky cliffs, no crags, no protruding boulders. The mountain was peace itself. It seemed to promise perpetual protection. The poetic natives relied upon it to keep back storms from the land and frighten, with its stern brow, the tempests from the sea. They pointed to it with profoundest pride as one of the most beautiful mountains in the world. Children played in its bowers and arbors, families picnicked there day after day during the balmy weather, hundreds of tourists ascended to the summit and looked with pleasure at the beautiful crystal lake which sparkled and glinted in the sunshine. Mont Pelee was the place of enjoyment of the people of St. Pierre. I can hear the placid natives say, "Old Father Pelee is our protector, not our destroyer." Not until 2 weeks before the eruption did the slumbering mountain show signs of waking to death and disaster. On the 23rd of April it first displayed symptoms of internal disquiet. A great column of smoke began to rise from it, and was accompanied from time to time by showers of ashes and cinders. Despite these signals, there was nothing until Monday, May 5th, to indicate actual danger. On that day a stream of smoking mud and lava burst through the top of the crater and plunged into the valley of the River Blanche, overwhelming the Garin sugar works and killing 23 workmen and the son of the proprietor. Mr. Garin's was one of the largest sugar works on the island. Its destruction entailed a heavy loss. The mud which overwhelmed it followed the beds of streams towards the north of the island. The alarm in the city was great, but it was somewhat allayed by the report of an expert commission appointed by the governor, which decided that the eruption was normal and that the city was in no peril. To further allay the excitement, the governor, with several scientists, took up his residence in St. Pierre. He could not restrain the people by force, but the moral effect of his presence and the decision of the scientists had a similar disastrous result. A graphic description by a sufferer. The existing state of affairs during these few waiting days is so graphically given in a letter from Mrs. Thomas T. Prentice, wife of the United States Consul at St. Pierre, to her sister in Melrose, a suburban city of Boston, that we quote it here. My dear sister, this morning the whole population of the city is on the alert and every eye is directed toward Mont Pelee, an extinct volcano. Everybody is afraid that the volcano has taken into its heart to burst forth and destroy the whole island. 50 years ago Mont Pelee burst forth with terrific force and destroyed everything within a radius of several miles. For several days the mountain has been bursting forth in flame and immense quantities of lava are flowing down its sides. All the inhabitants are going up to see it. There is not a horse to be had on the island, those belonging to the natives being kept in readiness to leave at a moment's notice. Last Wednesday, which was April 23rd, I was in my room with little Christine, and we heard 3 distinct shocks. They were so great that we supposed at first that there was someone at the door, and Christine went and found no one there. The first report was very loud, and the second and third were so great that dishes were thrown from the shelves and the house was rocked. We can see Mont Pelee from the rear windows of our house, and although it is fully 4 miles away, we can hear the roar of the fire and lava issuing from it. The city is covered with ashes and clouds of smoke have been over our heads for the last 5 days. The smell of sulfur is so strong that horses on the streets stop and snort, and some of them are obliged to give up, drop in their harness and die from suffocation. Many of the people are obliged to wear wet handkerchiefs over their faces to protect them from the fumes of sulfur. My husband assures me that there is no immediate danger, and when there is the least particle of danger we will leave the place. There is an American schooner, the RF Morse, in the harbor, and she will remain here for at least 2 weeks. If the volcano becomes very bad we shall embark at once and go out to sea. The papers in this city are asking if we are going to experience another earthquake similar to that which struck here some 50 years ago. The fateful 8th of May. The writer of this letter and her husband, Consul Prentice, trusted Mont Pelee too long. They perished, with all the inhabitants of the city, in a deadly flood of fire and ashes that descended on the devoted place on the fateful morning of Thursday, May 8th. Only for the few who were rescued from the ships in the harbor there would be scarcely a living soul to tell that dread story of ruin and death. The most graphic accounts are those given by rescued officers of the Roraima, one of the fleet of the Quebec Steamship Co., trading with the West Indies. This vessel had left the island of Dominica for Martinique at midnight of Wednesday, and reached Saint Pierre about 7 o'clock Thursday morning. The greatest difficulty was experienced in getting into port, the air being thick with falling ashes and the darkness intense. The ship had to grope its way to the anchorage. Appalling sounds were issuing from the mountain behind the town, which was shrouded in darkness. The ashes were falling thickly on the steamer's deck, where the passengers and others were gazing at the town, some being engaged in photographing the scene. The best way in which we can describe a scene of which few lived to tell the story, is to give the narratives of a number of the survivors. From their several stories a coherent idea of the terrible scene can be formed. From the various accounts given of the terrible explosion by officers of the Roraima, we select as a first example the following description by Assistant Purser Thompson. A tale of sudden ruin. I saw Saint Pierre destroyed. It was blotted out by one great flash of fire. Nearly 40,000 persons were all killed at once. Out of 18 vessels lying in the roads only one, the British steamship Rodham, escaped, and she, I hear, lost more than half on board. It was a dying crew that took her out. Our boat, the Roraima, of the Quebec line, arrived at Saint Pierre early Thursday morning. For hours before we entered the roadstead we could see flames and smoke rising from Mont Pelee. No one on board had any idea of danger. Captain G.T. Mugga was on the bridge, and all hands got on deck to see the show. The spectacle was magnificent. As we approached Saint Pierre we could distinguish the rolling and leaping of the red flames that belched from the mountain in huge volumes and gushed high into the sky. Enormous clouds of black smoke hung over the volcano. When we anchored at Saint Pierre I noticed the cable steamship Grappler, the Rodham, 3 or 4 American schooners and a number of Italian and Norwegian barks. The flames were then spurting straight up in the air, now and then waving to one side or the other for a moment and again leaping suddenly higher up. There was a constant muffled roar. It was like the biggest oil refinery in the world burning up on the mountain top. There was a tremendous explosion about 7:45 o'clock, soon after we got in. The mountain was blown to pieces. There was no warning. The side of the volcano was ripped out, and there was hurled straight toward us a solid wall of flame. It sounded like thousands of cannon. The wave of fire was on us and over us like a lightning flash. It was like a hurricane of fire. I saw it strike the cable steamship Grappler broadside on and capsize her. From end to end she burst into flames and then sank. The fire rolled in mass straight down upon Saint Pierre and the shipping. The town vanished before our eyes and the air grew stifling hot, and we were in the thick of it. Wherever the mass of fire struck the sea the water boiled and sent up vast clouds of steam. The sea was torn into huge whirlpools that careened toward the open sea. One of these horrible hot whirlpools swung under the Roraima and pulled her down on her beam ends with the suction. She careened way over to port, and then the fire hurricane from the volcano smashed her, and over she went on the opposite side. The fire wave swept off the masts and smokestack as if they were cut with a knife. Heat caused explosions. Captain Mugga was the only one on deck not killed outright. He was caught by the fire wave and terribly burned. He yelled to get up the anchor, but, before 2 fathoms were heaved in. The Roraima was almost upset by the boiling whirlpool, and the fire wave had thrown her down on her beam ends to starboard. Captain Mugga was overcome by the flames. He fell unconscious from the bridge and toppled overboard. The blast of fire from the volcano lasted only a few minutes. It shriveled and set fire to everything it touched. Thousands of casks of rum were stored in St. Pierre, and these were exploded by the terrific heat. The burning rum ran in streams down every street and out to the sea. This blazing rum set fire to the Roraima several times. Before the volcano burst, the landings of St. Pierre were crowded with people. After the explosion, not one living being was seen on land. Only 25 of those on the Roraima out of 68 were left after the first flash. The French cruiser Suchet came in and took us off at 2 p.m. She remained nearby, helping all she could, until 5 o'clock, then went to Fort de France with all the people she had rescued. At that time it looked as if the entire north end of the island was on fire. C.C. Evans, of Montreal, and John G. Morris, of New York, who were among those rescued, say the vessel arrived at 6 o'clock. As 8 bells were struck, a frightful explosion was heard up the mountain. A cloud of fire, toppling and roaring, swept with lightning speed down the mountainside and over the town and bay. The Roraima was nearly sunk, and caught fire at once. "I can never forget the horrid, fiery, choking whirlwind which enveloped me," said Mr. Evans. "Mr. Morris and I rushed below. We are not very badly burned, not so bad as most of them. When the fire came, we were going to our posts, we are engineers, to weigh anchor and get out. When we came up, we found the ship afire aft, and fought it forward until 3 o'clock, when the Suchet came to our rescue. We were then building a raft." Ben Benson, the carpenter of the Roraima, said, "I was on deck, amidships, when I heard an explosion. The captain ordered me to up anchor. I got to the windlass, but when the fire came I went into the forecastle and got my duds. When I came out I talked with Captain Mugga, Mr. Scott, the first officer, and others. They had been on the bridge. The captain was horribly burned. He had inhaled flames and wanted to jump into the sea. I tried to make him take a life preserver. The captain, who was undressed, jumped overboard and hung onto a line for a while. Then he disappeared." The Cooper's story. James Taylor, a cooper employed on the Roraima, gives the following account of his experience of the disaster. "Hearing a tremendous report and seeing the ashes falling thicker, I dived into a room, dragging with me Samuel Thomas, a gangwayman and fellow countryman, shutting the door tightly. Shortly after I heard a voice, which I recognized as that of the chief mate, Mr. Scott. Opening the door with great caution, I drew him in. The nose of Thomas was burned by the intense heat. We 3 and Thompson, the assistant purser, out of 68 souls on board, were the only persons who escaped practically uninjured. The heat being unbearable, I emerged in a few moments, and the scene that presented itself to my eyes baffles description. All around on the deck were the dead and dying covered with boiling mud. There they lay, men, women and little children, and the appeals of the latter for water were heart-rending. When water was given them they could not swallow it, owing to their throats being filled with ashes or burnt with the heated air. The ship was burning aft, and I jumped overboard, the sea being intensely hot. I was at once swept seaward by a tidal wave, but, the sea receding a considerable distance, the return wave washed me against an upturned sloop to which I clung. I was joined by a man so dreadfully burned and disfigured as to be unrecognizable. Afterwards I found. He was the captain of the Roraima, Captain Mugga. He was in dreadful agony, begging piteously to be put on board his ship. Picking up some wreckage which contained bedding and a tool chest, I, with the help of 5 others who had joined me on the wreck, constructed a rude raft, on which we placed the captain. Then, seeing an upturned boat, I asked one of the 5, a native of Martinique, to swim and fetch it. Instead of returning to us, he picked up 2 of his countrymen and went away in the direction of Fort de France. Seeing the Roddam, which arrived in port shortly after we anchored, Making for the Roraima, I said goodbye to the captain and swam back to the Roraima. The Roddam, however, burst into flames and put to sea. I reached the Roraima at about 2:30, and was afterwards taken off by a boat from the French warship Suchet. 24 others with myself were taken on to Fort de France. 3 of these died before reaching port. A number of others have since died. Samuel Thomas, the gangway man, whose life was saved by the forethought of Taylor, says that the scene on the burning ship was awful. The groans and cries of the dying, for whom nothing could be done, were horrible. He describes a woman as being burned to death with a living babe in her arms. He says that it seemed as if the whole world was afire. Consul Ayme's statement. The inflammable material in the forepart of the ship that would have ignited that part of the vessel was thrown overboard by him and the other 2 uninjured men. The Grappler, the telegraph company's ship, was seen opposite the Usain Garin, and disappeared as if blown up by a submarine explosion. The captain's body was subsequently found by a boat from the Suchet. Consul Ayme, of Guadeloupe, who, as already stated, had hastened to Fort de France on hearing of the terrible event, tells the story of the disaster in the following words. Thursday morning the inhabitants of the city awoke to find heavy clouds shrouding Mont Pelee crater. All day Wednesday horrid detonations had been heard. These were echoed from St. Thomas on the north to Barbados on the south. The cannonading ceased on Wednesday night, and fine ashes fell like rain on St. Pierre. The inhabitants were alarmed, but Governor Maudet, who had arrived at St. Pierre the evening before, did everything possible to allay the panic. The British steamer Roraima reached St. Pierre on Thursday with 10 passengers, among whom were Mrs. Stokes and her 3 children, and Mrs. H.J. Ince. They were watching the rain of ashes, when, with a frightful roar and terrific electric discharges, a cyclone of fire, mud, and steam swept down from the crater over the town and bay, sweeping all before it and destroying the fleet of vessels at anchor off the shore. There the accounts of the catastrophe so far obtainable cease. 30,000 corpses are strewn about, buried in the ruins of St. Pierre, or else floating, gnawed by sharks, in the surrounding seas. 28 charred, half-dead human beings were brought here. 16 of them are already dead, and only 4 of the whole number are expected to recover. A woman's experience on the Roraima. Margaret Stokes, the 9-year-old daughter of the late Clement Stokes, of New York, who, with her mother, a brother aged 4 and a sister aged 3 years, was on the ill-fated steamer Roraima, was saved from that vessel, but is not expected to live. Her nurse, Clara King, tells the following story of her experience. She says she was in her stateroom, when the steward of the Roraima called out to her, "Look at Mont Pelee." She went on deck and saw a vast mass of black cloud coming down from the volcano. The steward ordered her to return to the saloon, saying, "It is coming." Miss King then rushed to the saloon. She says she experienced a feeling of suffocation, which was followed by intense heat. The after part of the Roraima broke out in flames. Ben Benson, the carpenter of the Roraima, severely burned, assisted Miss King and Margaret Stokes to escape. With the help of Mr. Scott, the first mate of the Roraima, he constructed a raft, with life preservers. Upon this Miss King and Margaret were placed. While this was being done, Margaret's little brother died. Mate Scott brought the child water at great personal danger, but it was unavailing. Shortly after the death of the little boy, Mrs. Stokes succumbed. Margaret and Miss King eventually got away on the raft, and were picked up by the steamer Corona. Mate Scott also escaped. Miss King did not sustain serious injuries. She covered the face of Margaret with her dress, but still the child was probably fatally burned. The only woman known at that time to have survived the disaster at St. Pierre was a negress named Philada. She was found in a cellar Saturday afternoon, where she had been for 3 days. She was still alive, but fearfully burned from head to toes. She died afterward in the hospital. Captain Freeman's thrilling account. Of the vessels in the harbor of St. Pierre on the fateful morning, only one, the British steamer Rodham, escaped, and that with a crew of whom few reached the open sea alive. Those who did escape were terribly injured. Captain Freeman, of this vessel, tells what he experienced in the following thrilling language. St. Lucia, British West Indies, May 11th. The steamer Rodham, of which I am captain, left St. Lucia at midnight of May 7th, and was off St. Pierre, Martinique, at 6 o'clock on the morning of the 8th. I noticed that the volcano, Mont Pelee, was smoking, and crept slowly in toward the bay, finding there among others the steamer Roraima, the telegraph repairing steamer Grappler and 4 sailing vessels. I went to anchorage between 7 and 8 and had hardly moored when the side of the volcano opened out with a terrible explosion. A wall of fire swept over the town and the bay. The Rodham was struck broadside by the burning mass. The shock to the ship was terrible, nearly capsizing her. Awful results. Hearing the awful report of the explosion and seeing the great wall of flames approaching the steamer, those on deck sought shelter wherever it was possible, jumping into the cabin, the forecastle, and even into the hold. I was in the chart room, but the burning embers were borne by so swift a movement of the air that they were swept in through the door and portholes, suffocating and scorching me badly. I was terribly burned by these embers about the face and hands, but managed to reach the deck. Then, as soon as it was possible, I mustered the few survivors who seemed able to move, ordered them to slip the anchor, leaped for the bridge and ran the engine for full speed astern. The second and the third engineer and a fireman were on watch below and so escaped injury. They did their part in the attempt to escape, but the men on deck could not work the steering gear because it was jammed by the debris from the volcano. We accordingly went ahead and astern until the gear was free, but in this running backward and forward it was 2 hours after the first shock before we were clear of the bay. One of the most terrifying conditions was that, the atmosphere being charged with ashes, it was totally dark. The sun was completely obscured, and the air was only illuminated by the flames from the volcano and those of the burning town and shipping. It seems small to say that the scene was terrifying in the extreme. As we backed out we passed close to the Roraima, which was one massive blaze. The steam was rushing from the engine room, and the screams of those on board were terrible to hear. The cries for help were all in vain, for I could do nothing but save my own ship. When I last saw the Roraima she was settling down by the stern. That was about 10 o'clock in the morning. When the Rodham was safely out of the harbor of St. Pierre, with its desolations and horrors, I made for St. Lucia. Arriving there, and when the ship was safe, I mustered the survivors as well as I was able and searched for the dead and injured. Some I found in the saloon where they had vainly sought for safety, but the cabins were full of burning embers that had blown in through the portholes. Through these the fire swept as through funnels and burned the victims where they lay or stood, leaving a circular imprint of scorched and burned flesh. I brought 10 on deck who were thus burned. 2 of them were dead, the others survived, although in a dreadful state of torture from their burns. Their screams of agony were here trending. Out of a total of 23 on board the Rodham, which includes the captain and the crew, 10 are dead and several are in the hospital. My first and second mates, my chief engineer and my supercargo, Campbell by name, were killed. The ship was covered from stem to stern with tons of powdered lava, which retained its heat for hours after it had fallen. In many cases it was practically incandescent, and to move about the deck in this burning mass was not only difficult but absolutely perilous. I am only now able to begin thoroughly to clear and search the ship for any damage done by this volcanic rain, and to see if there are any corpses in out-of-the-way places. For instance, this morning, I found one body in the peak of the forecastle. The body was horribly burned and the sailor had evidently crept in there in his agony to die. On the arrival of the Rodham at St. Lucia the ship presented an appalling appearance. Dead and calcined bodies lay about the deck, which was also crowded with injured, helpless and suffering people. Prompt assistance was rendered to the injured by the authorities here and my poor, tortured men were taken to the hospital. The dead were buried. I have omitted to mention that out of 21 black laborers that I brought from Granada to help in stevedoring, only 6 survived. Most of the others threw themselves overboard to escape a dreadful fate, but they met a worse one, for it is an actual fact that the water around the ship was literally at a boiling heat. The escape of my vessel was miraculous. The woodwork of the cabins and bridge and everything inflammable on deck were constantly igniting, and it was with great difficulty that we few survivors managed to keep the flames down. My ropes, awnings, tarpaulins were completely burned up. I witnessed the entire destruction of St. Pierre. The flames enveloped the town in every quarter with such rapidity that it was impossible that any person could be saved. As I have said, the day was suddenly turned to night, but I could distinguish by the light of the burning town people distractedly running about on the beach. The burning buildings stood out from the surrounding darkness like black shadows. All this time the mountain was roaring and shaking, and in the intervals between these terrifying sounds I could hear the cries of despair and agony from the thousands who were perishing. These cries added to the terror of the scene, but it is impossible to describe its horror or the dreadful sensations it produced. It was like witnessing the end of the world. Let me add that, after the first shock was over, the survivors of the crew rendered willing help to navigate the ship to this port. Mr. Plissono, our agent in Martinique, happening to be on board, was saved, and I really believe that he is the only survivor of St. Pierre. As it is, he is seriously burned on the hands and face. Freeman. Master British steamship Rodham. The Edna passes St. Pierre. The British steamer Edna, of the Norton Line, stopped at St. Lucia to coal on May 10th. Captain Cantel there visited the Rodham and had an interview with Captain Freeman. On the 11th the Ilana put to sea again, passing St. Pierre in the afternoon. We subjoin her captain's story. The weather was clear and we had a fine view, but the old outlines of St. Pierre were not recognizable. Everything was a mass of blue lava, and the formation of the land itself seemed to have changed. When we were about 8 miles off the northern end of the island, Mount Pelee began to belch a second time. Clouds of smoke and lava shot into the air and spread over all the sea, darkening the sun. Our decks in a few minutes were covered with a substance that looked like sand dyed a bluish tint, and which smelled like phosphorus. For all that the day was clear, there was little to be seen satisfactorily. Over the island there hung a blue haze. It seemed to me that the formation, the topography, of the island was altered. Everything seemed to be covered with a blue dust, such as had fallen aboard us every day since we had been within the affected region. It was blue lava dust. For more than an hour we scanned the coast with our glasses, now and then discovering something that looked like a ruined hamlet or collection of buildings. There was no life visible. Suddenly we realized that we might have to fight for our lives as the Rodham's people had done. We were about 4 miles off the northern end of the island when suddenly there shot up in the air to a tremendous height a column of smoke. The sky darkened and the smoke seemed to swirl down upon us. In fact, it spread all around, darkening the atmosphere as far as we could see. I called Chief Engineer Farish to the deck. "Do you see that over there?" I asked, pointing to the eruption, for it was the second eruption of Mont Pelee. He saw it all right. Captain Freeman's story was fresh in my mind. "Well, Farish, rush your engines as they have never been rushed before," I said to him. He went below, and soon we began to burn coal and pile up the feathers in our forefoot. I was on watch with Second Officer Gibbs. At once we began to furl awnings and make secure against fire. The crew were all showing an anxious spirit, and everybody on board, including the 4 passengers, were serious and apprehensive. We began to cut through the water at almost 12 knots. Ordinarily we make 10 knots. We could see no more of the land contour, but everything seemed to be enveloped in a great cloud. There was no fire visible, but the lava dust rained down upon us steadily. In less than an hour there were 2 inches of it upon our deck. The air smelled like phosphorus. No one dared to look up to try to locate the sun, because one's eyes would fill with lava dust. Some of the blue lava dust is sticking to our mast yet, although we have swabbed decks and rigging again and again to be clear of it. After a little more than an hour's fast running, we saw daylight ahead and began to breathe easier. If I had not talked with Captain Freeman and heard from him just how the black swirl of wind and fire rolled down upon him, I would not have been so apprehensive, but would have thought that the darkness and cloud that came down upon us meant just an unusually heavy squall. Chief Engineer Farish's story. The Etna's run from Montevideo was a fast one, I think a record breaker. We were 22 days and 21 hours from port to port. Off Martinique I stared at the coast for about an hour, and then went below. The blue lava that covered everything faded into the haze that hung over the island so that nothing was distinctly visible. Through my glass I discovered a stream of lava, though. It stretched down the mountainside, and seemed to be flowing into the sea. It was not clearly and distinctly visible, however. About 3 o'clock I went below to take 40 winks. I had been in my berth only a few minutes when the steward told me the captain wanted me on the bridge. "Do you see that, Farish?" he asked, pointing at the land. An outburst of smoke seemed to be sweeping down upon us. It made me think of the Rodham's experience. Smoke and dust closed in about us, shutting out the sunlight, and precipitating a fall of lava on our decks. "Go below and drive her," said the captain, and I didn't lose any time, I can tell you. We burned coal as though it didn't cost a cent. The safety valve was jumping every second, even though we were making 12 knots an hour. For 2 hours we kept up the pace, and then, running into clear daylight, let the engines slow down and we all cheered up a bit. Captain Cantel visits the Rodham. Captain Cantel went on board the Rodham, whose frightful condition he thus describes. At St. Lucia, on May 11th, I went on board the British steamship Rodham, which had escaped from the terrible volcanic eruption at Martinique 2 days before. The state of the ship was enough to show that those on board must have undergone an awful experience. The Rodham was covered with a mass of fine bluish-gray dust or ashes of cement-like appearance. In some parts it lay 2 feet deep on the decks. This matter had fallen in a red-hot state all over the steamer, setting fire to everything it struck that was burnable, and, when it fell on the men on board, burning off limbs and large pieces of flesh. This was shown by finding portions of human flesh when the decks were cleared of the debris. The rigging, ropes, tarpaulins, sails, awnings, etc., were charred or burned, and most of the upper stanchions and spars were swept overboard or destroyed by fire. Skylights were smashed and cabins were filled with volcanic dust. The scene of ruin was deplorable. The captain, though suffering the greatest agony, succeeded in navigating his vessel safely to the port of Castries, St. Lucia, with 18 dead bodies on the deck and human limbs scattered about. A sailor stood by constantly wiping the captain's injured eyes. I think the performance of the Rodham's captain was most wonderful, and the more so when I saw his pitiful condition. I do not understand how he kept up, yet when the steamer arrived at St. Lucia and medical assistance was procured, this brave man asked the doctors to attend to the others first and refused to be treated until this was done. My interview with the captain brought out this account. I left him in good spirits and receiving every comfort. The sight of his face would frighten anyone not prepared to see it. The vivid account of M. Albert. To the accounts given by the survivors of the Roraima and the officers of the Etna, it will be well to add the following graphic story told by M. Albert, a planter of the island, the owner of an estate situated only a mile to the northeast of the burning crater of Mont Pelee. His escape from death had in it something of the marvelous. He says, Mont Pelee had given warning of the destruction that was to come, but we, who had looked upon the volcano as harmless, did not believe that it would do more than spout fire and steam, as it had done on other occasions. It was a little before 8 o'clock on the morning of May 8 that the end came. I was in one of the fields of my estate when the ground trembled under my feet, not as it does when the earth quakes, but as though a terrible struggle was going on within the mountain. A terror came upon me, but I could not explain my fear. As I stood still, Mont Pelee seemed to shudder, and a moaning sound issued from its crater. It was quite dark, the sun being obscured by ashes and fine volcanic dust. The air was dead about me, so dead that the floating dust seemingly was not disturbed. Then there was a rending, crashing, grinding noise, which I can only describe as sounding as though every bit of machinery in the world had suddenly broken down. It was deafening, and the flash of light that accompanied it was blinding, more so than any lightning I have ever seen. It was like a terrible hurricane, and where a fraction of a second before there had been a perfect calm, I felt myself drawn into a vortex and I had to brace myself firmly. It was like a great express train rushing by, and I was drawn by its force. The mysterious force levelled a row of strong trees, tearing them up by the roots and leaving bare a space of ground 15 yards wide and more than 100 yards long. Transfixed I stood, not knowing in what direction to flee. I looked toward Mont Pelee, and above its apex there appeared a great black cloud which reached high in the air. It literally fell upon the city of Saint Pierre. It moved with a rapidity that made it impossible for anything to escape it. From the cloud came explosions that sounded as though all of the navies of the world were in titanic combat. Lightning played in and out in broad forks, the result being that intense darkness was followed by light that seemed to be of magnifying power. That Saint Pierre was doomed I knew, but I was prevented from seeing the destruction by a spur of the hill that shut off the view of the city. It is impossible for me to tell how long I stood there inert. Probably it was only a few seconds, but so vivid were my impressions that it now seems as though I stood as a spectator for many minutes. When I recovered possession of my senses, I ran to my house and collected the members of the family, all of whom were panic-stricken. I hurried them to the seashore, where we boarded a small steamship, in which we made the trip in safety to Fort de France. I know that there was no flame in the first wave that was sent down upon Saint Pierre. It was a heavy gas, like fire damp, and it must have asphyxiated the inhabitants before they were touched by the fire, which quickly followed. As we drew out to sea in the small steamship, Mont Pelee was in the throes of a terrible convulsion. New craters seemed to be opening all about the summit, and lava was flowing in broad streams in every direction. My estate was ruined while we were still in sight of it. Many women who lived in Saint Pierre escaped only to know that they were left widowed and childless. This is because many of the wealthier men sent their wives away, while they remained in Saint Pierre to attend to their business affairs. What happened on the Horace? The British steamer Horace experienced the effect of the explosion when farther from land. After touching at Barbados, she reached the vicinity of Martinique on May 9th, her decks being covered with several inches of dust when she was 125 miles distant. We quote Engineer Anderson's story. On the afternoon of May 8th, Thursday, we noticed a peculiar haze in the direction of Martinique. The air seemed heavy and oppressive. The weather conditions were not at all unlike those which precede the great West Indian hurricanes, but, knowing it was not the season of the year for them, we all remarked in the engine room that there must be a heavy storm approaching. Several of the sailors, experienced deep-water seamen, laughed at our prognostications, and informed us there would be no storm within the next 60 hours, and insisted that, according to all FOCALE indications, a dead calm was in sight. So unusually peculiar were the weather conditions that we talked of nothing else during the evening. That night, in the direction of Martinique, there was a very black sky, an unusual thing at this season of the year, and a storm was apparently brewing in a direction from which storms do not come at this season. Great flashes of light. As the night wore on, those on watch noticed what appeared to be great flashes of lightning in the direction of Martinique. It seemed as though the ordinary conditions were reversed, and even the FOCALE prophets were unable to offer explanations. Occasionally, over the pounding of the engines and the rush of water, we thought we could hear long, deep roars, not unlike the ending of a deep peal of thunder. Several times we heard the rumble or roar, but at the time we were not certain as to exactly what it was, or even whether we really heard it. There would suddenly come great flashes of light from the dark bank toward Martinique. Some of them seemed to spread over a great area, while others appeared to spout skyward, funnel-shaped. All night this continued, and it was not until day came that the flashes disappeared. The dark bank that covered the horizon toward Martinique, however, did not fade away with the breaking of day, and at 8 in the morning of the 9th, Friday, the whole section of the sky in that direction seemed dark and troubled. About 9 o'clock Friday morning I was sitting on one of the hatches aft with some of the other engineers and officers of the ship, discussing the peculiar weather phenomena. I noticed a sort of grit that got into my mouth from the end of the cigar I was smoking. I attributed it to some rather bad coal which we had shipped aboard, and, turning to Chief Engineer Evans, I remarked that coal was mighty dirty, and he said that it was covering the ship with a sort of grit. Then I noticed that grit was getting on my clothes, and finally someone suggested that we go forward of the funnels, so we would not get dirt on us. As we went forward we met one or two of the sailors from the forecastle, who wanted to know about the dust that was falling on the ship. Then we found that the grayish-looking ash was sifting all over the ship, both forward and aft. Ashes rained on the ship. Every moment the ashes rained down all over the ship, and at the same time grew thicker. A few moments later, the lookout called down that we were running into a fog bank dead ahead. Fog banks in that section are unheard of at 9 o'clock in the morning at this season, and we were more than 100 miles from land, and what could fog and sand be doing there? Before we knew it, we went into the fog, which proved to be a big dense bank of this same sand, and it rained down on us from every side. Ventilators were quickly brought to their places, and later even the hatches were battened down. The dust became suffocating, and the men at times had all they could do to keep from choking. What the stuff was we could not at first conjecture, or rather, we didn't have much time to speculate on it, for we had to get our ship in shape to withstand we hardly knew what. At first we thought that the sand must have been blown from shore. Then we decided that if the captain's figures were right we wouldn't be near enough to shore to have sand blow on us, and as we had just cleared Barbados, we knew that the captain's figures had to be right. Just as the storm of sand was at its height, 4th Engineer Wild was nearly suffocated by it, but was easily revived. About this time it became so dark that we found it necessary to start up the electric lights, and it was not until after we got clear from the fog that we turned the current off. In the meantime they had burned from 9 o'clock in the morning until after 2 in the afternoon. The engine became choked. Then there was another anxious moment shortly after 9 o'clock. 3rd Engineer Rennie had been running the donkey engine, when suddenly it choked, and when he finally got it clear from the sand or ashes, he found the valves were all cut out, and then it was we discovered that it was not sand, but some sort of a composition that seemed to cut steel like emery. Then came the danger that it would get into the valves of the engine and cut them out. And for several moments all hands scurried about and helped make the engine room tight, and even then the ash drifted in and kept all the engine room force wiping the engines clear of it. Toward 3 o'clock in the afternoon of Friday we were practically clear of the sand, but at 11 o'clock that night we ran into a second bank of it, though not as bad as the first. We made some experiments, and found the stuff was superior to emery dust. It cut deeper and quicker, and only about half as much was required to do the work. We made up our minds we would keep what came on board, as it was better than the emery dust and much cheaper, so we gathered it up. That night there were more of the same electric phenomena toward Martinique, but it was not until we got into St. Lucia, where we saw the Rotterdam, that we learned of the terrible disaster at St. Pierre, and then we knew that our sand was lava dust. The volcanic ash which fell on the decks of the Horace was ground as fine as rifle powder, and was much finer than that which covered the decks of the Etna. Returning to the stories told by officers of the Roraima, of which a number have been given, it seems desirable to add here the narrative of Ellery S. Scott, the mate of the ruined ship, since it gives a vivid and striking account of his personal experience of the frightful disaster, with many details of interest not related by others. Mate Scott's graphic story. We got to St. Pierre in the Roraima, began Mr. Scott, at 6:30 o'clock on Thursday morning. That's the morning the mountain and the town and the ships were all sent to hell in a minute. All hands had had breakfast. I was standing on the focsl head trying to make out the marks on the pipes of a ship way out and heading for St. Lucia. I wasn't looking at the mountain at all. But I guess the captain was, for he was on the bridge, and the last time I heard him speak was when he shouted, "Heave up, Mr. Scott, heave up." I gave the order to the men, and I think some of them did jump to get the anchor up, but nobody knows what really happened for the next 15 minutes. I turned around toward the captain and then I saw the mountain. Did you ever see the tide come into the Bay of Fundy? It doesn't sneak in a little at a time as it does round here. It rolls in waves. That's the way the cloud of fire and mud and white-hot stones rolled down from that volcano over the town and over the ships. It was on us in almost no time, but I saw it, and in the same glance I saw our captain bracing himself to meet it on the bridge. He was facing the fire cloud with both hands gripped hard to the bridge rail, his legs apart and his knees braced back stiff. I've seen him brace himself that same way many a time in a tough sea with the spray going masthead high and green water pouring along the decks. I saw the captain, I say, at the same instant I saw that ruin coming down on us. I don't know why, but that last glimpse of poor Mugga on his bridge will stay with me just as long as I remember St. Pierre, and that will be long enough. In another instant it was all over for him. As I was looking at him he was all ablaze. He reeled and fell on the bridge with his face toward me. His mustache and eyebrows were gone in a jiffy. His hat had gone, and his hair was aflame, and so were his clothes from head to foot. I knew he was conscious when he fell, by the look in his eyes, but he didn't make a sound. That all happened a long way inside of half a minute, then something new happened. When the wave of fire was going over us, a tidal wave of the sea came out from the shore and did the rest. That wall of rushing water was so high and so solid that it seemed to rise up and join the smoke and flame above. For an instant we could see nothing but the water and the flame. That tidal wave picked the ship up like a canoe and then smashed her. After one list to starboard the ship righted, but the masts, the bridge, the funnel, and all the upper works had gone overboard. I had saved myself from fire by jamming a metal ventilator cover over my head and jumping from the FOCSL head. 2 St. Kitts Negroes saved me from the water by grabbing me by the legs and pulling me down into the FOCSL after them. Before I could get up 3 men tumbled in on top of me. 2 of them were dead. Captain Mugga went overboard, still clinging to the fragments of his wrecked bridge. Daniel Taylor, the ship's cooper, and a Kitts native jumped overboard to save him. Taylor managed to push the captain onto a hatch that had floated off from us, and then they swam back to the ship for more assistance, but nothing could be done for the captain. Taylor wasn't sure he was alive. The last we saw of him or his dead body, it was drifting shoreward on that hatch. Well, after staying in the FOCSL about 20 minutes I went out on deck. There were just 4 of us left aboard who could do anything. The 4 were Thompson, Dan Taylor, Quashie, and myself. It was still raining fire and hot rocks and you could hardly see a ship's length for dust and ashes, but we could stand that. There were burning men and some women and 2 or 3 children lying around the deck. Not just burned, but burning, then, when we got to them. More than half the ship's company had been killed in that first rush of flame. Some had rolled overboard when the tidal wave came and we never saw so much as their bodies. The cook was burned to death in his galley. He had been paring potatoes for dinner and what was left of his right hand held the shank of his potato knife. The wooden handle was in ashes. All that happened to a man in less than a minute. The donkey engineman was killed on deck sitting in front of his boiler. We found parts of some bodies, a hand, or an arm or a leg. Below decks there were some 20 alive. The ship was on fire, of course, what was left of it. The stumps of both masts were blazing. Aft she was like a furnace, but forward the flames had not got below deck, so we 4 carried those who were still alive on deck into the FOCSL. All of them were burned and most of them were half strangled. One boy, a passenger, and just a little shaver, the 4-year-old son of the late Clement Stokes, above spoken of, was picked up naked. His hair and all his clothing had been burned off, but he was alive. We rolled him in a blanket and put him in a sailor's bunk. A few minutes later we looked at him and he was dead. My own son's gone, too. It had been his trick at lookout ahead during the dog watch that morning, when we were making for St. Pierre, so I supposed at first when the fire struck us that he was asleep in his bunk and safe. But he wasn't. Nobody could tell me where he was. I don't know whether he was burned to death or rolled overboard and drowned. He was a likely boy. He had been several voyages with me and would have been a master someday. He used to say he'd make me mate. After getting all hands that had any life left in them below and tended to the best we could, the 4 of us that were left halfway shipshape started in to fight the fire. We had case oil stowed forward. Thanks to that tidal wave that cleared our decks, there wasn't much left to burn. So we got the fire down so's we could live on board with it for several hours more, and then the 4 turned to knock a raft together out of what timber and truck we could find below. Our boats had gone overboard with the masts and funnel. Prepared to trust to luck. We made that raft for something over 30 that were alive. We put provisions on for 2 days and rigged up a makeshift mast and sail, for we intended to go to sea. We were only 3 boats' length from the shore, but the shore was hell itself. We intended to put straight out and trust to luck that the Corona, that was about due at St. Pierre, would pick us up. But we did not have to risk the raft, for about 3 o'clock in the afternoon, when we were almost ready to put the raft overboard, the Suchet came along and took us all off. We thought for a minute just after we were wrecked that we were to get help from a ship that passed us. We burned blue lights, but she kept on. We learned afterward that she was the Rotterdam. Soundings made off Martinique after the explosion showed that earthquake effects of much importance had taken place under the sea bottom, which had been lifted in some places and had sunk in others. While deep crevices had been formed on the land, a still greater effect had seemingly been produced beneath the water. During the explosion, the sea withdrew several hundred feet from its shoreline, and then came back steaming with fury, this indicating a lift and fall of the ocean bed off the isle. Soundings made subsequently near the island found in one place a depth of 4,000 feet where before it had been only 600 feet deep. The French cable company, which was at work trying to repair the cables broken by the eruption, found the bottom of the Caribbean Sea so changed as to render the old charts useless. New charts will need to be made for future navigation. The changes in sea levels were not confined to the immediate center of volcanic activity, but extended as far north as Puerto Rico, and it was believed that the seismic wave would be found to have altered the ocean bed round Jamaica. Vessels plying between St. Thomas, Martinique, St. Lucia, and other islands found it necessary to heave the lead while many miles at sea. It is estimated that the sea had encroached from 10 feet to 2 miles along the coast of St. Vincent near Georgetown, and that a section on the north of the island had dropped into the sea. Soundings showed 7 fathoms where before the eruption there were 36 fathoms of water. Vessels that endeavored to approach St. Vincent toward the north reported that it was impossible to get nearer than 8 miles to the scene of the catastrophe, and that at that distance the ocean was seriously perturbed as from a submarine volcano, boiling and hissing continually. In this connection, the remarkable experience reported by the officers of the Danish steamship Nordby on the day preceding the eruption is of much interest, as seeming to show great convulsions of the sea bottom at a point several hundred miles from Martinique. The following is the story told by Captain Eric Liljensk-Jold. The strange experience of the Nordby. On May 5 the captain said, "We touched at St. Michael's for water. We had had an easy voyage from Girgenti, in Sicily, and we wanted to finish an easy run here. We left St. Michael's on the same day. Nothing worthwhile talking about occurred until 2 days afterward, Wednesday, May 7th. We were plodding along slowly that day. About noon I took the bridge to make an observation. It seemed to be hotter than ordinary. I shed my coat and vest and got into what little shade there was. As I worked it grew hotter and hotter. I didn't know what to make of it. Along about 2 o'clock in the afternoon it was so hot that all hands got to talking about it. We reckoned that something queer was coming off, but none of us could explain what it was. You could almost see the pitch softening in the seams. Then, as quick as you could toss a biscuit over its rail, the Nordby dropped 3 or 4 feet down into the sea. No sooner did it do this than big waves, that looked like they were coming from all directions at once, began to smash against our sides. This was queerer yet, because the water a minute before was as smooth as I ever saw it. I had all hands piped on deck and we battened down everything loose to make ready for a storm. And we got it all right, the strangest storm you ever heard tell of. There was something wrong with the sun that afternoon. It grew red and then dark red and then, about 2:15, it went out of sight altogether. The day got so dark that you couldn't see half a ship's length ahead of you. We got our lamps going, and put on our oilskins, ready for a hurricane. All of a sudden there came a sheet of lightning that showed up the whole tumbling sea for miles and miles. We sort of ducked, expecting an awful crash of thunder, but it didn't come. There was no sound except the big waves pounding against our sides. There wasn't a breath of wind. Well, sir, at that minute there began the most exciting time I've ever been through, and I've been on every sea on the map for 25 years. Every second there'd be waves 15 or 20 feet high, belting us head on, stern on and broadside, all at once. We could see them coming, for without any stop at all flash after flash of lightning was blazing all about us. Something else we could see, too. Sharks. There were hundreds of them on all sides, jumping up and down in the water. Some of them jumped clear out of it. And seabirds. A flock of them, squawking and crying, made for our rigging and perched there. They seemed like they were scared to death. But the queerest part of it all was the water itself. It was hot, not so hot that our feet could not stand it when it washed over the deck, but hot enough to make us think that it had been heated by some kind of a fire. Well, that sort of thing went on hour after hour. The waves, the lightning, the hot water and the sharks, and all the rest of the odd things happening, frightened the crew out of their wits. Some of them prayed out loud, I guess the first time they ever did in their lives. Some Frenchmen aboard kept running around and yelling, "C'est le dernier jour." This is the last day. We were all worried. Even the officers began to think that the world was coming to an end. Mighty strange things happen on the sea, but this topped them all. I kept to the bridge all night. When the first hour of morning came, the storm was still going on. We were all pretty much tired out by that time, but there was no such thing as trying to sleep. The waves still were batting us around and we didn't know whether we were 1 mile or 1,000 miles from shore. At 2 o'clock in the morning all the queer goings on stopped just the way they began all of a sudden. We lay to until daylight, then we took our reckonings and started off again. We were about 700 miles off Cape Henlopen. No, sir, you couldn't get me through a thing like that again for $10,000. None of us was hurt, and the old Nordby herself pulled through all right, but I'd sooner stay ashore than see waves without wind and lightning without thunder. Fiery stream contained poisonous gases. Careful inspection showed that the fiery stream which so completely destroyed St. Pierre must have been composed of poisonous gases, which instantly suffocated everyone who inhaled them, and of other gases burning furiously, for nearly all the victims had their hands covering their mouths, or were in some other attitude showing that they had perished from suffocation. It is believed that Montpellier threw off a great gasp of some exceedingly heavy and noxious gas, something akin to fire damp, which settled upon the city and rendered the inhabitants insensible. This was followed by the sheet of flame that swept down the side of the mountain. This theory is sustained by the experience of the survivors who were taken from the ships in the harbor, as they say that their first experience was one of faintness. The dumb animals were wiser than man, and early took warning of the storm of fire which Montpellier was storing up to hurl upon the island. Even before the mountain began to rumble, late in April, livestock became uneasy, and at times were almost uncontrollable. Cattle lowed in the night. Dogs howled and sought the company of their masters, and when driven forth they gave every evidence of fear. Wild animals disappeared from the vicinity of Montpellier. Even the snakes, which at ordinary times are found in great numbers near the volcano, crawled away. Birds ceased singing and left the trees that shaded the sides of Pili. A great fear seemed to be upon the island, and though it was shared by the human inhabitants, they alone neglected to protect themselves. Of the villages in the vicinity of Saint Pierre only one escaped, the others suffering the fate of the city. The fortunate one was El Icarbet, on the south, which escaped uninjured, the flood of lava stopping when within 200 feet of the town. Morne Rouge, a beautiful summer resort, frequented by the people of the island during the hot season as a place of recreation, also escaped. In the height of the season several thousand people gathered there, though at the time of the explosion there were but a few hundred. Though located on an elevation between the city and the crater, it was by great good fortune saved. The governor of Martinique, Mr. Maudet, whose precautions to prevent the people fleeing from the city aided to make the work of death complete, was himself among the victims of the burning mountain. With him in this fate was Colonel Dane, commander of the troops who formed a cordon round the doomed city. Chapter XXIX. Saint Vincent Island and Mont Soufriere in 1812. Among all the islands of the Caribbean, Saint Vincent is unique in natural wonders and beauties. Situated about 95 miles west of Barbados, it has a length of 18 and a width of 11 miles, the whole mass being largely composed of a single peak which rises from the ocean's bed. From north to south volcanic hills traverse its length, their ridges intersected by fertile and beautiful valleys. A ridge of mountains crosses the island, dividing it into eastern and western parts. Kingstown, the capital, a town of 8,000 inhabitants, is on the southward side and extends along the shores of a beautiful bay, with mountains gradually rising behind it in the form of a vast amphitheater. 3 streets, broad and lined with good houses, run parallel to the waterfront. There are many other intersecting highways, some of which lead back to the foothills, from which good roads ascend the mountains. The majority of the houses have red tile roofing and a goodly number of them are of stone, 1 story high, with thick walls after the Spanish style, the same types of houses that were in Saint Pierre and which are not unlike the old Roman houses which in all stages of ruin and semi-preservation are found in Pompeii to this day. Behind the general group of the houses of the town loom the governor's residence and the buildings of the botanical gardens which overlook the town. Kingstown is the trading center and the town of importance in the island. It contains the churches and chapels of 5 Protestant denominations and a number of excellent schools. Away from Kingstown and the smaller settlement of Georgetown, the population is almost wholly rural, occupying scattered villages which consist of Negro huts clustering around a few substantial buildings or of cabins grouped about old plantation buildings somewhat after the antebellum fashion in our own southern states. One of the tragedies of the West Indies was the sinking of Old Port Royal, the resort of buccaneers, in 1692. The harbor of Kingstown is commonly supposed to cover the site of the old settlement. There is a tradition that a buoy for many years was attached to the spire of a sunken church in order to warn mariners. 3,000 persons perished in the disaster. Descendants of original Indian population. The northern portion of the island, that desolate by the recent volcanic eruption, was inhabited by people living in the manner just described, the great majority of them being Negroes. The total population of the island is about 45,000, of whom 30,000 are Africans and about 3,000 Europeans, the remainder being nearly all Asiatics. There are, or rather were, a number of Caribs, the descendants of the original warlike Indian population of these islands. Many of these live in Saint Vincent, though there are others in Dominico. As their residence was in the northern section of the island, the volcano seems to have completed the work for the Caribs of this island which the Spaniard long ago began. These Caribs were really half-breds, having amalgamated with the Negroes. Many of the blacks own land of their own, raising arrowroot, which, since the decay of the sugar industry, is the chief export. In an island only 18 miles long by 11 broad there is not room for any distinctly marked mountain range. The whole of Saint Vincent, in fact, is a fantastic tumble of hills, culminating in the volcanic ridge which runs lengthwise of the oval-shaped island. The culminating peak of the great volcanic mass, for St. Vincent is nothing more, is Mont Garou, of which La Soufriere is a sort of lofty excrescence in the northwest, 4,048 feet high, and flanking the main peak at some distance away. It may be said that all the volcanic mountains in this part of the West Indies have what the people call a soufriere-a sulfur pit, or sulfur crater. The name coming, as in the case of past disturbances of Mont Pelee, from the strong stench of sulfur and hydrogen which issues from them when the volcano becomes agitated. In 1812 it was La Soufriere adjacent to Mont Garou which broke loose on the island of St. Vincent, and it is the same soufriere which again has devastated the island and has bombarded Kingstown with rocks, lava, and ashes. The old crater of Mont Garou has long been extinct, and, like the old crater of Mont Pelee, near St. Pierre, it had far down in its depths, surrounded by sheer cliffs from 500 to 800 feet high, a lake. Glimpses of the lake of Mont Garou are difficult to get, owing to the thick verdure growing about the dangerous edges of the precipices, but those who have seen it describe it as a beautiful sheet of deep blue water. The appearance of the soufriere. Previous to the eruption of 1812, the appearance of the soufriere was most interesting. The crater was half a mile in diameter and 500 feet in depth. In its center was a conical hill, fringed with shrubs and vines, at whose base were two small lakes, one sulphurous, the other pure and tasteless. This lovely and beautiful spot was rendered more interesting by the singularly melodious notes of a bird. An inhabitant of these upper solitudes, and altogether unknown to the other parts of the island, hence called, or supposed to be, invisible, as it had never been seen. It is of interest to state that Frederick Ober, in a visit to the island some 20 years ago, succeeded in obtaining specimens of this previously unknown bird. From the fissures of the cone a thin white smoke exuded, occasionally tinged with a light blue flame. Evergreens, flowers, and aromatic shrubs clothed the steep sides of the crater, which made, as the first indication of the eruption on April 27, 1812, a tremulous noise in the air. A severe concussion of the earth followed, and then a column of thick black smoke burst from the crater. The eruption of 1812. The eruption which followed these premonitory symptoms was one of the most terrific which had occurred in the West Indies up to that time. It was the culminating event which seemed to relieve a pressure within the Earth's crust which extended from the Mississippi Valley to Caracas, Venezuela, producing terrible effects in the latter place. Here, 35 days before the volcanic explosion, the ground was rent and shaken by a frightful earthquake which hurled the city in ruins to the ground and killed 10,000 of its inhabitants in a moment of time. La Soufriere made the first historic display of its hidden powers in 1718, when lava poured from its crater. A far more violent demonstration of its destructive forces was that above mentioned. On this occasion the eruption lasted for 3 days, ruining a number of the estates in the vicinity and destroying many lives. Myriads of tons of ashes, cinders, pumice, and scoriae, hurled from the crater, fell in every section of the island. Volumes of sand darkened the air, and woods, ridges and cane fields were covered with light gray ashes, which speedily destroyed all vegetation. The sun for 3 days seemed to be in a total eclipse, the sea was discolored and the ground bore a wintry appearance from the white crust of fallen ashes. Carib natives who lived at Mornron fled from their houses to Kingstown. As the third day drew to a close, flames sprang pyramidically from the crater, accompanied by loud thunder and electric flashes, which rent the column of smoke hanging over the volcano. Eruptive matter pouring from the northwest side plunged over the cliff, carrying down rocks and woods in its course. The island was shaken by an earthquake and bombarded with showers of cinders and stones, which set houses on fire and killed many of the natives. The terrible earthquake at Caracas. For nearly 2 years before this explosion, earthquakes had been common, and sea and land had been agitated from the valley of the Mississippi to the coasts of Venezuela and the mountains of New Granada, and from the Azores to the West Indies. On March 26, 1812, these culminated in the terrible tragedy, spoken of above, of which Humboldt gives us a vivid account. On that day the people of the Venezuelan city of Caracas were assembled in the churches, beneath a still and blazing sky. When the earth suddenly heaved and shook, like a great monster waking from slumber, and in a single minute 10,000 people were buried beneath the walls of churches and houses, which tumbled in hideous ruin upon their heads. The same earthquake made itself felt along the whole line of the northern Cordilleras, working terrible destruction, and shook the earth as far as Santa Fe, Bogota and Honda, 180 leagues from Caracas. This was a preliminary symptom of the internal disorder of the earth. While the wretched inhabitants of Caracas who had escaped the earthquake were dying of fever and starvation, and seeking among villages and farms places of safety from the renewed earthquake shocks, the almost forgotten volcano of St. Vincent was muttering in suppressed wrath. For 12 months it had given warning, by frequent shocks of the earth, that it was making ready to play its part in the great subterranean battle. On the 27th of April its deep hidden powers broke their bonds, and the conflict between rock and fire began. The mountain stones a herd boy. The first intimation of the outbreak was rather amusing than alarming. A Negro boy was herding cattle on the mountainside. A stone fell near him. Another followed. He fancied that some other boys were pelting him from the cliff above, and began throwing stones upward at his fancied concealed tormentors. But the stones fell thicker, among them some too large to be thrown by any human hand. Only then did the little fellow awake to the fact that it was not a boy like himself, but the mighty mountain, that was flinging these stones at him. He looked up and saw that the black column which was rising from the crater's mouth was no longer harmless vapor, but dust, ashes, and stones. Leaving the cattle to their fate, he fled for his life, while the mighty cannon of the Titans roared behind him as he ran. For 3 days and nights this continued, then, on the 30th, a stream of lava poured over the crater's rim and rushed downward, reaching the sea in 4 hours, and the great eruption was at an end. On the same day, says Humboldt, at a distance of more than 200 leagues, the inhabitants not only of Caracas, but of Calabozo, situated in the midst of the Llanos, over a space of 4,000 square leagues, were terrified by a subterranean noise which resembled frequent discharges of the heaviest cannon. It was accompanied by no shock, and, what is very remarkable, was as loud on the coast as at 80 leagues distance inland, and at Caracas, as well as at Calabozo, preparations were made to put the place in defense against an enemy who seemed to be advancing with heavy artillery. It was no enemy that man could deal with. Fortunately, it confined its assault to deep noises, and desisted from earthquake shocks. Similar noises were heard in Martinique and Guadeloupe, and here also without shocks. The internal thunder was the signal of what was taking place on St. Vincent. With this last warning sound the trouble, which had lasted so long, was at an end. The earthquakes which for 2 years had shaken a sheet of the Earth's surface larger than half Europe, were stilled by the eruption of St. Vincent's volcanic peak. Barbados covered with ashes. Northeast of the original crater of the Soufriere a new one was formed which was a half-mile in diameter and 500 feet deep. The old crater was in time transformed into a beautiful blue lake, as above stated, walled in by ragged cliffs to a height of 800 feet. It was looked upon as a remarkable circumstance that although the air was perfectly calm during the eruption, Barbados, which is 95 miles to the windward, was covered inches deep with ashes. The inhabitants there and on other neighboring islands were terrified by the darkness, which continued for 4 hours and a half. Troops were called under arms, the supposition from the continued noise being that hostile fleets were in an engagement. The movement of the ashes to windward, as just stated, was viewed as a remarkable phenomenon, and is cited by Elise Reclus, in The Ocean, to show the force of different aerial currents. On the first day of May, 1812, when the northeast trade wind was in all its force, enormous quantities of ashes obscured the atmosphere above the island of Barbados, and covered the ground with a thick layer. One would have supposed that they came from the volcanoes of the Azores, which were to the northeast, nevertheless they were cast up by the crater in St. Vincent, 100 miles to the west. It is therefore certain that the debris had been hurled, by the force of the eruption, above the moving sheet of the trade winds into an aerial river proceeding in a contrary direction. For this it must have been hurled miles high into the air, till caught by the current of the anti-trade winds. Kingsley's visit to St. Vincent. From Charles Kingsley's at last we extract, from the account of the visit of the author to St. Vincent, some interesting matter concerning the 1812 eruption and its effect on the mountain, also its influence upon distant Barbados, as just stated. The strangest fact about this eruption was, that the mountain did not make use of its old crater. The original vent must have become so jammed and consolidated in the few years between 1785 and 1812, that it could not be reopened, even by a steam force the vastness of which may be guessed at from the vastness of the area which it had shaken for 2 years. So, when the eruption was over, it was found that the old crater lake, incredible as it may seem, remained undisturbed, so far as has been ascertained. But close to it, and separated only by a knife edge of rock some 700 feet in height, and so narrow that, as I was assured by one who had seen it, it is dangerous to crawl along it, a second crater, nearly as large as the first, had been blasted out, the bottom of which, in like manner, was afterward filled with water. I regretted much that I could not visit it. 3 points I longed to ascertain carefully: the relative heights of the water in the two craters, the height and nature of the spot where the lava stream issued, and, lastly, if possible, the actual causes of the locally famous Rebecca, or Dry River, one of the largest streams in the island, which was swallowed up during the eruption, at a short distance from its source, leaving its bed an arid gully to this day. But it could not be, and I owe what little I know of the summit of the Soufriere principally to a most intelligent and gentlemanlike young Wesleyan minister, whose name has escaped me. He described vividly, as we stood together on the deck, looking up at the volcano, the awful beauty of the twin lakes, and of the clouds which, for months together, whirl in and out of the cups in fantastic shapes before the eddies of the trade wind. Black Sunday at Barbados. The day after the explosion, Black Sunday, gave a proof of, though no measure of, the enormous force which had been exerted. 80 miles to windward lies Barbados. All Saturday a heavy cannonading had been heard to the eastward. The English and French fleets were surely engaged. The soldiers were called out, the batteries manned, but the cannonade died away, and all went to bed in wonder. On the 1st of May the clocks struck 6, but the sun did not, as usual in the tropics, answer to the call. The darkness was still intense, and grew more intense as the morning wore on. A slow and silent rain of impalpable dust was falling over the whole island. The negroes rushed shrieking into the streets. Surely the last day was come. The white folk caught, and little blame to them, the panic, and some began to pray who had not prayed for years. The pious and the educated, and there were plenty of both in Barbados, were not proof against the infection. Old letters describe the scene in the churches that morning as hideous prayers, sobs, and cries, in Stygian darkness, from trembling crowds. And still the darkness continued and the dust fell. Incidents at Barbados. I have a letter written by one long since dead, who had at least powers of description of no common order, telling how, when he tried to go out of his house upon the east coast, he could not find the trees on his own lawn save by feeling for their stems. He stood amazed not only in utter darkness, but in utter silence, for the trade wind had fallen dead, the everlasting roar of the surf was gone, and the only noise was the crashing of branches, snapped by the weight of the clammy dust. He went in again, and waited. About 1 o'clock the veil began to lift, a lurid sunlight stared in from the horizon, but all was black overhead. Gradually the dust drifted away, the island saw the sun once more, and saw itself inches deep in black, and in this case fertilizing, dust. The trade wind blew suddenly once more out of the clear east, and the surf roared again along the shore. Meanwhile a heavy earthquake wave had struck part at least of the shores of Barbados. The gentlemen on the east coast, going out, found traces of the sea, and boats, and logs washed up some 10 to 20 feet above high tide mark, a convulsion which seemed to have gone unmarked during the general dismay. One man at least, an old friend of John Hunter, Sir Joseph Banks and others their compeers, was above the dismay, and the superstitious panic which accompanied it. Finding it still dark when he rose to dress, he opened, so the story used to run, his window, found it stick, and felt upon the sill a coat of soft powder. The volcano in St. Vincent has broken out at last, said the wise man, and this is the dust of it. So he quieted his household and his negroes, lighted his candles, and went to his scientific books, in that delight, mingled with an awe not the less deep, because it is rational and self-possessed, with which he, like the other men of science, looked at the wonders of this wondrous world. Chapter XXX. Submarine volcanoes and their work of island building. In November 1867, a volcano suddenly began to show signs of activity beneath the deep sea of the Pacific Ocean. There are some islands nearly 2,000 miles to the east of Australia called the Navigators Group, in which there had been no history of an eruption, nor had such an event been handed down by tradition. Most of the islands in the Pacific Ocean are old volcanoes, or are made up of rocks cast forth from extinct burning mountains. They rise up like peaks through the great depths of the ocean, and the top, which just appears above the sea level, is generally encircled by a growth of coral. Hence they are termed coral islands. These islands every now and then rise higher than the sea level, owing to some deep upheaving force, and then the coral is lifted up above the water, and become a solid rock. But occasionally the reverse of this takes place, and the islands begin to sink into the sea, owing to a force which causes the base of the submarine mountain to become depressed. Sometimes they disappear. All this shows that some great disturbing forces are in action at the bottom of the sea, and just within the Earth's crust, and that they are of a volcanic nature. For some time before the eruption in question, earthquakes shook the surrounding islands of the Navigators Group, and caused great alarm, and when the trembling of the earth was very great, the sea began to be agitated near one of the islands, and vast circles of disturbed water were formed. Soon the water began to be forced upwards, and dead fish were seen floating about. After a while, steam rushed forth, and jets of mud and volcanic sand. Moreover, when the steam began to rush up out of the water, the violence of the general agitation of the land and of the surface of the sea increased. An eruption described. When the eruption was at its height, vast columns of mud and masses of stone rushed into the air to a height of 2,000 feet, and the fearful crash of masses of rock hurled upwards and coming in collision with others which were falling attested the great volume of ejected matter which accumulated in the bed of the ocean. Although no trace of a volcano could be seen above the surface of the sea, similar submarine volcanic action has been observed in the Atlantic Ocean, and crews of ships have reported that they have seen in different places sulfurous smoke, flame, jets of water, and steam, rising up from the sea, or they have observed the waters greatly discolored and in a state of violent agitation, as if boiling in large circles. New shoals have also been encountered, or a reef of rocks just emerging above the surface, where previously there was always supposed to have been deep water. On some few occasions, the gradual building up of an island by submarine volcanoes has been observed, as that of Sabrina in 1181, off St. Michael's, in the Azores. The throwing up of ashes in this case, and the formation of a conical hill 300 feet high, with a crater out of which spouted lava and steam, took place very rapidly. But the waves had the best of it, and finally washed Sabrina into the depths of the ocean. Previous eruptions in the same part of the sea were recorded as having happened in 1691 and 1720. In 1831, a submarine volcanic eruption occurred in the Mediterranean Sea, between Sicily and that part of the African coast where Carthage formerly stood. A few years before, Captain Smith had sounded the spot in a survey of the sea ordered by government, and he found the sea bottom to be under 500 feet of water. On June 28, about a fortnight before the eruption was visible, Sir Pulteney Malcolm, in passing over the spot in his ship, felt the shock of an earthquake as if he had struck on a sandbank, and the same shocks were felt on the west coast of Sicily, in a direction from southwest to northeast. Building up of an island by submarine volcanoes. About July 10th, the captain of a Sicilian vessel reported that as he passed near the place he saw a column of water like a waterspout, 60 feet high, and 800 yards in circumference, rising from the sea, and soon after a dense rush of steam in its place, which ascended to the height of 1,800 feet. The same captain, on his return 18 days after, found a small island 12 feet high, with a crater in its center, throwing forth volcanic matter in immense columns of vapor, the sea around being covered with floating cinders and dead fish. The eruption continued with great violence to the end of the same month. By the end of the month the island grew to 90 feet in height, and measured 3/4 of a mile round. By August 4th it became 200 feet high and 3 miles in circumference, after which it began to diminish in size by the action of the waves. Towards the end of October the island was leveled nearly to the surface of the sea. Naval officers and foreign ministers alike took an absorbing interest in this new island. The strong national thirst for territory manifested itself, and eager mariners waited only till the new land should be cool enough to set foot on to strive who should be first to plant there his country's flag. Names in abundance were given it by successive observers: Deschnerita, Siaca, Fernandina, Julia, Hotham, Corau, and Graham. The last holds good in English speech, and as Graham's Island it is known in books today, though the sea took back what it had given, leaving but a shoal of cinders and sand. The Bay of Santorin, in the island of that name, which lies immediately to the north of Crete, has long been noted for its submarine volcanoes. According to one account, indeed, the whole island was at a remote period raised from the bottom of the sea, but this is questionable. It is, with more reason, supposed that the bay is the site of an ancient crater, which was situated on the summit of a volcanic cone that subsequently fell in. Certain it is that islands have from time to time been thrown up by volcanic forces from the bottom of the sea within this bay, and that some of them have remained, while others have sunk again. How an island grew. Of the existing islands, some were thrown up shortly before the beginning of the Christian era, in particular, one called the Great Calamity, which, however, received a considerable accession to its size by a fresh eruption in AD 726. The islet nearest Santorin was raised in 1573, and was named the Little Calamity, and in 1707 there was added, between the other two, a third, which is now called the Black Island. This made its appearance above water on the 23rd of May, 1707, and was first mistaken for a wreck. But some sailors, who landed on it, found it to be a mass of rock, consisting of a very white soft stone, to which were adhering quantities of fresh oysters. While they were collecting these, a violent shaking of the ground scared them away. During several weeks the island gradually increased in volume. But in July, at a distance of about 60 paces from the new islet, there was thrown up a chain of black calcined rocks, followed by volumes of thick black smoke, having a sulfurous smell. A few days thereafter the water all around the spot became hot, and many dead fishes were thrown up. Then, with loud subterraneous noises, flames arose, and fresh quantities of stones and other substances were ejected, until the chain of black rocks became united to the first islet that had appeared. This eruption continued for a long time, there being thrown out quantities of ashes and pumice, which covered the island of Santorin and the surface of the sea, some being drifted to the coasts of Asia Minor and the Dardanelles. The activity of this miniature volcano was prolonged, with greater or less energy, for about 10 years. In 1866 similar phenomena took place in the Bay of Santorin, beginning with underground sounds and slight shocks of earthquake, which were followed by the appearance of flames on the surface of the sea. Soon after there arose, out of a dense smoke, a small islet, which gradually increased until in a week's time it was 60 feet high, 200 long, and 90 wide. The people of Santorin named it George, in honor of the King of Greece. In another week it joined and became continuous with the Little Calamity. The detonations increased in loudness, and large quantities of incandescent stones were thrown up from the crater. About the same time, at the distance of nearly 150 feet from the coast, to the westward of a point called Cape Flego, there rose from the sea another island, to which was given the name of Aphroessa. It sank and reappeared several times before it established itself above water. The detonations and ejection of incandescent lava and stones continued at intervals during 3 weeks. From the crater of the islet George, which attained a height of 150 feet, some stones several cubic yards in bulk were projected to a great distance. One of them, falling on board of a merchant vessel, killed the captain and set fire to the ship. By the 10th of March the eruptions had partially subsided, but were then renewed, and a third island, which was named Rika, rose alongside of Afro-Essa. They were at first separated by a channel 60 feet deep, but in 3 days this was filled up, and the two islets became united. Reference may properly be made here to Monte Nuovo and Jorallo. Not that they appertain to the present subject, but that they form examples of the action of similar forces. In the one instance exerted on a lake bottom, in the other on dry land, each yielding permanent volcanic elevations in every respect analogous to those which rise as islands from the bottom of the sea. In the Icelandic seas. Off the coast of Iceland, islands have appeared during several of the volcanic eruptions which that remote dependency of Denmark has manifested. And at various periods in Iceland's history the sea has been covered with pumice and other debris, which tell their own tale of what has been going on, without being in sufficient quantity to reach the surface in the form of an island mass. The sea off Reykjanes Smoky Cape, as the name means, has been a frequent scene of these submarine eruptions. In 1240, during what the Icelandic historians describe as the Eighth Outburst, a number of islets were formed, though most of them subsequently disappeared, only to have their places occupied by others born at a later date. In 1422 high rocks of considerable circumference appeared. In 1783, about a month before the eruption of Skaptur Jökull, a volcanic island named Njö, from which fire and smoke issued, was built up. But in time it vanished under the waves, all that remains of it today being a reef from 5 to 35 fathoms below the sea level. In 1830, after several long-continued eruptions of the usual character, another isle arose. While at the same time the skerries known as the Geirfuglaska disappeared, and with them vanished the great auks, or Geirfowls, birds now extinct, which up to that time had bred on them. At all events, though the auks could not well have been drowned, no traces of them were seen after the date mentioned. In July 1884, an island again appeared about 10 miles off Reykjanes, but it is already beginning to diminish in size, and may soon disappear. Off the coast of Alaska. Elsewhere in the region of the northern seas there are other instances of the influence of the submarine forces in raising up and lowering land. The coast of Alaska is a region of intense volcanic action. In 1795, during a period of volcanic activity in the craters of Makushina, on Unalaska, and in others on Umnak Island, a volume of smoke was seen to rise out of the sea about 42 miles to the north of Unalaska. And the next year it was followed by a heap of cindery material, from which arose flame and volcanic matter, the glow being visible over a radius of 10 miles. In 4 years the island grew into a large cone, 3,000 feet above the sea level, and 2 or 3 miles in circumference. 2 years later it was still so hot that when some hunters landed on it they found the soil too warm for walking. It was named Iona Bogoslova, St. John the Theologian, by the Russians, Agashagok by the Aleuts, and is now known to the whites of that region as Bogoslav. Mr. Dahl believes that it occupies the site of some rocks that existed there as long as tradition extends. There were additions to the cone up to the year 1823, when it became so quiescent as to be the favorite haunt of seals and seafowls, and, when the weather was favorable, was visited by native egg hunters from Unalaska. During the summer of 1883 Bogoslav was again seen in eruption, as it was thought. However, on closely examining the neighborhood, it was found that the old island was undisturbed, but that there had been a fresh eruption, which had resulted in the extension of Bogoslav by the appearance of a cone and crater, Hegvialkano, 357 feet high, connected with the parent island by a low sandspit, and situated in a spot where, the year before, the lead showed 800 fathoms of water. At the same time Augustine and 2 other previously quiet islands on the peninsula of Alaska began simultaneously to emit smoke, dust, and ashes, while a reef running westward and formerly submerged became elevated to the sea surface. Other islands, of origin exactly similar to Bogoslav and those mentioned, are to be found in this region, notably Koniagi and Kazatakai, in the western Aleutians, and Pinnacle Island, near St. Matthew Island. Indeed, the volcano of Klyochevsk, which rises to a height of over 15,000 feet, is really a volcanic island. A permanent addition was made to the Aleutian group of islands by the action of a submarine volcano in 1806. This new island has the form of a volcanic peak, with several subsidiary cones. It is 4 geographical miles in circumference. In 1814 another arose out of the sea in the same archipelago, the cone of which attained a height of 3,000 feet, but at the end of a year it lost a portion of this elevation. In 1856, in the sea in the same neighborhood, Captain Newell, of the whaling bark Alice Fraser, witnessed a submarine eruption, which was also seen by the crews of several other vessels. There was no island formed on this occasion, but large jets of water were thrown up, and the sea was greatly agitated all around. Then followed volcanic smoke, and quantities of stones, ashes, and pumice, the two latter being scattered over the surface of the sea to a great distance. Loud thundering reports accompanied this eruption, and all the ships in the neighborhood felt concussions like those produced by an earthquake. These phenomena seem to have ended in the formation of some great submarine chasm, into which the waters rushed with extreme violence in a terrific roar. Occurrences similar to this last have been several times observed in a tract of open sea in the Atlantic, about half a degree south of the equator, and between 20 and 22 degrees of west longitude. Although quantities of volcanic dross have been from time to time thrown up to the surface in this region, no island has yet made its appearance above water. The events here described repeat on a far smaller scale similar ones which have occurred in remote ages in many parts of the ocean and left great island masses as the permanent effects of their work. We may instance the Hawaiian group, which is wholly of volcanic origin, with the exception of its minor coral additions, and represents a stupendous activity of underground agencies beneath the domain of Father Neptune. In part, as we have said elsewhere in this work, all oceanic islands, remote from those in the shoal-bordering waters of the continents, have been of volcanic or coral formation, or more often a combination of the two. No sooner does an island mass appear above or near the surface of tropical waters than the minute coral animals effective only by their myriads begin their labors, building fringes of coral rock around the cindery heaps lifted from the ocean floor. The atolls of the Pacific circular or oval rings of coral with ligands of seawater within have long been thought to be built on the rims of submarine volcanoes. Rising to within a few hundred feet of the surface, much as coral reefs around actual islands. If the volcanic mass should subsequently subside, as it is likely to do, the minute ocean builders will continue their work unless the subsidence be too rapid for their powers of production, and in this way ring-like islands of coral may in time rise from great depths of sea. Their basis being the volcanic island which has sunk from near the surface far toward old ocean's primal floor. Chapter XXXI. Mud volcanoes, geysers, and hot springs. Our usual impression of a volcano is indicated in the title of burning mountain. So often employed, a great fire-spouting cone of volcanic debris, from which steam, lava, rock masses, cinder-like fragments, and dust, often of extreme fineness, are flung high into the air or flow in river-like torrents of molten rock. This, no doubt, applies in the majority of cases, but the volcanic forces do not confine themselves to these magnificent displays of energy, nor are their products limited to those above specified. We have seen that mud is a not uncommon product, due to the mingling of water with volcanic dust, while water alone is occasionally emitted, of which we have a marked instance in the Volcán de Agua, of Guatemala, already mentioned. As regards mud flows, we may specially instance the first outflow from Mont Pelee, that by which the Garin sugar works were overwhelmed. The imprisoned forces of the earth have still other modes of manifestation. A very frequent one of these, and the most destructive to human life of them all, is the earthquake. Minor manifestations of volcanic action may be seen in the geyser and the hot spring, the latter the most widely disseminated of all the resultant effects of the heated condition of the Earth's interior. It is these displays of subterranean energy, differing from those usually termed volcanic, yet due to the same general causes, that we have next to consider. And it may be premised that their manifestations, while, except in the case of the earthquake, less violent, are no less interesting, especially as the minor displays are free from that peril to human life which renders the major ones so terrible. While the largest volcanoes at times pour out rivers of liquid mud, there are volcanoes from which nothing is ever ejected but mud and water, the latter being generally salt. From this circumstance they are sometimes called salzas, but they are more generally termed mud volcanoes. Some varieties of them throw out little else than gases of different sorts, and these are called air volcanoes. The Great Mud Volcano of Sicily. One of the best known mud volcanoes is at Macaluba, near Girgenti, in Sicily. It consists of several conical mounds, varying from time to time in their form and height, which ranges from 8 to 30 feet. From orifices on the tops of these mounds there are thrown out sometimes jets of warmish water and mud mixed with bitumen, sometimes bubbles of gas, chiefly carbonic acid and carburet hydrogen, occasionally pure nitrogen. The mud ejected has often a strong sulfurous smell. The jets in general ascend only to a moderate height, but occasionally they are thrown up with great violence, attaining a height of about 200 feet. In 1777 there was ejected an immense column, consisting of mud strongly impregnated with sulfur and mixed with naphtha and stones, accompanied also by quantities of sulfurous vapors. This mud volcano is known to have been in action for 15 centuries. Very recently a small mud volcano has been formed on the flanks of Mount Etna. It began with the throwing up of jets of boiling water, mixed with petroleum and mud, great quantities of gas bubbling up at the same time. In several of the valleys of Iceland there are similar phenomena, the boiling water and mud being thrown up in jets to the height of 15 feet and upwards, the mud accumulating around the orifices whence the jets arise. A mud volcano named Korabatov, in the Crimea, presents phenomena more akin to those of the igneous volcanoes of South America. There was an eruption from this mountain on the 6th of August, 1853. It began by throwing up from the summit a column of fire and smoke, which ascended to a great height. This continued for 5 or 6 minutes, and was followed at short intervals by 2 similar eruptions. There was then ejected with a hissing noise a quantity of black fetid mud, which was so hot as to scorch the grass on the edges of the stream. The mud continued to pour out for 3 hours, covering a wide space at the mountain's base. The mud volcanoes on the coast of Baluchistan are very numerous, and extend over an area of nearly 1,000 square miles. Their action resembles that at Macaluba. The mud volcano of Java. There is a mud volcano in Java which is of interest as somewhat resembling the geyser in its mode of operation and apparently due to similar agencies. It is thus described by Dr. Orfield Dash. On approaching it from a distance, it is first discovered by a large volume of smoke, rising and disappearing at intervals of a few seconds, resembling the vapors rising from a violent surf. A loud noise is heard, like that of distant thunder. Having advanced so near that the vision was no longer impeded by the smoke, a large hemispherical mass was observed, consisting of black earth mixed with water, about 16 feet in diameter, rising to the height of 20 or 30 feet in a perfectly regular manner, and as if it were pushed up by a force beneath, which suddenly exploded with a loud noise, and scattered about a volume of black mud in every direction. After an interval of 2 or 3, or sometimes 4 or 5 seconds, the hemispherical body of mud rose and exploded again. In the manner stated, this volcanic ebullition goes on without interruption, throwing up a globular body of mud, and dispersing it with violence through the neighboring plain. The spot where the ebullition occurs is nearly circular, and perfectly level. It is covered only with the earthy particles, impregnated with salt water, which are thrown up from below. The circumference may be estimated at about half an English mile. In order to conduct the salt water to the circumference, small passages or gutters are made in the loose muddy earth, which lead to the borders, where it is collected in holes dug in the ground for the purpose of evaporation. The mud has a strong, pungent, sulfurous smell, resembling that of mineral oil, and is hotter than the surrounding atmosphere. During the rainy season, the explosions increase in violence. There are submarine mud volcanoes as well as those of igneous kind. In 1814, one of this character broke out in the Sea of Azov, beginning with flame and black smoke, accompanied by earth and stones, which were flung to a great height. 10 of these explosions occurred, and, after a period of rest, others were heard during the night. The next morning there was visible above the water an island of mud some 10 feet high. A very similar occurrence took place in 1827, near Baku, in the Caspian Sea. This began with a flaming display and the ejection of great fragments of rock. An eruption of mud succeeded. A set of small volcanoes discovered by Humboldt in Turbaco, in South America, confined their emissions almost wholly to gases, chiefly nitrogen. There is a close connection in character between mud volcanoes and those intermittent boiling springs named geysers. A good many of the mud volcanoes throw out jets of boiling water along with the mud. But in the case of the geysers, the boiling water is ejected alone, without any visible impregnation, though some mineral in solution, as silica, carbonate of lime, or sulfur, is usually present. The geyser is a water volcano. The phenomenon of the geyser serves in a measure to support the theory that steam is an important agent in volcanic action. A geyser, in fact, may be designated as a water volcano, since it throws up water only. It comprises a cone or mound, usually only a few feet high. In the middle of this is a crater-like opening with a passage leading down into the earth. As in the case of the volcano, the geyser cone is built up by its own action. In the boiling water which is ejected there is dissolved a certain amount of silica. As the water falls and cools, this mineral is deposited, gradually building up a cup-like elevation. The basin of the geyser is generally full of clear water, with a little steam rising from its surface, but at intervals an eruption takes place, sometimes at regular periods, but more often at irregular intervals. Among the largest and best-known geysers in the world are those of Iceland, chief among them being the Great Geyser. Silica is the mineral with which the waters of this fountain are impregnated, and the substance which they deposit, as they slowly evaporate, is named siliceous cinder. Of this material is composed the mound, 6 or 7 feet high, on which the spring is situated. On the top of the mound is a large oval basin, about 3 feet in depth, measuring in its larger diameter about 56, and in its shorter about 46 feet. The center of this basin is occupied by a circular well about 10 feet in diameter, and between 70 and 80 feet deep. Out of the central well springs a jet of boiling water, at intervals of 6 or 7 hours. When the fountain is at rest, both the basin and the well appear quite empty, and no steam is seen. But on the approach of the moment for action, the water rises in the well, till it flows over into the basin. Then loud subterranean explosions are heard, and the ground all round is violently shaken. Instantly, and with immense force, a steaming jet of boiling water, of the full width of the well, springs up, and ascends to a great height in the air. The top of this large column of water is enveloped in vast clouds of steam, which diffuse themselves through the air, rendering it misty. These jets succeed each other with great rapidity to the number of 16 or 18, the period of action of the fountain being about 5 minutes. The last of the jets generally ascends to the greatest height, usually to about 100, but sometimes to 150 feet. On one occasion it rose to the great height of 212 feet. Having ejected this great column of water, the action ceases, and the water that had filled the basin sinks down into the well. There it remains till the time for the next eruption, when the same phenomena are repeated. It has been found that by throwing large stones into the well, the period of the eruption may be hastened, while the loudness of the explosions and the violence of the fountain effect are increased, the stones being at the same time ejected with great force. Eruption can be induced by artificial means. Geysers are found all over the island, presenting various peculiarities. In the case of one of the smaller ones, which is called Stryker, or the churn, an eruption can be induced by artificial means. A barrel load of sods is thrown into the crater of the geyser, with the effect of causing an eruption. The sensitiveness of Strucker is due to its peculiar form. An observer states that the bore is 8 feet in diameter at the top, and 44 feet deep. Below 27 feet it contracts to 19 inches, so that the turf thrown in completely chokes it. Steam collects below, a foaming scum covers the surface of the water, and in a quarter of an hour it surges up the pipe. The fountain then begins playing, sending its bundles of jets rather higher than those of the great geyser, flinging up the clods of turf which have been its obstruction like a number of rockets. This magnificent display continues for a quarter of an hour or 20 minutes. The erupted water flows back into the pipe from the curved sides of the bowl. This occasions a succession of bursts, the last expiring effort, very generally, being the most magnificent. Strucker gives no warning thumps, like the great geyser, and there is not the same roaring of steam accompanying the outbreak of the water. The same author thus describes an eruption of the great geyser, which occurred about 2 o'clock in the morning. A violent concussion of the ground brought me and my companions to our feet. We rushed out of the tent in every condition of dishabille and were in time to see geyser put forth his full strength. 5 strokes underground were the signal, then an overflow, wetting every side of the mound. Presently a dome of water rose in the center of the basin and fell again, immediately to be followed by a fresh bell, which sprang into the air fully 40 feet high, accompanied by a roaring burst of steam. Instantly the fountain began to play with the utmost violence. A column rushing up to the height of 90 or 100 feet against the gray night sky, with mighty volumes of white steam cloud rolling after it and swept off by the breeze to fall in torrents of hot rain. Jets and lines of water tore their way through the clouds, or leaped high above its domed mass. The earth trembled and throbbed during the explosion, then the column sank, started up again, dropped once more, and seemed to be sucked back into the earth. We ran to the basin, which was left dry, and looked down the bore at the water, which was bubbling at the depth of 6 feet. In the case of Strucker, the cause of this eruption is not difficult to understand. The narrow part of the channel is choked up by the turf and the steam, and prevented from escaping. Finally it gains such force as to drive out the obstacle with a violent explosion, just as a bottle of fermenting liquor may blow out the cork and discharge some of its contents. Geysers are somewhat abundant phenomena, existing in many parts of the earth, while striking examples of them are found in the widely separated regions of Iceland, New Zealand, Japan, and the western United States. In the volcanic region of New Zealand, geysers and their associated hot springs are abundant. It was to their action that we owed the famous white and pink terraces and the warm lake of Rotomehana, which were ruined by the destructive eruption of Mount Terrara, already described. Geysers of the United States. The United States is abundantly supplied with hot springs, but geysers, outside of the Yellowstone region, are found only in California and Nevada. Those of California exist chiefly in Napa Valley, north of San Francisco, in a canyon or defile. Their waters are impregnated not with silica, but with sulfur, and they thus approach more nearly in their character to mud volcanoes, whose ejections are, in like manner, much impregnated with that substance. They are also, like them, collected in groups, there being no less than 100 openings within a space of flat ground a mile square. Owing to their number and proximity, their individual energy is nothing like so violent as that of the geysers of Iceland. Their jets seldom rise higher than 20 or 30 feet, but so great a number playing within so confined a space produces an imposing effect. The jets of boiling water issue with a loud noise from little conical mounds, around which the ground is merely a crust of sulfur. When this crust is penetrated, the boiling water may be seen underneath. The rocks in the neighborhood of these fountains are all corroded by the action of the sulfurous vapors. Nevertheless, within a distance of not more than 50 feet from them, trees grow without injury to their health. Few of these fountains, however, are regular geysers, most of them discharging only steam. From the steamboat geyser this ascends to a height of from 50 to 100 feet, with a roar like that of the escape from a steamboat boiler. Associated with the geysers are numerous hot springs, some clear, some turbid, and variously impregnated with iron. sulfur or alum. In Nevada, the Steamboat Springs, as they are designated, exist in Washoe Valley, east of the Virginian Range. They come nearer in character to the Yellowstone geysers, their waters depositing true geyserite, or siliceous concretions. The Volcano Springs, in Lauder County, are also true geysers, though of small importance. The ground here is so thickly perforated by holes from which steam escapes that it looks like a colander. The Yellowstone Geysers. The most remarkable geyser country in the world, alike for the size and the number of its spouting fountains, is the Yellowstone region in the northwest part of the territory of Wyoming, in the United States, which, by a special act of Congress, has been reserved as the Yellowstone National Park, exempt from settlement, purchase, or preemption. Here nearly every form of geyser and unintermittent hot spring occurs, with deposits of various kinds, siliceous, calcareous, etc. Of the hot springs, Dr. Peel enumerates 2,195, and considers that within the limits of the park, which is about 54 miles by 62 miles, and includes 3,312 square miles, as many as 3,000 actually exist. The same geologist notes the existence of 71 geysers in the area mentioned, though some of the number are only inferred to be spouting springs from the form of their basins and the character of the surrounding deposits. Of this vast collection of still and eruptive springs, between which there seems every gradation, those which do not send water into the air are, owing to the magnificent cascades which they form, often quite as remarkable as those which take the shape of geysers. The more striking of the latter may, however, be briefly mentioned. In the Gibbon Basin is a geyser of late origin. In 1878 this consisted of two steam holes, roaring on the side of a hill, that looked as if they had recently burst through the surface. And the gully leading towards the ravine was at that date filled with sand, which appeared to have been poured out during an eruption. Dead trees stood on the line of this sand floor, and others, with their bark still remaining, and even with their foliage not lost, were uprooted hard by, everything indicating that the steamboat vent, as it was called, was of recent formation. In 1875 it had no existence, but in 1879 the spouting spring which first opened, it is believed, on the 11th of August in the preceding year had settled down to business as a very powerful flowing geyser, with a double period. One eruption occurring every half hour, and projecting water to the height of 30 feet, the main eruption occurring every 6 or 7 days, with long continued action, and a column of nearly 100 feet. The new geyser in the same basin is also of quite recent origin. It consists of two fissures in the rock, in which the water boils vigorously. But there is no mound, and the rocks of the fissure are just beginning to get a coating of the siliceous geyserite deposited from the water, so that it cannot long have been spouting. Again, in the Grotto Geyser in the upper geyser basin of Firehole River, the main or larger crater is hollowed into fantastic arches, beneath which are the grotto-like cavities from which it is named, which act as lateral orifices for the escape of water during an eruption. It plays several times in the course of the 24 hours, and sends a column of water 60 feet high, the eruption lasting an hour. As yet, however, the force of the water has not been sufficient, or of sufficiently long duration, to break through the arches covering the basin or crater. The Excelsior claimed to be the largest of its order, which sent water nearly 300 feet into the air at intervals of about 5 hours, and of such volume as to wash away bridges over small streams below, was not, until comparatively recent years, known as a specially powerful geyser. But if it had for a time waned in importance, its immense crater, 330 feet in length and 200 feet at the widest part, shows that at a still earlier date it was a gigantic fountain. In this deep pit, when the breeze wafted aside the clouds of steam constantly arising from its surface, the water could be seen seething 15 or 20 feet below the surrounding level. Yet into the cauldron of boiling water a little stream of cold water, from the melting snow of the uplands, ran unceasingly. Since 1888 this great geyser has been inactive. The Castle Geyser is so named on account of the fancied resemblance which its mound of white and gray deposit presents to the ruins of a feudal keep. The crater itself being placed on a cone or turret, which has a somewhat imposing appearance compared with the other geysers in the neighborhood. It throws a column usually about 50 or 60 feet high, at intervals of 2 or 3 hours, but sometimes the discharge shoots up much higher. The giant, in the upper geyser basin, has a peculiar crater, which has been likened to the stump of a hollow sycamore tree of gigantic proportions, whose top has been wrenched off by a storm. This curious cup is broken down at one side, as though it had been torn away during an eruption of more than ordinary violence, and on this side the visitor is able to look into the crater, if he can contrive to avoid the jets which are constantly spouted from it. The periods of rest which it takes are varied, an eruption often not occurring for several days at a time, yet when it breaks out it continues playing for more than 3 hours, with a volume of water reaching a height of from 130 to 140 feet. In the interval little spouts are constantly in progress. Mr. Stanley saw one eruption which he calculated to have shot a column of water to the height of more than 200 feet. At first it seemed as though the geyser was only making a feint, the discharge which preceded the great one being merely repeated several times, followed by a cessation both of the rumbling noises and of the ejection of water. But soon, after a premonitory cloud of steam, the geyser began to work in earnest, the column discharged rising higher and higher, until it reached the altitude mentioned. At first it appeared to labor in raising the immense volume, which seemed loath to start on its heavenward tour. But it was with perfect ease that the stupendous column was held to its place, the water breaking into jets and returning in glittering showers to the basin. The steam ascended in dense volumes for thousands of feet, when it was freighted on the wings of the winds and borne away in clouds. The fearful rumble and confusion attending it were as the sound of distant artillery, the rushing of many horses to battle, or the roar of a fearful tornado. It commenced to act at 2 p.m., and continued for an hour and a half, the latter part of which it emitted little else than steam, rushing upward from its chambers below, of which, if controlled, there was enough to run an engine of wonderful power. The waving to and fro of such a gigantic fountain, when the column is at its height, tinseled o'er in robes of varying hues, and glistening in the bright sunlight, which adorns it with the glowing colors of many a gorgeous rainbow, affords a spectacle so wonderful and grandly magnificent, so overwhelming to the mind, that the ablest attempt at description gives the reader who has never witnessed such a display but a feeble idea of its glory. A description of the geyser at work. The only other geysers in this remarkable geyserland which we can spare room to notice are those known as the Giantess, the Beehive, and the Grand. The Giantess sends a column of water to the height of 250 feet. An eruption is usually divided into 3 periods, 2 preliminary efforts and a final one, divided from each other by intervals of between 1 and 2 hours, while the intervals of discharge are very long. Sometimes it does not play for several weeks. The Beehive, which is 400 feet from the Giantess, gets its name from the peculiar beehive-like cone which it has formed. The eruption is also almost unique. It is heralded by a slight escape of steam, which is followed by a column of steam and water, shooting to the height of over 200 feet. The column is somewhat fan-shaped, but it does not fall in rain, the spray being evaporated and carried off as steam if, indeed, there is not more steam than water in the column. The duration of the discharge is between 4 and 5 minutes, and the interval between 2 eruptions from 21 to 25 hours. The Grand is one of the most important in the upper geyser basin. Yet, unlike the Grotto, the Giant, or the Old Faithful, so called from its frequent and regular eruptions, it has no raised cone or crater, and a much less cavernous bowl than the Giantess and other geysers. The column discharged ascends to the height of from 80 to 200 feet, and the eruptions last from 15 minutes to 3/4 of an hour, with intervals on an average of from 7 to 20 hours. This fountain is apparently very irregular in its action, though it is just possible that when the Yellowstone geysers have been more consecutively studied, it will be found that these seeming irregularities depend on the varying supplies of water at different times of the year. The Mammoth Hot Springs. The marvelous phenomena of the Yellowstone region are not confined to geyser action, hot springs of steady flow being, as above stated, exceedingly numerous. Of these, the most striking are those known as the Mammoth Hot Springs, whose waters find their way through underground passages, finally flowing from an opening as the Boiling River, which empties into the Gardner River. These springs are marvels of beauty. Their terraced bowls, adorned with delicate fretwork, are among the finest specimens of nature's handiwork in the world, and the colored waters themselves are startling in their brilliancy. Red, pink, black, canary, green, saffron, blue, chocolate, and all their intermediate gradations are found here in exquisite harmony. The springs rise in terraces of various heights and widths, having intermingled with their delicate shades chalk-like cliffs, soft and crumbly, these latter being the remains of springs from which the life and beauty have departed. The Great Spring is the largest in the country, the water flowing through 3 openings into a basin 40 feet long by 25 feet wide. From this, the hot mineral waters drip over into lower basins, of gracefully curved and scalloped outline, the minerals deposited on the lips of the basin forming stalagmites of variegated hue, yielding a brilliant and beautiful effect. The terraced basins bear a close resemblance to the former New Zealand pink and white terraces, and since the annihilation of the latter are the most charming examples in existence of this rare form of nature's artistic handiwork.